One, two. Good morning, everyone. Can we start? If you can take our seats so we can start our session today. I want to greet you this morning and welcoming you to day 2 of the 14th Oppenheimer Research Conference. Just some few rules as we start. Please remember to put your cell phone on silent or off so that you don't disturb the flow of the conference. Wi-Fi is available. There's no password. It's called ORC 2025. Please note the location of the restrooms. If you haven't seen them already, you go out and then turn to the left. We have also gifted you with a travel mug in your bag. Can you please use it to refill water from the various water dispensers that are around the room? We've also provided you with recycle bins. Please recycle all your use the trash. And then mobile phone charge points are also located around the auditorium. You can also charge your cell phone. In the unlikely event of an emergency, the assembly point markers have been put on your way out of the auditorium. So you just follow those markers. Medics are also on duty here. So for the entire conference. So if you need some first aid or some medical attention, you can also go to their place. And then smoking is strictly forbidden, except in the designated area outside outside where there's the grass side, this side. And then finally, we have a wonderful and very full program. So we ask all the presenters today to stick to the time. This morning, we are going to start with a plenary session by Deft Weston, and then we have speed talks, 5-minute speed talks, and then we will conclude with a poster session. Okay, so Deft Weston, a PhD graduate of the University of Nairobi, began his research and conservation work in Amboseli in 1967, looking at human-wildlife interactions, and since then he has published a lot of work in that area, over 300 published articles and lots of books. He is the former director of the Kenya Wildlife Service and also led the Wildlife Conservation Society program internationally. He chaired the African Elephant and Rhino Specialist Group, was also the founding president of the International Ecotourism Society and founder of the African Conservation Center in Nairobi. So today, is going to give us a talk on linking wildlife, conservation, and people across landscapes. Deft Weston, thank you.
Good morning. Hamjambo. Your response should be Hatujambo. I want to express my special thanks to the Oppenheimer conveners. I have long wanted to come to this conference. I have to say you allowed my wife to beat me to it, but here I am. What I want to talk about today, if we can start the first slide, is how do you go from a local conservation enterprise to link across entire landscapes and conserve the biodiversity of an entire region? Look at this picture very closely. And I want to ask what you see. You see wildlife. And this is what the colonial governments first saw when they came into Eastern Africa. They saw this wealth of wildlife, and they asked one question: how is it that such an extraordinary variety of animals exists in such a dry place? Recognizing that mega wildlife had been exterminated around most of the world. Now, I grew up in Tanzania before national parks were even established. And to me, people and wildlife living together was the natural scene. When the first parks were set up, when I was very young, they excluded people from the very areas where people had coexisted. So as a young graduate student at the University of Nairobi in 1967, I looked to this one peculiar area, which has some of the most rich and iconic wildlife in Africa, Amboseli. And this is the scene that I saw. This is the enigma I want you to think about. Why is it, despite that we as a species co-evolved and emerged with the mega mammals, did not wipe them out in Africa? This is the African enigma we have to explain, and I'll come back to the end. This is the heritage which is very peculiar to Africa and which is the hallmark of our conservation. If you look at that picture, you'll see a wide variety of animals. What you don't see is way, way in the background, a herd of cattle. Now, this is the scene that the visitor coming into any national park in Africa sees today: a wealth of wildlife, a place without people. Now I want to show you the scene that I see and I saw growing up. People everywhere. And this is the most extraordinary scene you can see in East Africa. Here's a Maasai herding cattle. Next to him, zebra and wildebeest, buffalo, elephant, and so on, all in incredibly close proximity. Now, what explains this coexistence? How is it they're able to coexist? And to my mind, in going to Amboseli, which was not just a national park, was this question: do we really need parks? Can we conserve wildlife without parks? And my view was that, yes, we need parks. Had we not conserved some of those critical populations when they were conserved, they would have disappeared long ago. But we now know, as biologists, and I was very involved in the conservation biology at its very beginnings, and I asked one question: where do humans fit into this picture? Surely, if humans are the problem, humans are also the solution. And so this is what I set out to do in Amboseli, to answer that very question. And so the first thing I did was ask the Maasai themselves how it is they coexisted with wildlife. And they said something which was very prophetic. They said, unless you own cattle with us and herd cattle with us, you will never understand Amboseli. You have to see it through the eyes of a cow. So that's what I did throughout much of my career. I was both a herder, trying to understand Amboseli and how the Maasai saw it, and I was a biologist, trying to see it from the outside. So the message I'm going to put across today is that we have to see all these areas from the inside, from the view of the people who live with wildlife, but also we have to take this big external view as well, because many of the threats we face today are entirely new and outside the experience of people on the ground. So for the Amboseli monitoring program, I began in 1967, where there was almost no theory biologically about how ecosystems work. So I set out to measure every single thing I could: plants, animals, people, livestock, everything else. And I began to involve local resource assessors. These are Maasai from the ground who are taking over my monitoring every single aspect of that, and then feeding back that information to their own community. I also recognize that we have to set up local and national capacity. So in the 1980s, I set up the African Conservation Center, which has now trained over 35 to 40 Kenyans and other people from around Africa in conservation biology, and PhDs, MScs, and so forth. And those people today, like Lucy Warawengi, who would have attended this meeting today, director of the African Conservation Center, have occupied almost every single major position in Kenya today. We also have to look at how traditional people manage the land, how they managed it over 4,000 years of pastoralism in East Africa, and yet did not degrade the land to any great extent, and still coexisted without any major extinctions. That comes back to how people manage large areas of land. And finally, in this day and age, whether it's a national park, whether it's conservancy, none is an island. We have to collaborate at many, many different levels. And this is the message I'll be putting across today. So let me go back very briefly to Amboseli. I tried to figure out where the migrations moved, what range they moved, and so on. And the area in red defines the Amboseli ecosystem. Those dots, or other triangles in red, define settlements. So you can see that from the wetter areas, these dry lowland areas, which are the peak of our wildlife, are being enclosed. So I'm going to look particularly within the Amboseli area and ask how it is that those migrations have sustained themselves and how people fit in. We set up what we call a hierarchical monitoring system. We start from the very low level. We have permanent plots on the ground of 300 square meters, which every single month, David Maitumo, the resource assessors, measures how much grass there is, what the species richness is, how much they've been grazed down, and this is a critical point you'll see in a moment. Species diversity and what animals are using them. At the next highest level, I conduct aerial counts every single month of the total animals in the protected area. And then above that, we do an ecosystem-wide survey over 10,000 square kilometers every few months to every year or two to measure all wildlife, livestock, human activity, and so on. Then at the very high level, and this only came in the 1980s, satellite imagery opened a whole other new avenue for us, which allowed us to scale up. So I'm just going to run a few very quick pictures here of every single species we monitor and show how they're moving in time and space. And you'll see that applies to buffalo, cattle, wildebeest, and so on and so forth. This gives us what I call the rhythm of an ecosystem, seeing how animals move in time and space, how they're being contracted by settlement, and what effect that's having. I'm just going to show two pictures of two species, zebra at the top, which shows their wet season dispersal on the left-hand side, and their dry season concentration on the right-hand side. The bottom one is wildebeest, wet season distribution on the bottom left-hand side, and on the right-hand side, how much they're concentrated. Most of these animals, about 90%, are concentrating into a mere 10% of the ecosystem in the late dry season. So they become very vulnerable, and these are largely where our national parks are. So most of our national parks were set around the dry season concentration areas and ignored the importance of the migrations outside. Now I want to use another measure apart from the rhythm. We have to look at the big ecosystem processes, and this is the pulse of the system, rather like measuring your pulse. And you'll see that livestock and wildlife go up and down over time with droughts, with wet seasons, and so on and so forth. But the pulse of livestock is identical to the pulse of wildlife. Why? Because the gut fauna is the same for zebra and cattle. They get the same benefit by migrating and following the green flush. And on average, a wildebeest or a cow gets 40% greater digestive energy by following the green flush and the migrations. So that means they coexist. And the Maasai will say, wildlife is our second cattle. In times of drought, when we lose our own cattle, we fall back on wildlife as our second cattle. Now, being typical men, they say, cattle, wildlife used to belong to women. They went wild. They didn't look after them, so we, the men, now dominate the society. So my message in conservation is, if those were women's cattle, women have to be part of the conservation solution too. That gets a lot of laughs. The other point I want to make is, the more you compress an ecosystem, the more you compress time as well. So as you lose range, the seasons become shorter, and you're concentrating animals into the late dry seasons area faster and faster. I want to end up with one other point. There's a saying among the Maasai that elephants create grasslands, cattle create trees. And that's true. But what it creates is a big ecological minuet carried out over many decades, where elephants are opening up thickets here, creating grasslands, then livestock move in. Over here, Maasai are moving, grazing very heavily, and they're creating grasslands, and then cattle move in. So what I want to do is say, put together all of this information, the pulse and the reason of the system, every single species, and what you can come up with is a minimum viable conservation area for an ecosystem. You'll see the park in the center, which is in purple, which is where most animals concentrate. But those blue areas are the dispersal areas. The pink areas are the meta-ecosystems, which connects Amboseli to the Chulu Hills, where animals can migrate in drier periods, up to Kilimanjaro, where they can also migrate, or into Tanzania. So the meta-ecosystem is the resilience against droughts and climate change. I want to now come back to the local level and say the Maasai have been custodians of the land for generations. So I took on David Maitum on the left in the 1970s, and every single month he's measured grass height, biomass, greenness, grazing pressure, and so on. And this gives us a remarkable picture of the rhythm of the grasslands. So the picture you see on the top left is the actual biomass measured over 6 decades. And it'll show you how that biomass is going up and down and up and down. Obviously up during rains, down during droughts. But what is very typical is that there's beginning to be a change at about 1998. There's a switch point. That switch point is from when the migrations were free-ranging to when pastoralists became sedentary. And the moment they became sedentary, we see a decline in the productivity of the grasslands. I've got a picture on the bottom left-hand side which shows the condition of cattle. And you'll see in droughts, it goes down, and there's no milk yield left during the droughts. After the droughts, things begin to rebound. Then again, in the droughts of the 2023, we have another big decline in body condition, milk yields, market prices, which means that once it's dropped below a certain level, they can't even sell their cattle, and we're into a huge drought with an enormous impact. So what we do is we have a barometer which measures the condition and warns the community using those pictures down the bottom of good conditions, medium conditions, and severe conditions. And when it moves into the red, that warns the community that they are entering a drought similar to the experiences they've introduced in the past. This is the time to begin sell cattle, to begin thinking about paying for kids to stay in schools, and so on and so forth. So I'm just going to come to one final picture of Amboseli. What's driving these changes? Why the switch point in the 1980s? Sedentarization. Not subdivision of land yet, and you'll see the grazing pressure on the bottom part of the grass has gone from an average of about 25% grazing pressure up to about 60 to 75. In turn, the rainfall efficiency, the amount of grass produced per unit of rainfall has gone down 30%. So even before climate change, we're having a tremendous degradation of the grasslands. And this is the point I've been trying to make again and again and again about the African rangelands. We're facing something very similar to what the American Dust Bowl faced in the 1930s. When everyone lost their livelihoods, they had to move off the land, and there was tremendous degradation. So to finish off this picture, look at the seasonal cycle. If you look at the bottom graph, this is what the season would look like if it was driven by rainfall. The top one is your forage cycle. It's what's driven by your grazing pressure. And you'll see it's becoming more and more synchronized. We're going into recovery from droughts, but deeper and deeper and deeper droughts with bigger economic losses. So I'm going to now transition very quickly to say, how do we communicate this information back to the community? Victor Mose, who is my co-author on this program, will be telling you a lot more about this in the roundtable on Friday. We use platforms to collect the information that goes into cyberspace. It goes right back to the communities. Everyone has cell phones, and this information is available for them in telephones. That then goes back to the grazing committees. And I want to introduce a word in Maasai which has no equivalent in English. It's called eramatre. Now, eramatre, there's no word in Ma for conservation. What eramatre means is the health of the family is dependent on the health of the herd. And the health of the herd is dependent on the maintenance of those grasslands and always keeping reserve for the droughts. So we've resurrected the whole idea of the eramatre. We've resurrected the idea that wildlife were the second cattle, and you can now become the custodians of those areas once again. So that's led us into the idea of bringing together all the elders in Amboseli, and then inviting us, the NGOs, inviting governments, inviting the county council, saying, we want to sit down with you and come up with an ecosystem plan for the whole of Amboseli. So the park will be buffered by our land, our ecosystem, and we are participants in that. As a result of that, there was a payment for ecological services. Now, bear in mind, this is 1970s, which paid those landowners to conserve the migrations on their land. Secondly, A small area was retained for the county council to benefit from those revenues. But here's the most important thing. All those lodges in Amboseli today are outside the national park on community lands, where they're involved in the enterprises. The park is being spared that mass congestion of tourists which we normally get in the center of the park. That then parlayed into our national policy. I was asked to set up the Wildlife Planning Unit in the 1970s to incorporate the whole notion of both an ecosystem approach and a community-based conservation approach. And that's what we adopt now. So we want to finish up with what the Amboseli ecosystem looks like now. Green is the national park. All of the yellow areas are the conservancies they've set up. And then the orange areas are pastoral common wildlife areas, trying to maintain the open nature of the lands, both for the benefit of livestock, but also for wildlife. And then again, way down on the south, you'll see yellow. Those are zoned for agriculture. So every Maasai has a plot in agriculture, a settlement area, a pastoral area, and a share in the conservancies. So looking beyond parks, I was invited by the president in 1994 to take this Amboseli experiment and to scale it up. So the first thing I did is say we need to have legal provisions for landowners to have the rights to come into agreements with whoever they wish on how to conserve wildlife, to set up ecotourism operations, to access funds we set up, biodiversity conservation funds, tourism trust funds, and so on, to set up their own wildlife enterprises. Now, I'm very proud of that idea because we called it Parks Beyond Parks. There are now in Kenya today 250 conservancies, and they cover more than twice the area of all our national parks put together. And wherever a conservancy surrounds a park, those parks are doing much better than parks in isolation. We then asked the president to launch this whole approach and take a national-wide approach to selling it through the media, with the media present. That then led on to a final approach, which is ecosystem mapping, which I'll go on to now. If you look at the distribution of wildlife in the whole of the southern area, Amboseli would be somewhere there in the middle. You've got Tsavo on your right-hand side, you've got Mara on the left. How do we link across the whole of these landscapes? We set up the next level of organization called the Southern Rangeland Coalition, bringing together all these landowners across the landscape to form one coalition and saying, this is the richest wildlife area in Kenya. Promote and conserve that, work with your conservation partners, and you will benefit from conservation. Now, today in Mara, the landowners earn about 30% of their income from wildlife over and above their livestock, and they set aside their own conservancies. We then set up the Southern Rangeland Coalition, which, in order to deal with a lot of the big losses to livestock, set up a Livestock Producers Association, where they could have the political power to sell their own livestock at good prices. We set up the Kenya Rangeland Association to see what's the future of Kenya's rangelands in the transition from traditional pastoralism to modern economies, beef economies, people wanting to send their kids to school, and so on and so forth. We then have two major districts which cover all the way from Masai Mara to Amboseli, Kajiado and Narok. And they've set up an economic bloc, a common economic bloc, where they say, we've got two major assets, livestock and wildlife. And we, the Maasai, know they have coexisted, and that's their story. That's the Maasai story. So we want to have a circuit that connects all the way from Amboseli to Masai Mara, through the South Rift, which is where the South Rift Association of Landowners are, where you have the oldest fossil sites on Earth, Olikasali, where you have the greatest biodiversity, which I'll show in a moment, going from deserts all the way up to the escarpments and so on. But then we had to have national supporting institutions. And so we have the Kenya Wildlife Conservancy Association, we have the National Forum of NGOs and so on. So we've created these larger forums, which can work both with the landowners on the ground and can work with the governments in forming policy. So our policy is now a combination of bottom-up and top-down. So how do you scale up even further? The southern rangeland area is there in yellow on that side, left or right. This is the richest area of biodiversity, not just in Africa, but almost everywhere on Earth, and I'll show you that in the last slide. So how do we connect up all these parks, Serengeti, Mara, Mikumi, Amboseli, and so on and so forth? First of all, by setting up the Rangeland Coalition of Kenya, the Southern Rangeland Association. We then took a bolder step. We invited the Tanzanian government, the Kenyan government to sit down on Arusha and say, let's form a cross-border ecosystem. We then invited all the local communities to be represented, the NGOs, the donors, and so on. And in 2 days, we came up with what we call the Borderland Conservation Initiative, that we would have a structure working with all the partners to help conserve this big contiguous area. So here's the extraordinary thing. If you look at the picture on your right, the elephants are telling their own story. These are radio-tracked elephants saying, hey guys, these are the areas we need. This is the area you need to connect up. So elephant conservation, rhino conservation, all the large mammal conservation has now come up with a larger program for Kenya, and I'll show you that next, which is National Biodiversity Planning. In 2010, we held an international meeting to bring together all the landowners in Kenya, many others, and the conference was labeled Biodiversity, Land Use, and Climate Change. And guess what came out as the most important issue? Land use, because it was being degraded. And you can see from the previous graphs that I showed that the efficiency of rainfall is already declining, despite yet climate change. But it also means when climate change hits on our degraded lands, the impact is going to be even greater. So I'll finish up with, we've mapped all of biodiversity, the Biodiversity Atlas, and then under the presidential directive, Victor here is one of those people, we decided to replicate what Amboseli did and come up with a national mapping. So mapping all the main ecosystems, and they're shown here. You can see the productivity of those areas and where those ecosystems lie. So this is what we call the mini-max approach to conservation. What is the minimum area we can define which captures the maximum of biodiversity? And how in each one of those areas can we set up the governance of the landowners, the NGOs, the governments to conserve those ecosystems? So back to the bigger picture. If you look at the biodiversity of African mammals, you'll see these two great centers, like mountains standing out. The Albertine Rift on the left-hand side and the Gregory Rift on the right-hand side. We did some mapping, and what it shows in this nice, colorful map is the rich biodiversity areas. And you now see this whole program which we put together precisely overlays the biodiversity. But even more, it traverses all of the altitudes from deserts in Magadi all the way up to Kilimanjaro, which will insulate that area from climate change in the event that climate change becomes a driving factor. Because our parks are so isolated, they're all within the 500 to 700 millimeter band of rainfall, that if rainfall shifts one way or the other, we're going to have climate refugees who can't move anywhere. So I want to finish up with a larger message. I've heard a lot in this meeting that South Africa, Southern Africa, is one of the great centers of learning, of conservation, and collaboration. We say the same in East Africa. We're a great center of exactly those things. So my question for this conference is, why haven't we got together? We're looking at two aspects of the same thing. In East Africa, we're trying to conserve big open landscapes which have not yet been subdivided. In South Africa, you've gone through a long history of land privatization and isolation, and they're now putting back together those pieces. So surely, if we can put together the two pieces of those jigsaw puzzles and learn from each other and have exactly this sort of form we have today, we're going to be better off. So here's the final message. Everywhere I look, and I have to say, like Jane Goodall, who was a very good friend of mine, I'm an optimist because I've seen progress. I've seen communities come into conservation, become the custodians of conservation, realize that they have always been the custodians of conservation. I see what's going on in Kaza, the expansion of Kruger, the Greater Yellowstone Coalition. All over the world that I've been, I see the same thing happening. Parks are beginning to open up. How do they re-establish the wolf? How do they spread the bison? You see many of those species which should have gone extinct by all rights because we wiped them out in the past, beginning to come back and become icons of conservation. So I think we're in a really remarkable position. But I want to leave you with one question, which I've always asked about myself throughout my entire career. Why on earth are we the only species in all evolutionary history that has ever conserved other species? That question goes back to how it is and why it is that we coexisted with wildlife in Africa. And that's going to be our future too. Thank you.
Thank you. Thank you so much for that insightful talk. I've got time for one quick question. Anyone with a question? Yes, there. Every mind?
Asante sana, Jambumzi. I've lived in Kenya for a long time. I've been to all of those parks. I'm South African, and I'm wondering why I've never had the idea that we should be merging what we know with what East Africa does. So how would you suggest about going about that?
I was speaking to the publicity person of the organization today, and he said, look, we have a big divide. The Western world has created a dual vision of wildlife and people, wildlife out there and people here. We have been bedogged, quite frankly, by the Western world saying that we have to separate wildlife and people. That's not the African story. So my view is that what is missing is a voice from the community. Do you realize in social media, only 5% of the community ever gets a voice in the international media? It's all of us, and I include Jane Goodall as being the spokesman. We shouldn't be. So what I would suggest is that we get a small forum of people, which represents the managers, which represents the biologists, which represents the NGOs, and the animal rights and welfare groups, meeting with the communities and saying, what is it we're trying to achieve? How can we achieve this? What are the big unresolved issues? This is going to have to be a pluralistic approach. There is no one solution for conservation. We're going to have to accept that we have different solutions for different areas. But I would add this one point. Every single time I've met up with animal rights and welfare people, I have 90% agreement with them. I don't like seeing laboratory animals used for experimentation. But neither do I like seeing people killed, their crops destroyed, and their voice ignored.
Thank you. Thank you so much.
Thank you.
You can clap your hands. Thank you. Thank you. Next up, we have speed presenters. We just have a minute to remove the podium, and then we will continue with the speed presenters. Speed presenters, please, you'll be on stage during the presentations. Thank you. Nice last time. Job. Thank you. So we now have got our speed presenters. You have got 5 minutes to present, and then we have a Q&A session at the end when all of you have presented. So first, we have got a talk about most bioindicators from Antonio Razafin Rambo.
Thank you. Good morning, everyone. My name is Antonio, and I am a master student from the University of Antananarivo. I am pleased to present our ongoing research. Air pollution in Antananarivo is increasingly worrying, mainly due to vehicle emission, brickmaking, and seasonal forest burning, combined with global climate change. However, we know very little about how this affects biodiversity, especially on bryophytes. And our understanding of urban biodiversity and air quality remains limited in Madagascar. So my study aims to fill this gap. So what are bryophytes? They are non-vascular plants and have no roots. They absorb nutrients and water directly from the environment and thrive even in a polluted habitat. Their sensitivity makes them a powerful tool for monitoring atmospheric pollution. So this research had two main objectives. First, to describe bryophyte diversity, and second, to assess air pollution by measuring the bioaccumulation of potentially toxic elements in mosses tissues. Through this approach, we aim to develop a long-term monitoring framework for urban biodiversity and air quality in Madagascar. Here is the map that shows our monitoring sites. For sampling design for bryophyte community inventory, we set up 100 by 100 meters plots at 10 urban sites and 4 rural ones. Bryophytes were collected from all available substrates and along with their ecological data. At each site, we also collected mass samples for chemical screening of elements to assess pollution levels. Our preliminary results show a relatively high species richness for such as an urban setting. So far, we have identified a total of 100 species comprising of 88 mosses and 12 liverworts. Mosses, particularly from the family of Potiaceae, were the most widespread and abundant. A clear decline in species richness was observed from rural to urban areas, suggesting that urbanization and air pollution impact negatively the bryophyte diversity. And moreover, the species accumulation curves confirm that the sampling design was representative, capturing most of the species present across the gradients. This figure shows the variation of elements concentration across all sites. The values were log transformed to normalize the data and enable comparisons among elements with large differences in concentrations. A logarithmic scale highlights the presence of elements even at a lower concentration, and chemical analysis revealed the presence of heavy metals in both rural and urban sites, confirming that air pollution is not confined to city centers, but it spreads across the landscape. It was interesting to find a trace of cadmium and lead in bryophyte tissues, one of the most dangerous for human health. To summarize, urbanization is impacting air quality and biodiversity along the rural-urban gradients. The result of chemical analysis showed that bryophyte-based monitoring is an effective tool for assessing urban air quality. And future research should focus on identifying their accumulator species, studying their adaptation to pollution, and improving taxonomic knowledge of Malagasy bryophytes. Finally, I would like to thank the GWO for funding this research and as well as the institution that's supporting this project. Thank you.
Thank you. Next up with Benjamin on pangolin habitat use.
Pangolins are considered the most trafficked mammal in Africa, with over 200,000 being poached every year. Pangolins confiscated from the trades need rehabilitation and ideally released into suitable areas. However, the location of these areas is often uncertain, as we don't know where these pangolins exactly came from. Considering the factors that impact species distribution and habitat use is fundamental to identify safe areas for survival and for assessing potential future impacts of other pressures, including habitat loss from changing climates. Data collection took place at Swalu Kalahari Reserve for a period of 12 months. Swalu is located in a dryland environment in the Northern Cape province of South Africa. Pangolins were located from the help of guides and trackers, and once located, they were fitted with VHF tracking transmitters. Pangolin observations included recording whether pangolins fed at grasses, trees, or the bare ground and bare ground by trees. I also recorded pangolin duration of feeding time and prey consumed. One of the objectives of the study was to look at pangolin foraging behavior and fine-scale habitat use patterns. During the dry season, we saw that pangolins tended to forage more at prey that was closely associated with trees, then grasses, and lastly, the two bare ground categories. During the wet season, however, we saw a behavioral shift, pangolins tending to feed more at grasses, then trees, and then there was a dramatic decrease in the two bare ground categories. During the dry season, the duration of feeding time was highest at the two bare ground categories, which was then followed by trees, and grasses had the lowest duration of feeding time. During the wet season, all categories did decrease, where the two bare ground categories and tree category averaged about a minute and a half. However, we saw a significant decrease in the duration of feeding time at grass tufts. So even though the frequency of pangolin feeding events was highest at grass tufts, they spent significantly less time feeding there. This evidence that pangolins shifted their foraging behavior can be supported by insect transects that were laid out over a 12-month period. The same 30 transects were laid out and mostly caught ground-dwelling ants and termites. During the dry season, there was an average of 16 ants per trap caught, and during the wet season, it increased to around 26 ants per trap. Rainfall during the dry season had a strong positive effect on ant abundance. So during the wet season, pangolins fed more at food associated with grasses, but the duration was lower, which suggests that this was a more profitable foraging strategy. During the dry season, pangolins adjusted their diet to focus more on ants closely linked to trees, highlighting their seasonal flexibility and strong influence of prey availability on their foraging behavior. Habitat use is therefore possibly variable even at a slightly smaller scale, which is important to understand given the environmental changes that pangolins face, as well as identifying areas of safe release for pangolins. Thank you.
Thank you. Thank you very much. Next, we've got Lauren on climate change and cyanobacteria.
Cool. So, current climate change predictions indicate that climatic conditions will become hotter and drier in the near future. This means that rainfall events will become less frequent and less predictable. Also, the hotter temperatures will make evapotranspiration rates higher. Combined, this leads to an overall decrease in available surface water and water holes to shrink. Barring this, animals will need to visit water more frequently to meet their physiological requirements under these hot to dry conditions, particularly in fenced reserves, where they will likely become completely reliant on these artificially provided water sources. As animals increase their visitation to water sources, the nutrient deposition in and around water sources also increase as they urinate and defecate in and around these water sources. Combined, these shrinking water holes and the increase in nutrient input create ideal conditions for cyanobacterial blooms. Cyanobacteria are naturally occurring algae in sediments of slow-moving streams and water, which under these high temperature, high nutrient input, create toxic plumes that float on the surface of the water. For this study, we wanted to see how the construction of these artificial waterholes affect the potential for these plumes to occur. We assessed all active waterholes at Tswalu Kalahari Reserve. First, we categorized them into natural or concrete waterholes based on the substrate used during their construction. Next, we measured each waterhole. We measured the circumference, length, and width, as well as water and sediment depth in the middle where it's deepest, at the edge where it's shallowest, and at a point in between. We also measured water temperature at these same locations. Next, we measured water quality at the outlet where water is cleanest, in the middle, and right at the edge where water should be the dirtiest. We also categorized animals into being either sippers or waders. Sippers being animals that do not step into water to drink, and waders being animals that do. Lastly, we used all of these factors to calculate an individual risk score for each type of waterhole. Of the 18 waterholes assessed during my study, 12 were natural and 6 were concrete waterholes. On average, natural waterholes were bigger, deeper, had more sediment deposition, a higher length-to-width ratio, and warmer water. Visually, natural waterholes had worse quality than concrete waterholes, which was substantiated by 4 of the 6 main water quality parameters reaching bloom threshold. Whereas in concrete, monopersulfate, which is a natural algicide, reached lethal limits. Of the sippers assessed, lion, impala, and baboon were some of the most prevalent, and white rhino, buffalo, and warthog were some of the most prevalent waders. When we combined all of these factors and we calculated an average risk score for each of the type of waterholes, natural waterholes were more likely to experience these toxic blooms. So, yes, natural waterholes will emulate more natural behavior as animals can step into the water to drink, and is more visually appealing to look at. But in the long run, concrete waterholes will prevent animals from walking in, and it's easier to clean. Therefore, this study found that in the long run, we should look into using more concrete waterholes to limit this cyanobacterial risk. I would like to thank everyone involved in this project, and thank you.
Thank you. Thank you very much. Next, we have got a talk on ant and spider diversity from Asande.
Are the riparian zones of Umgeni River connected to the upland ecosystems? Today, we find out. Riparian zones are transitional areas between land and freshwater systems. They're relatively small compared to the upland ecosystems. They're unique due to their soil, vegetation, and disturbance regimes, which make them complex and dynamic. They act as natural filters, removing pollutants from surface runoff. Their vegetation stabilizes soil, help absorb and slow down floodwaters, and it has potential to contribute to climate change resilience. Other than that, they are a home to a wide range of plants and animals. Among the dominant animals in the riparian zones are arthropods, which include ants and spiders. Their diversity and abundance is crucial for the sustainability of ecosystem health, as they link the terrestrial and aquatic food web as predators for emerging aquatic insects and prey for birds and fish. They are also sensitive to environmental changes, which make them potential indicators to assess, restore, and manage any ecosystem. Globally, only 10% of all riparian zones are not extensively exploited for human use. The current state of knowledge focuses on selected species neglecting terrestrial arthropods, especially in African rivers. While previous studies have made effort to address the gap in knowledge, the physical boundaries of these zones can vary depending on the organism and its specific habitat needs. Umgeni River is one of the most important rivers of KwaZulu-Natal, surrounding communities and servicing 4 dams with water. its riparian zones serve as early indicators of environmental change. So we had sampling plots on a transit from 0 meters to 300 meters from the riverine to the uplands, using pitfall traps during the wet and dry season in Umgeni Port and Hilton. Spider abundance increased during the wet season, while the ant abundance decreased with increasing distance in the wet season. The distribution of ants' foraging strategies was mainly affected by distance, seasonality, and location, whereas the spider foraging strategies were significantly influenced by locations and seasonality. The distance decay relationship describes how species composition become less as the spatial gap increases. This pattern was evident in ants as their community composition at 300 meters differed from that at 0 meters and 300 meters. Spider communities showed variation due to seasonality. This was consistent with the meta-community theory, which states that the environment filters drive species species turnover when species can disperse without a barrier. We can conclude that the riparian zones of Umgeni River support distinct ant communities from those in the adjacent uplands due to the species replacement, suggesting environmental heterogeneity. Contrasting to spider community composition, which suggests connectivity between the two ecosystems with seasonality temporarily filtering the communities. This study, being the first one to document the terrestrial arthropods of Umgeni River, advocates for the preservation of heterogeneous habitats and the extension of conservation efforts to the adjacent uplands to sustain biodiversity. I'd like to acknowledge everyone who was part of the project and helped make it a success. Thank you.
Thank you. Thank you very much. Next, we've got Lesedi talking about the white broad sparrow weavers and the Kalahari. Thank you.
Hi everyone, I'm going to quickly tell you about a Kalahari ecosystem. So ecosystem engineers are species that create or modify the physical environment. Some of the examples I have are the coral reefs, the termite mound, beaver dams, as well as the classic barrow. So these species actually facilitate resources, therefore making them available for other species, creating outsized impact in resource-scarce areas. So birds also have the potential to be ecosystem engineers. And in this picture, you are looking at a white-browed sparrow roost, which is being used by scaly feathered weavers. There's probably around 8 individuals in there, all huddled up. Some of the species that have been seen sleeping in these roosts are the red-headed finches, southern fiscals, those species that you see in the image. So to tell you more about the white-browed sparrow weaver, they occur in arid and semi-arid areas, although their distribution can be a little bit patchy. They are territorial year-round and live in groups of 2 to 12 individuals, and they create these iconic roosts that last for years in the field, providing shelter from extreme weather conditions as well as predators. Because these roosts have been used by other different species, they therefore provide a community resource. So for my study, we wanted to understand the broader impact that the sparrow weaver roosts have on avian communities besides the ones that we know of. And therefore, we hypothesized that the presence of the sparrow weaver roost will boost the local bird life in the Kalahari. So although the sparrow weavers occur across Africa, little is known about them as ecosystem engineers. And there's also very little experimental studies on the potential of birds as ecosystem engineers. So for my study, I worked at Tswalu Kalahari Reserve, and I had to find areas that did not have the sparrow weavers or the sparrow weaver roost, and I found 32 plots without, and in those plots, I hung 6 roosts in each plot. I did not take the roosts from the existing trees. I picked them on the ground, and I had to divide the 32 plots into 2, which was treatment and the control. The treatment plots were left open, the entrances were left open, and the control plots, we closed the entrances with cardboard to minimize access. So I did 3 sets of 5-minute bird counts across 3 different phases. The first phase was pre, which was before adding the nest, and we used this as the baseline. The second one was post 3 weeks. This was to monitor the short-term effect, and the post 4 months was to monitor the long-term effect of how the birds would respond. So for my results on the y-axis, you're looking at the number of individuals, and I checked this across the 3 phases and to see how the birds reacted to the treatment. So because pre was used as baseline, there isn't much difference there, but when we checked pre against post 3 weeks, we had an increase of 64% from pre to post 3 weeks, and an increase of 72% from pre to post 4 months. So you might also see that there was an increase in the closed roosts, increase in abundance, and that is because some birds were trying to get into the roost. I did the same analysis to check avian diversity, and again, pre was used as my baseline. When I compared pre with post 3 weeks, there was an increase in avian diversity of 27%, and looking at the long term, we had an increase of 32% avian diversity. So in case you are wondering why is this study important, understanding ecosystem engineer functions actually helps with conservation outcomes. And with the sparrow weavers having their roosts being used by other species, this makes them a very good proxy to study this. It also adds to the experimental evidence in the avian studies. There has been population declines in the Kalahari of the white-browed sparrow weavers, and this has been documented by the different research groups. And this study gives us an insight on the broader implications that there could be should the numbers continue to decrease. Lastly, it highlights the secondary use, which leads to higher avian communities in the Kalahari in an area that is climatically stricken, as well as resource scarce. I would like to extend my gratitude to these organizations. Thank you.
Thank you. Next up, we've got Darlene on how wetlands provide stable forage resources for ungulates.
Wetlands, the ecosystem's equivalent of that reliable friend that shows up in a crisis, overlooked until drought hits. Wetlands rank among the world's most productive ecosystems, providing vital water and forage that sustain diverse species, making their protection essential in a changing climate. Today, I'll show how they act as functional dry season habitats, buffering herbivore populations against possible collapse. To explore this, I investigated the seasonal importance of wetlands to ungulates on Taupirian Nature Reserve, quantifying habitat use via camera traps and dung transects, and testing whether forage scarcity increased wetland reliance. To investigate seasonal and site variation in vegetation structure and herbivore habitat use, a multi-method approach was employed, integrating vegetation surveys, camera trap monitoring, and dung transects. On Taupirian, 10 sample sites were monitored for a period of 1 year, from January 2024 to December 2024. The 10 sample sites included 5 wetland sites and 5 grassland sites. 1 hectare plots were marked out in each one of these sites, with all surveys conducted within these plots. The surveys were conducted throughout the study period, with animal surveys conducted every 2 weeks and vegetation surveys conducted 4 times a year to capture vegetation changes during the 4 austral seasons. The vegetation survey results showed that above-ground biomass varied significantly between site type, with wetlands consistently having a higher mean biomass compared to grasslands. The highest biomass was recorded in wetlands during summer, and the lowest biomass was recorded in grasslands during winter. The graph on the left shows densitometer readings, further highlighting site differences, with wetlands having high and consistent crown cover compared to more variable crown cover in grasslands. A Wilcoxon-Rank sum test confirmed significantly higher crown cover in wetlands compared to grasslands. The graph on the right shows felt condition assessment results, with higher felt condition scores in autumn compared to summer, and with wetlands having higher felt condition scores compared to grasslands. Shifting to herbivore responses, the top graph shows camera trap results that reveal a significant interaction between season and site. Specifically, camera detections in wetlands during spring were significantly higher compared to detections in grasslands during summer. The graph on the bottom shows dung transit results, which also reveal significant season-by-site interactions, with both winter and spring having significantly more dung pile counts in wetlands compared to grasslands in summer. These results reveal a general shift in habitat use, with higher biomass, denser vegetation, and better felt conditions leading to herbivores shifting from grasslands to wetlands during dry seasons. This relative shift aligns with documented herbivore behaviors during resource-limited periods. When resources become depleted, herbivores will adapt by broadening their diet and increasing their use of functional dry season habitats, such as wetlands. Wetlands play a crucial role in ecosystems. However, poor management practices such as overstocking lead to overgrazing and ultimately the degradation of these systems. This could have serious management consequences, including the potential collapse of herbivore assemblages. It is therefore essential to understand the seasonal variation in forage and habitat use of upland grasslands and that of wetlands to ensure the long-term functioning of these ecosystems and their use by herbivores. Thank you.
Thank you. Last but not least, we've got Shaskia talking about the emerging contaminants in a southern African river catchment.
Good morning, everybody. So, legacy and emerging contaminants in a critically ecologically important southern African catchment, specifically the Crocodile River. So, rivers sustain livelihoods, they sustain biodiversity, but the Crocodile River catchment is slowly becoming a chemical cocktail. And not the fun kind that I hope that we'll be having later tonight. Rivers are the veins of ecosystems. Rivers, every drop of river water tells a story, not just about nature, but about the kind of medicine that we take, about the kind of chemicals that we use, about the kind of lifestyle choices we make, a little bit more questionable sometimes here and there. The image that you're seeing now looks like livers, looks like petals, looks like leaves. Not really sure what it is, but it's a little bit more grim than that. The image that you're actually seeing is dead fish. It is a pollution event. It is a die-off of some of these fish. And it is more common than we think. What my study focused on was understanding seasonal comparisons of water quality and being able to test potential chemical loads in surface water as well as in fish muscle mass. I screened for 22 metals and 274 pesticides in water samples, as well as 21 pharmaceuticals. In fish muscle mass, I sampled for 38 pesticides. They were analyzed using liquid chromatography mass spectrometry and gas chromatography mass spectrometry. Within the crocodile catchment itself, I did in situ water quality sampling with a probe. I also sampled for these surface water samples and did on-site solid phase extraction. And then I also sent these tissue samples off to a commercial laboratory for chemical analysis. The Crocodile River itself, land use is varied. There is industrial use, there is urban use, there is agricultural use, and then there are also ecological zones or buffer zones. The agricultural, industrial, and urban bring in chemicals, pharmaceuticals, and pesticides, as well as fertilizers into the river. So my aims were simple. Determine the chemical loads, determine whether or not there might be a link between anthropogenic pressure and ecological risk. One of our key findings was that legacy contaminants still haunt our rivers. DDT and DDE were present. This means that there is a level of bioaccumulation and biomagnification, as you will see. So with the 3 fish that we sampled, I know some fishermen here are dying at the tiger fish that you see. It was very fun sampling. The the large-scale yellowfish, as well as the tigerfish and the red-breast tilapia were all sampled. DDE was present in all 3 of the fish. DDT, however, was only found in the tigerfish. The levels of DDE in the tigerfish were also elevated, suggesting biomagnification through our trophic levels. There was also differences in the concentrations among species, which might be due to physiological factors such as their uptake and their metabolic uptake. Pesticides were absent in April 2022 in water samples, but in October we did find perchlorates as well as chlorates. Urban influences and urban drugs were also found. We found a lot of methaqualone, or mandrax, in 79% of our sites. We also found cocaine and its metabolites, as well as persistent compounds such as carbamazepine, diclofenac, and sulfur methoxynol. These are persistent compounds that are very difficult to get rid of in a system. Pollution hotspots also allow us to see that there might be a level of antibiotic resistance within the water and causing aquatic toxicity. Within metals, seasonal changes led to fluctuations in the input and the runoff in the river, causing variations in our metal concentrations, which differed between sampling seasons. In the April and October sampling sessions, the target water quality range that was set out by the then DWAF showed that at each site, aluminium, lead, as well as arsenic all exceeded the general acceptable amount that we need for ecological health. So what does this mean? Basically, this means that there is still legacy contaminants being discovered in our rivers, and our new contaminants are emerging at levels faster than we are able to manage. We need to have improved wastewater treatment facilities that need to be upgraded and updated regularly. We also need monitoring of legacy and emerging contaminants, which must continue. Public awareness is important, and we must be able to have a conversation about conservation that reaches more than just scientists and researchers in the room. Thank you very much.
Thank you, our presenters. It's now time for question and answers. So we've got 5 minutes to just pose some questions to any of the presenters. Please raise your hand if you would like to ask some questions. Thank you.
Lesedi, I have a question for you. It's Andrew McKechnie. Wonderful to see you again. But my question is, was the presence of sociable weaver nests not potentially a confounding factor when looking at the impacts or the effects of sparrow weaver nests? And if it was, how did you control for that?
I had to search for areas that did not have sparrow weaver roosts initially. I also did factor in sociable weavers because some of these species that use the sparrow weaver roost actually do use the sociable weaver nest as well. So I looked for areas that did not have both of those species nests. Yeah.
Thank you. I think my question is, it's more of a comment and a question, which is directed to, I think it's Adebe who talked about the ants and spiders. I think the study is quite interesting, and I think there is need for more insights in terms of climate change, the effects of climate change on I think, insects. Particularly, we are noticing that there is a decline in terms of species diversity and abundance, and the effect of this on productivity, forest productivity as well as agriculture is quite significant. Therefore, perhaps we would need these findings to stretch further to look at the effects of climate change on biodiversity and so forth. However, we would like to, maybe might need to, have an insight as to how we can address this issue of abundance, which is being affected by the factors that you talked about. Then there is another one, I think this one is for the legacy and emerging contaminants. I think we can agree that in Southern Africa we are facing a challenge in terms of river pollution as well as dam pollution. Your call for action was quite impressive, but also we wanted to know, how do we remedy, rivers and dams that are already contaminated, that are already polluted? I know there's technology, but can that technology be rolled on? And is it efficient enough to address dams that are already polluted? Thank you.
His first question as well. Okay. I think I'm going to answer your second question, which I think was directed towards me, if that's okay. So I think in South Africa specifically, because from what I'm speaking about is a South African context, there is a lot of shortfalls in our implementation of laws for the constant monitoring of our, wow, it's bright, let me stand up. There is a lot of shortfalls in our laws and the implementation of it. And I think that in order to be able to address these kinds of shortfalls, we need to have consistent monitoring, and we need to call to action not just scientists, but also just normal community members to make it more engaging, to make it more accessible, to make not just the research that we actually find on the ground that we can understand the numbers for, but actual people. This is what's happening. This is how sustainability is being affected. This is why you need to not be able to litter. This is why you need to. So just having a conversation like that, I think, will make a big difference in our contaminants of emerging concern, as well as our legacy contaminants. There needs to be some accountability, and I think that's how we change the conversation from just seeing it to actually making a difference. I hope that answers your question. Thanks.
My question's for Dalian. Thanks for a great presentation. I see, obviously, the wetlands are quite heavily utilized in the winter months. Are those wetlands being overutilized by Game on Telperion?
I don't think it's being overutilized yet, but I think since there's not really, they're confined within Telperion, and there's no predators. I mean, there's leopards, but the leopards can only do so much. So I think it will become a problem in the future if it's not monitored and eventually controlled. So yeah, I think wetlands would face some threats.
Still in on the question?
Thank you so much. I have a question for Loreen. I'd just like to know, you mentioned with the artificial water holes, they're not quite aesthetic and the animals themselves cannot really enter into the water much. So wouldn't there be a possibility to change the structure of these artificial water holes? And especially since you mentioned, with the cyanobacteria, it's actually better for those animals. So wouldn't there be any ideas of the structural changes of these artificial water holes, making them more accessible for the animals that you would know of, perhaps?
Okay, so cyanobacteria are not useful to animals. They produce neuro and hepatotoxins, which cause them to die, which is not great. But I think getting something where you can easily access a water hole and clean it to get rid of that sediment where the nutrients accumulate, combining that with the visual aesthetics of a more natural-looking water hole, like a sediment or a calculine one, would be the optimal game.
Great, thank you. Thank you so much. Thank you, our presenters. Let's clap our hands for them for the good work. Well, we have come to the end of the speed talks. We are now going to a poster session. We'll combine this with tea. So grab a cup of coffee and just go around the posters. We'll be back in the auditorium at 11. Thank you.
loves me like you used to. Sometimes we're not ourselves, there's no one I can turn to. And I know all the feelings that we shared are in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. We're moving on, we're moving on. I know times
My name is Tracy Webster. I'm going to be chairing this session. The format is that we're going to have 6 presentations that will take us through to lunch. And first up, we have Sive Kolisi, please take the stage, who's going to be speaking on origins and invasion date of quilted millennia. Thank you.
Yeah, I'm not the Kolisi you guys were expecting. Good morning, everyone. I'm Sive Kolisi, and I'll be taking you through the work that I did for my master's, where I was looking at the origins and invasion depth of Teribia granifera in southern Africa. So Teribia granifera is a major benthic invader which dominates the benthos. It comes from Southeast Asia, and it constantly expands its range in both freshwater and brackish habitats. It reproduces parthenogenetically, which increases its invasion ability. It can reach densities of up to 5,000 individuals per square meter, as you can see on the picture down on your right, on my left. So the major contributors are habitat modification and bird dispersal. So Teribia was first recorded in South Africa in 1999 in a reservoir in Mandini, KwaZulu-Natal. This reservoir supplies water to a paper mill. So it was introduced in the country with discarded contents of a tropical fish tank. Currently, 26 years after its introduction in South Africa, Teribia occupies 3 provinces, which are KwaZulu-Natal, Limpopo, and Mpumalanga. So looking at this wide distribution, we aimed to investigate the distribution and potential expansion of Teribia populations in South Africa using species distribution models. So we hypothesized that there will be a southward spread which will be influenced by water temperature. Secondly, we wanted to assess the genetic diversity and trace the source of introduction. And we also now hypothesized that Teribia granifera was introduced in the country through in the region through multiple invasion events. To do this, we initially looked at bioclim variables. However, they have been used as proxies in freshwater studies. But for us, these were irrelevant because Teribia granifera is a benthic species. So using bioclim variables would have no biological relevance. Doing that, we now collected in situ water quality data, and we collected these from published research and unpublished data from researchers and research institutions. Now, this metadata that we collected was converted into shapefiles using ArcMap. The shapefiles were then converted into environmental raster layers using the IDW spatial analyst. So what this does is it interpolates a raster surface from points using an inverse distance weighted technique. So all our spatial analysis were carried out using the packages raster, map tools, and biomod2. And then we implemented these in the R programming language. So we based all our models in an ensemble approach, and we implemented them in Maxent, GLM, BRT, Mars, and Random Forest. All our models used occurrence data from the introduced range, which is South Africa. And we followed the methods of Mariatis and colleagues. So for our DNA, we extracted our DNA using the salting out method, and we targeted and sequenced the CO1 gene. To determine the phylogenetic relativeness, we constructed the Bayesian inference, and to infer the haplotype relationships, we constructed a TCS network using pop art. So on the map that you see is a predicted suitability map. So it shows a northward inland expansion and a southward coastal expansion. These are influenced by temperature that range from 16 degrees to 30 degrees and an optimal temperature of 25 degrees. And then turbidity also has an influence. However, it ranges from 0 to 50 NTU. And also the phosphate concentrations also have an influence on the spread of Teribia. It goes from 5 to 15 milligrams per liter. Lastly, electric conductivity, which goes from 0 to 2,000. Yes. Moving on. So what you see there is a phylogenetic tree and a haplotype network. However, both of these figures represent the same thing. So I'll focus on the haplotype network, and I've highlighted in red what I'm gonna be speaking about. In South Africa, so this is a portion of an ongoing work where we are looking at the source of introduction of Teribia. So in South Africa, we believe that, so the genetics are telling us that KwaZulu-Natal is the common ancestor for the southern population, for the Southern Africa population. And we believe that the snails further spread into the region through secondary dispersal by migratory birds. As you can see there, I have color-coded the regions, the provinces, and countries. So we have inferred that Thailand is the source population because it has clustered together with the Southern African sequences. And then the lines that you see are mutational differences. So the S14 represents a sample from Zimbabwe, and then the NO04 represents a sample from Mpumalanga, and the NSE represents a sample from KZN. So this tells us that there's actually a single population that exists in Southern Africa. However, the three that are standing out are species that have mutated. But as you can see, they have single lines, so that means there's a single mutational difference. So the take-home message is that Teribia granifera is spreading southward on the coastal plain towards the Eastern Cape and northward inland. So potentially, we can predict that the water quality variables that I showed earlier on are the ones that are influencing both the spreads. And we know that Teribia granifera was introduced to Southern Africa by a single invasion event that spread from KwaZulu-Natal, as I showed you on the haplotype network. So the knowledge from this study can help us understand the invasion dynamics of freshwater snail invaders. I'd like to acknowledge these institutions and the people that helped me with my project. Thank you.
Thanks, Sive. Do we have any questions in the audience? No. Thank you. Next up, we have Stefan Woodburn with a very interesting topic. How doth the little crocodile?
How doth the little crocodile improve his shining tail and pour the waters of the Nile on every golden scale? The first stanza of Lewis Carroll's poem, The Crocodile, it invokes a kind of pleasant feeling about the little crocodile, maybe something that looks like this. In reality, this poem is about the mischief of human children. And when we get on to the second stanza, it looks more like this. How cheerfully he seems to grin, how neatly spreads his claws, and welcomes little fishes in with gently smiling jaws. And perhaps the image associated with the second stanza is more like this, a mischievous little crocodile. Now, whether you subscribe to the innocent crocodile or the mischievous crocodile, the little crocodile that invites fish in has the risk of a completely different image, and that image is tragedy. This is a crocodile from the Olifants River Gorge from 2010. This was a period when crocodiles were dying from a disease called pansteatitis. Now, pansteatitis is a dietary disease, so it had something to do with whatever the crocodiles were eating. The crocodiles were dying in a very limited range. It's called the Olifants River Gorge. It's from where the Letaba River, the confluence between the Letaba and Olifants River, down to Masinga Dam in Mozambique. And there was a hint of what was going on here, and it came from catfish. Catfish in the same area had the same disease. And it turned out that catfish that had fish in their stomachs had pansteatitis. Catfish that had no fish in their stomachs didn't have pansteatitis. So we thought it was something to do with a fish diet. Now, I do stable isotope work, and we can try and reconstruct the way in which trophic relations organize in a food web. And so what we didn't imagine that this was eating any fish. It was maybe there's a specific fish species that was the cause of this. And maybe the catfish were eating these fish and the crocodiles were eating this fish, and they both got the disease. Now, I'm not going to go into the details of stable isotope analysis, but we measure the isotopes of carbon on the x-axis, nitrogen on the y-axis, and it's the nitrogen that separates trophic levels. So we would have expected crocodiles that are eating fish to plot higher than the fish. What we actually have here are the red crosses are the crocodile measurements, and the blue crosses are the fish. And so what we have to conclude is that the fish were eating crocodiles. This is absurd. To unravel this required a whole lot of scientific work. It's a glorious program to work out these kinds of dilemmas. The first thing we had to do was try and understand the biochemistry of isotopes in fish. Then we had to understand the biochemistry of isotopes in crocodiles. And then we realized something that perhaps we ought to have realized earlier on. We were doing a study after the pansteatitis epidemic had ended. Was there a possibility that we are not seeing the cause of the pansteatitis epidemic because it's no longer there? So we had to come up with a way to try and go back in time. And we figured that the claws of the crocodiles was the answer. Now, the claws of a crocodile, we presumed, grew the way your fingernails grew. So the tip of your fingernail grew a lot longer back in time than the base of your fingernail. So we thought that by measuring along the length of a crocodile claw, we would be able to work out what their diet has been in the past, hoping we would see what was happening at the time of the pansteatitis epidemic. And what you can see is our nitrogen isotope profile along the length of the claw. And it's quite interesting, because by far the majority of the nitrogen isotopes that we measure indicate a terrestrial diet, not fish. But we picked up these spikes, and those spikes are absolutely consistent with the crocodiles eating fish. So what this told us is that crocodiles generally are not eating fish. but they do sometimes. And this evidence seemed to suggest that it was episodic. Now, we've solved the problem in some ways because now we can say, yes, the crocodiles were eating fish. But we always, the scientists, have to go a little bit further. And we wanted to know if this is episodic, how episodic is episodic? And so we wanted to try and work out what kind of time range is reflected in the record that we're getting from these claws. So we sectioned a claw from top to bottom, and what you can see in the bottom right of that image is the section through the claw, and through a little bit of chemical magic in the lab, we were able to etch the edge of that claw, and you can see little laminations. I don't know if you can make that out in the bottom right, but there are little layers in the claw, and those laminations, we actually went and dissected them out one at a time and did radiocarbon dating on it, and we could prove that these are annual growth rings, like the growth rings in a tree. And on the basis of that, we could change our time axis from sample number to years. So it turns out that these nitrogen excursions indicating fish consumption were annual events. Just because we always take things too far, we wanted to see if the same thing happens outside of Kruger National Park, where there was no pancytitis epidemic, and sure, we found that the crocodiles outside of the park are also not really eating fish, maybe episodically. So now we know that the crocodiles were eating fish occasionally. Why is it that it happened in this one location? And to understand this, we have to look at the geography. At the time that the pancytitis outbreak happened, Massingier Dam wall had been raised to provide more irrigation water. It had back-flooded up into the Olifants River Gorge. And just to illustrate the difference between a back-flooded Olifants River Gorge and what it used to be, this is what the Olifants Gorge looks like when water levels are low, if Lake Massingier is low. When it's high, this is the same view. This is what it looks like. And the difference between those two images is quite profound, especially if you're a little crocodile, because crocodiles like beaches to lie on, and with the backflooding of the gorge, there was no place for them to lie on the beach. The second thing that's important about this is that gorge is something like 9 kilometers long. As soon as it stops being a river and it rises, anything that flows in does not flow through very quickly. So you have a higher residence time of the water in the system when it's flooded. And this is where we're trying to narrow why did this happen in this particular location and not elsewhere. And it's got to do with the pollution that we are putting down the Olifants River. I've spoken about that previously at these meetings. That pollution leads to annual toxic algal blooms. Now, this is not synthetic color. This is real. That's what it looks like if you get close to it. And it's extensive. This is a huge body of water that looks like some kind of luminescent green paint. This algae is toxic, and the filter-feeding fish love it. So the tilapia, the Oreochromis mozambicus, they migrate into this system, concentrates the fish in this area. They're busy eating the algae, and then the crocodile, they just think, well, this is too easy. So many fish in a small area, they eat the fish. So we think that what was happening is that when these algal blooms happen, it concentrated the fish, the crocodiles were binge feeding on the fish. Now, there's a bit of a problem with this theory because we know that we think it's fish. We think we know why it's happening in a particular area, but there's two little problems. The one is these toxic algal blooms are happening every year. They are so bad that we can track them from satellites now. Why didn't it happen again? We didn't have another pancytitis outbreak. The second thing is, we should have looked closely at those crocodile claws, because what that was telling us is that crocodile had binged on fish for several years in its life, and it didn't die of pancytitis until the very end. So just eating these fish during an algal bloom is not sufficient criteria. Now, the great thing around doing this kind of research, you go out there, you don't know what's going on at all. And we would sit around the fire late at night after catching crocodiles, and we would speculate what was going on. And the Sandparks team was actually the team that said, it's not just eating fish. It's got to do with the metabolism of crocodiles. If they get cold after eating fish, the fish that is in their stomach will stay there. And it will rot, like any fish will rot, and perhaps worse in a crocodile's stomach if you've ever been there. And so Sandparks actually came up with the idea, let's try and understand the thermal ecology of the crocodiles as well, and see if this ties into the pansteatitis outbreak. And so it was Sandparks' initiative, let's put some tracking devices and temperature sensors onto some crocodiles. And so how do you do this? Well, the first thing that you must do is ask the crocodile to just get out the river. Then it must lie still, and we would anesthetize the nuchal scoot that's on the back of the neck. And we would mount a tracking device. You can see it's a little green thing. We would mount that onto the back of the neck of the crocodile. That tracking device has a GPS position indicator. It logged temperature, and it also had an accelerometer in it, so it would log whether the crocodiles are being active. In addition, we would ask some of the crocodiles if they would open their mouth and gently bite onto this felt-coated metal tube, because when they did that, we could look down that tube and get to their gular flap, open up the back of their throat, take a creepy crawly tube, push it down into the stomach of the crocodile, and drop a thermal sensor into there. Interesting sound, zoop, as it goes into the... Obviously, when you ask a crocodile to bite on the felt, you really don't want to give it the chance to change its mind, so we would tape its mouth closed, as you can see. But this meant that we had temperature sensors from the stomach of the crocodile as well. Waiting for a slide to update. There we go. Okay, and so here's the data that we got. At the top, you can see a Google Earth image. On the right, you've got Lake Massingier. The yellow line is the border between Mozambique and South Africa. And you can see the red dots are where we got fixes on the crocodiles. And you can see they moved up the Letaba, the northwest up the Letaba. They didn't really go far southwest along the Olifants. But there was definitely a concentration of the crocodiles between the confluence of the Letaba and the Olifants and Massingier Dam. At the bottom, you can see the thermal data that we got. In black is the temperature that we got from the back of their necks. In red is the data that we got from the stomachs. Now, I don't know how crocodiles do it, but they are able to get rid of thermals. Actually, I know how they do it, but they get rid of the thermal sensors in their stomach. So we didn't get as much thermal data from the stomachs as we would have liked. The blue data set is the air temperature, and the orange is what we got out of the accelerometer. So you see, we've got about 4 years of data, not all of it for internal temperature. And so the question is, what does this mean? Now, I imagined that that sensor on the back of the head of the crocodile would be telling us about air temperature. If it was air temperature, then a plot of air temperature on the x-axis versus the external temperature on the y-axis should have been a straight line. The 1-to-1 line is a black line here. Those little dotted lines are plus minus 4 degrees. And when you look at the raw data on the left, I've divided it into summer in red and winter in blue. When you look at those, it actually doesn't fall on a 1-to-1 relationship. And this meant that I was missing something. But when I averaged this by the hour of the day, there was something that was quite interesting. During the summer, the average temperature of that unit is near enough to the air temperature. It sits very close to the 1-to-1 line. Just after the midday, from about 2 o'clock until maybe 5 or 6 o'clock in the evening, there's a little dip there. There's a reason for that. I'm not going to go into those details now. You can ask it as a question if you want. But the really interesting thing came out in the winter data set. And what we saw is that from about 9 o'clock in the morning, that sensor on the back of the head became warmer than air temperature. And you can see from about 9 o'clock in the morning up until about 5 o'clock in the afternoon, that sensor was warmer than the air. This was a clue to what the crocodiles were up to at that time. It's pretty much like when I walked to my car yesterday, the air temperature was fine, and when I got in the car, it was hot. This is the effect of the crocodiles basking in the sun, gathering as much heat as they can. And that sensor would... Now, this is going to turn out to be important. The next thing that I was interested to see is, what about the body temperature? These are ectotherms. So I would have thought, and I'm very naive about this, I would have thought that there would have been quite a linear correlation between the temperature of your reptile and the temperature of the air. That's what I was led to believe from a little child. But what we see is very strong cycling. Again, a big difference between summer and winter. And when I break that down by the hour of the day, I think this is fascinating. What we see is that during summer, between about 8 o'clock in the morning and 7 o'clock at night, during the day, the crocodiles are cooler than the air temperature. At night, during summer, the crocodiles are warmer than the air temperature. They plot above the 1-to-1 line. Winter is very interesting. What we see is that the temperature, as the day temperature increases, the crocodile temperature doesn't increase initially. So up until about 10 o'clock or 9 o'clock in the morning, the sun is up, but the crocodiles are not getting any warmer. And then suddenly they warm quite rapidly. And if you remember what I said previously about the crocodiles lying in the sun and basking at a certain time of the day, you see at that time, the crocodile temperature suddenly starts to go up. But what's important here is that this is winter. And the crocodiles are spending most of the day warmer than air temperature. In fact, most of the night as well. So how doth the little crocodile do it? To understand this, I want to resolve these into time series. So I've now plotted the average temperatures of the air, the average temperatures of the crocodile as a function of time in the day. I've split it between summer and winter. In blue is the air temperature, and in red is the crocodile's core temperature. And there's two things that really strike me about this. The first is that, I'll start off on the right, in winter. The red line spends more time above the blue line, which is what I said previously. The crocodiles are warmer than air temperature for most of the day. You can see that the very rapid increase in the internal temperature occurs at the time that we know that they're basking. So basking is very important. It allows the crocodile to generate heat sufficiently that it compensates for whatever heat loss happens overnight. So when the sun sets, everything gets cooler, the crocodile gets cooler, but by the time the sun rises the next morning, the crocodiles are still warmer than air temperature. The second thing that I noticed about this is, let's start off with the summer. When the sun rises in Kruger National Park in summer, it's around about 5 o'clock in the morning. The temperature starts going up. So your temperature minimum is, let's call it 5 o'clock in the morning. The crocodile temperature minimum happens more like 9 o'clock in the morning. So there's a delay. If we look at the peak temperature, it's the same thing. The daily temperature, the air temperature peaks, and 4 hours later, the crocodile temperature peaks. The same delays, well, not exactly the same, but we have similar delays in winter. How doth the crocodile do this? Now, I'm going to answer that in a moment, but I just want to take a very short excursion into the orange. That's the activity. I'm putting this in because it's Stefan's guide to when not to swim in Kruger National Park. What you notice is that during summer, the crocodiles are more active than in winter. Yeah, they're ectotherms. But what we see is that their activity coincides with the lowest body temperature. So where the red line in summer reaches its nadir, that's when their activity peaks. And what they do is at the end of the day, they stop being active because that would generate metabolic heat during the hottest part of the day and it would heat them up. So there's a behavioral response here that is avoiding hyperthermia from getting too hot. Right, back to this thermal lag. I can take these data sets and I can take the temperature and I can shift it to the left. You see they're out of phase at the moment, but if I do a little shift, I can get them to be in phase. And what it says is that if the day temperature starts going up, so many hours later, whatever the lag is, then the crocodile temperature goes up. When the air temperature starts going down, so many hours later, the crocodile temperature starts going. I can get them in phase with this shift. And when I look at what the timing is of this lag, it's patterned through time. And what we see is that the lags are greatest during the summer months, and this is when the crocodiles are at their best condition. During winter, they're using up their fat reserves, and the lag time drops to about 2 hours. And so the thickness of their fat layer seems to be a very strong indicator of what's going on. It's not just acting as a nutrient reserve to get them through winter, it's acting as an insulator as well. Now, I want to just point out the behavior of one mischievous crocodile. On the right is the data that we got from 4 crocodiles, which were behaving normally. The black data is the head temperature sensor, and you can see it oscillates. Underneath that, there's actually a blue temperature record. You can't see it because it's swamped by the head temperature. And the red is the body temperature. And you can see nice, that's a perfectly normal, what we would have expected from this data set. But one crocodile number 4, at exactly the same time, this is in the depth of winter. This crocodile, if you look at the black trace never exceeds really, at least not during the day, the air temperature, which is in blue. This tells us that the crocodile was not basking. If it's not basking, it's in the water. As a consequence of that, we see in the red trace that the body temperature drops. And there's a slight recovery during the day, and that's because the water's warming up, but the next night, the temperatures drop. This crocodile is not defending its core temperature, and it's not basking. And this tells us that the basking of the crocodiles is absolutely critical. Now, what was this crocodile doing? We can go to the tracking data, and we can see where was it. Now, for those 6 days or so, that crocodile had one GPS position. It did not move. We know it was active. The accelerometer says it was doing something. And that point, which is at the southern basin of Lake Massingier, just below Lago Nova, that's where that crocodile was. Now that is just opposite a fishing village. And I'm pretty sure that what he was doing there was raiding fish nets. So here was a little crocodile that doth eat fish. But if you are going to go and raid the nets from those fishermen, they are not going to be happy. And we've seen plenty of evidence of spear wounds on crocodiles and so on. That crocodile knew, do not go and spend time at the surface. It stayed where it was, but it didn't spend time on the surface, because if it did, it was going to get hammered by the fishermen. So what this tells us is that basking turns out to be really important to crocodiles. When you see crocodiles basking like this, they're not goofing off. They are really doing everything they can to capture as much heat as they can to be able to have heat reserves to get through the next night. Now, to understand this, I'm working with Shannon, so she's going to talk a little bit about this tomorrow. But we're trying to model what's going on here using models that really understand both behavior and the biology of the crocodiles. And so I look forward to what Shannon has to say about it, but I also look forward to the results that we're eventually going to get. And so let me just conclude with this. How doth the little crocodile deal with temperature? It turns out that basking, if a crocodile can't bask, it's in trouble. If it can't bask for a long time, it's in trouble. A few days is fine, it'll recover. They also have this really unique behavior, which it's like a thermal hysteresis, where they have their body temperatures lag air temperature. The consequence of that is that on the coldest nights in winter, the crocodiles never get that cold. They will be slightly warmer. During the hottest days in summer, the crocodiles never get that hot. They'll be a little bit cooler. So they're mitigating the extremes of temperature and the risk of hypo and hypothermia. Now the pansteatitis thing. So what happened? We knew they were eating fish. We knew where it was happening, and we know that we had a change in the physical layout of the gorge. And what now I propose on the basis of this evidence is that when that gorge was initially back-flooded, the crocodiles ate fish, but they didn't have anywhere to go and bask. And as a result, having lost all of their basking area, they were stuck in the water. They got colder and colder, like our truant number 4 crocodile. But there was no respite. And as a result, any fish that they had eaten became putrid in their stomach. It's the association between putrid fish, consumption of putrid fish, and pansteatitis that we see in other species. And it seems as if temperature was the cause of the inability to bask, and the metabolic impact on temperature was probably the final factor in explaining the pansteatitis epidemic. Thank you.
Thank you. We do have a minute or two for 2 questions.
Stephen, thanks for a great talk. I'm interested, what percentage of the crocodiles died, and those that didn't die, they couldn't bask. What happened there? They also had the fish, they were also eating those fish, I'm sure.
Yes, astute. I know that you're going to ask the right questions. No, you can imagine there were 180 odd crocodiles that died. Now, 180 crocodiles in a very short area. That's the thing is that it's not that there were no basking areas, but the dominant crocodiles got them. So if you were not dominant, if you didn't migrate out, and if you did migrate out, you're going to meet another dominant crocodile. That was the problem. If you weren't dominant, no basking.
Any other questions?
Thank you. That was a really great talk. I'm not sure if you mentioned it, but I'm just interested, what was your sample size?
18 crocodiles?
18. Okay. Thank you so much.
One final question? Anyone? No. Thank you very much. Next up, we have Dilys Rowe, and her question is, should wild animal welfare be considered in conservation?
Thanks very much. Yes, my name's Dilys Rowe. I'm the Biodiversity and Conservation Lead at the International Institute for Environment and Development, IIED, which is a sustainable development think tank based in the UK. And I'm also the chair of the IUCN Sustainable Use and Livelihood Specialist Group, which is a network of over 300 wildlife management professionals with some interest and hopefully expertise in sustainable use. So here I'm going to address the question, should wild animal welfare be considered in conservation, introducing you to 2 pieces of research that's explored this issue, one led by myself and the other led by Amy Dickman and Lauren Harrington at the Wildlife Conservation Research Unit at the University of Oxford. And I just wanted to start by saying it's great to be here. This is my first Oppenheimer conference, so really appreciate the opportunity to talk. And I'm already blown away by how great this is, just the venue, the organization, the quality of the talks, and everything about it. It's such a refreshing change, having just come straight from the IUCN World Conservation Congress in Abu Dhabi, which had too many people, too much bureaucracy, was too hot, and just quite a lot of chaos going on there. So it's really, really nice to be here. It's also really nice and a real novelty for me to be talking about animal welfare. Although I started my career working for an animal welfare research institute, for the last 30 years I've been working on issues around community conservation and sustainable use in Africa. And normally when I'm standing on a stage like this, I'm talking about trophy hunting or some other controversial sustainable use issue that animal welfare people really hate. And today I'm talking about animal welfare, which a lot of conservation and sustainable use people really hate. So lots of hatred from both sides, and yeah, interested to see where the land lies with this one. So why this question? And it's really for the very simple reason that animal welfare has been a concern for very many people for a long time, but it's often perceived to be at odds with conservation, hence this divide. You're either sort of for animal welfare or you're for sustainable use, and there doesn't seem to be a bridge between the two. And particularly for conservation programs that focus on sustainable use and involve the capture and killing of wild animals. Animal welfare laws and regulations have been around for decades, but they generally apply to either domesticated animals or to captive wild animals. So pets, zoo animals, laboratory animals, livestock, and sometimes farmed game. So as this horrible case from Wyoming in the US shows, it's sometimes actually really difficult legislatively to apply animal welfare laws to wild animals. So in this case, this person deliberately ran over a young female wolf with a snowmobile, injured it but didn't kill it, put tape around the muzzle of the wolf, dragged it into a bar and paraded it around the bar, and then took it out and shot it. Initially, the person was just fined $250 for illegal possession of a wild animal. There was no fine for animal cruelty, no animal welfare consideration there. Recently, this decision has been challenged by a grand jury, and the guy's now been indicted with an offence of felony animal cruelty, which has a much more significant fine and even a prison sentence. If he's found guilty, it's yet to come to court, but if he's found guilty, it'll be a significant change in law for Wyoming, the state where it happened. And also elsewhere across the world, we see increasing interest and attention to when and how animal welfare standards should be applied to wild animals and to conservation. So here in South Africa, for example, as I'm sure many of you know, 2023 white paper passed on the conservation and sustainable use of South Africa's biodiversity. And this emphasized that the well-being of individual animals as well as populations of wild animals should be integrated into biodiversity policy and legislation, as well as into conservation and sustainable use practices. And there's been a heated debate, which I think is still ongoing, about the formalization of this as a legal requirement. Globally, the link between animal welfare and wild animals really came to the fore with the outbreak of the COVID-19 pandemic, when the links were drawn between the condition under which wild animals are harvested and kept and the likelihood of the spillover of zoonotic diseases to humans. So evidence does show that zoonotic pathogens emerge more frequently in stressed and sick animals. So there is a logic to this argument, but at the same time, zoonotic disease risk doesn't mean that there should be no use of wild animals. And many, including myself, considered that COVID-19 was really being used as a convenient cover to push an existing animal welfare agenda. But it did make me and others think that although a firm advocate of sustainable use, perhaps the world has changed and we did need to reconsider what sustainability really means in a post-pandemic world, where we are sort of more aware of disease risks and where there's much more attention being paid to animal sentience and animal health and welfare. So hence the 50 Shades of Sustainability project was born, involving my organisation IAD and the IUCN Sustainable Use and Livelihoods Group, Traffic, the Endangered Wildlife Trust, and epic biodiversity. It was funded by the UK government's Darwin Initiative. And we started with rethinking the conceptual framework for sustainability. Most conventional depictions and descriptions of sustainability are illustrated either with 3 pillars or 3 overlapping circles, where you see these dimensions of economic sustainability, social sustainability, and ecological or environmental sustainability intertwining and overlapping, with sustainability there in the middle where these things overlap. Under our project, we developed a revised conceptual framework that took an expanded concept by bringing in 2 other dimensions, one around human health and the other around animal health and welfare. And what we did was conduct an extensive literature review where we looked at all the existing guidelines and standards and principles that we could find that were out there that related to one or more of these 5 dimensions that we had identified. So examples of information that we looked at were things like the CITES non-detriment findings guidance. So non-detriment findings is the assessment process that you carry out under CITES if you're contemplating exporting a species that's listed on one of the CITES appendices. And you have to conduct an assessment to prove that the trade in that species is not going to be detrimental to the survival of that species. So it just addresses the dimension of ecological sustainability. We looked at the World Organization for Animal Health's guidance on animal health and welfare, which obviously just addresses that one dimension of animal health and welfare. But other things such as the Fair Wild Standard, which is a certification scheme for wild harvested plants, addresses multiple dimensions, so including ecological sustainability, but also social sustainability, labor law conditions, and so on. And we went through all of these existing guideline standards, principles, and pulled out, sort of deconstructed them and allocated all of their constituent parts into one of our 5 dimensions. And then we synthesized all of these down and came up with 7 core principles for each of our 5 dimensions, as well as 7 cross-cutting principles which were relevant to all of the dimensions, and they concerned issues such as legality, traceability, adaptive management, and so on. We really desperately wanted to come up with 50 principles overall so that we could justify our 50 Shades of Sustainability name, but we only had 42, so it's 42 Shades of Sustainability. That's what we had to stick with. All of the principles aren't engraved on my heart, but just to tell you about the welfare principles, the first 6 relate to the conditions in which animals are kept or how they're handled or killed by humans. So they build on the 5 freedoms or the 5 domains which are kind of like a recognized international standard for animal welfare. And these refer to things like freedom from hunger, freedom from fear, availability of shelter, and so on. So the first 4 of them relate to provision of appropriate food and nutrition and water, provision of appropriate shelter, stocking densities and group composition that allow for natural behaviors, and appropriate treatment of sick animals. 2 of them then address the way that humans treat animals, how they catch, handle, contain, or kill them. So they'd only apply to animals in the wild as well as animals in captivity, whereas the first 4 only really apply to captive or enclosed animals where humans actually have some control over their welfare. So the 2 that apply to wild animals as well are the fact that if you are capturing, containing, handling, or killing wild animals, you should do this in a way that minimizes pain, stress, and suffering. And you should also do this in a way that minimizes disease transmission. And then the 7th principle is about the capabilities of humans that are working with animals, either as hunters or in any other context. It's about your knowledge of species biology, your knowledge about the kind of instruments that you're using, the weapons that you're using if you're going hunting, and so on. What we then did was take our principles and we developed a tool to support the application of the principles. It's an Excel spreadsheet-based tool I'm not expecting you to be able to read this, but for every single one of those 42 principles, we came up with 4 indicators that indicated a level of alignment of your practice with the principle. And the indicators reflect bad practice and then increasingly good practice up to exemplar practice. So bad practice, for example, for the first principle about provision of adequate food and water would be there's no evidence that adequate food and water has been provided, or there is evidence that animals are looking neglected. And what you do is you score each of the principles on a score of 1 to 4 for each of these. And the tool generates a radar chart at the end, and it shows you how your initiative scored against each of the dimensions. So the 6 points of the radar chart reflect the 5 dimensions, and the closer you are into the green zone reflects the higher score that you got for each of those dimensions. We piloted this tool in a number of different initiatives: wild meat industry in Tanzania, trophy hunting of crocodiles in Zimbabwe, python harvesting in Indonesia, and here in South Africa we looked at game ranching with research conducted by the Endangered Wildlife Trust. And these are just the results showing you how sort of different initiatives fare. This first radar chart comes from one game ranch which was managed as a private wildlife reserve, scores really highly on ecological sustainability, but not that high on social sustainability because it was a private reserve with very little involvement of local people. Second one was a game ranch which was really focused on producing commercial meat for export and very cognizant of international health and welfare standards, so scored very highly there. And the third one was a mixed game ranch where they had tourism, biltong hunting, trophy hunting and all sorts, and scored sort of averagely across the board. When I first presented this framework, it was met with horror by somebody in my specialist group who is a real advocate of trophy hunting, who told me that this was a terrible thing to be introducing animal welfare into the concept of sustainable use. And, really, if I was doing this, I ought to be ashamed of myself. And I was really surprised by the reaction because if you go hunting, you think about what kind of weapon am I using? What caliber bullet am I using? And that is animal welfare, even if we don't think about it like that and label it as that. So we went back to the wider specialist group and asked the question, what does everybody else think about how relevant this is? And overall, the responses were much more positive, that yes, we do think this is important. And they were generally for sort of both pragmatic and ethical reasons. Some people really highlighted that ecological sustainability has to come first and then welfare can follow, and highlighted that you could have a high welfare situation, but that the use could still be unsustainable. But overall, people recognize that if you introduce animal welfare and make it as good as possible, well, that's good for the animal, it's good for the person that's doing the hunting, and it usually makes economic sense if you're into a sustainable use initiative that has a commercial dimension to it. And many people highlighted examples of where welfare is already codified and incorporated into wildlife management practices. So as I said, one of the principles is about how you catch and kill wild animals and how you do that in a way that minimizes pain and suffering. But how do you know which ways to kill animals are good and which are bad? So this relates to some work that Oxford University are doing where they're looking at different kinds of ways of killing animals and looking at the welfare, comparing those from a welfare basis. So they did this through a process of getting assessors to look at welfare before and during death and coming up with a welfare index and combining those suffering before death and suffering during death to come up with a welfare index. These are the results, some preliminary results from their study that's looking at comparing optimal gun shooting with poor gun shooting, with spearing, bow shooting, poisoning. And it shows you, for lions in particular, overall, that the highest welfare deaths were brought about by good gun shooting and good bow shooting, and the rest were long-duration spearing. It also showed that with some kinds of killing, by good practice, you can improve welfare. So the graph here shows the difference between poor gun shooting and optimal shooting. If you make if you improve the practice around gun shooting, you can improve welfare. Other practices like poisoning, you can't really change the practice. Poisoning is poisoning and causes a lot of suffering. So just thinking about the way forwards, we do think that welfare consideration in conservation aren't going away, and perhaps they shouldn't go away. And tools such as these can really help us identify where the welfare risks are, but also where there are opportunities to improve them and address them. We can't resolve the debate about animal welfare or sustainable use, but we can certainly help and inform that debate and start to build bridges. So just to end, to show you that the tool is available online, and it gives you links to all the spreadsheets and everything. We're really keen to try this out in as many contexts as possible and encourage feedback from it. We're hoping to roll this out very soon. And the good and bad ways of killing is one of the posters that's being displayed. Sorry, if I can go back to that. In the poster session. So please go and talk to Lauren and Amy about that. And please do follow up with us by email if you're interested in this issue and interested to carry on the conversation. So thanks very much for listening.
We do have time for one question. Is there a question? No. Thank you very much.
Thank you.
Next up, we have Patience Gandiwe, and she's going to be talking to the applicability of environmental management systems for effective management of trans-frontier conservation areas. Thank you.
I think it's already midday, almost. And yeah, I think I'm deciding to talk about the naughty crocodile and what it's doing across borders. And maybe then add 100 shades of TFCA EMS issues in addition to what Dilys was just talking about. So if we're not listening to their presentation, sorry. Anyway, many of you might be wondering, actually, what are trans-frontier conservation areas? And when I look around the room, I think I can see quite a good fraction of the audience that are a bit familiar with what are these trans-frontier conservation areas. So I'm just going to give you some brief highlights and then share with you some of the preliminary findings and perceptions around TFCAs and also how we can apply the EMS gold standards. And yeah, and I think it's important that I put it up front that this has been really a management need-driven research than just a research for academic or other purposes. There have been some brick walls that we have had to hit, and also some of the emerging requirements from our various donor community that have, from time to time, always been reflecting about the needs for standards and protocols. So just maybe some say photos or videos, they can maybe say it better or explain it better. So for the sake of some of our audience that may not be familiar what are these TFCAs, I'm just going to play this video. It's in public domain on YouTube. I'm not going to finish playing it. You can always play it at your own time. But I think I like how it explains what are these TFCAs better than what my words can say. And
the Southern African Development Community, or SADC, was born of a vision to ensure economic well-being improvement in the standards of living and quality of life for the peoples of Southern Africa. SADC comprises 15 member states and is a region abounding in natural and cultural wealth. The vast and breathtaking landscapes are studded with countless treasures. However, wildlife, as well as rivers and even culture, do not neatly follow the arbitrary lines on a map that make up national boundaries. The movement of these resources is essential for maintaining population health, viability and resilience to change in the long term. These landscapes are essential to the continued provision of fundamental ecosystem services upon which we, as human race, rely. This is especially true in a world where our footprint as humans is continuing to dissect biological habitats and erode the natural resource base. Consequently, these resources cannot be considered only national assets, but regional and global assets for which the duty of responsibility must be shared. In stark contrast to the rich biodiversity that these nodes offer, they often characterize high levels of poverty amongst the human populations that host these resources, as they bear the highest opportunity cost of being their direct custodians. A combination of factors lock these populations in a tight cycle of poverty, including limited rights to use the resource base, meager livelihood options, inadequate service provision or access to services, and high levels of human-wildlife conflict. The resources upon which these populations rely so heavily are often not managed in a coherent manner by the corresponding agencies across international borders. And this has serious implications not only for the resource in question, but also on human livelihoods. Defined in the SADC Protocol on Wildlife Conservation and Law Enforcement of 1999 as the area or component of a large ecological region that straddles the boundaries of two or more countries, encompassing one or more protected areas as well as multiple resource use areas. Transfrontier conservation areas or peace parks differ substantially in spatial parameters and the mix of land use categories. Those adjoining protected areas are referred to as transfrontier parks. Those that encompass an area of multiple resource use areas are referred to as transfrontier conservation areas or TFCAs. Currently, there are 18 existing and potential TFCAs in SADC in both terrestrial and marine environments at different stages of development. While there is no international convention for TFCAs, these initiatives complement the goals and objectives of a series of international conservation-related conventions. And IUCN has identified over 227 transboundary protected areas worldwide. TFCAs offer a platform for dialogue between countries.
So, yes, you can always watch that video at your own pace and finish it, but it's really quite interesting. What are these TFCAs? And there's a cocktail of protocols at regional level that have actually necessitated or even are facilitating the implementation of the TFCA program. And protocols, what's important is that these are actually legally binding instruments that bring parties together. And because TFCAs were born out of the SADC Protocol on Wildlife Conservation and Law Enforcement of 1999, there are certain considerations that we need to make or to be mindful of, especially when we look back 25 years on when this program was initiated. And right now we do have the SADC TFCA program 10-year strategy, which was approved by SADC ministers responsible for wildlife. And these have got 5 goals. And as we're looking at these goals, We need to also be reflecting in terms of how are we measuring progress, and also how are we harmonizing our standards and processes, for example, to achieve integrated and effective management of transboundary landscapes and also seascapes. How are we making sure that there is improvement in terms of the well-being and livelihoods of people through various initiatives that are not limited to agriculture, fisheries, forestry, and other livelihood options. And there's need also to be thinking about the tools and solutions or mechanisms that are at our disposal in relation to the 3 goals, Goal 3, Goal 4, and Goal 5 of the SADC TFCA program. And of course, being mindful of the cross-cutting themes, and I think there are several talks that have been given during this conference that relate to issues of climate change, mitigation and adaptation, and also ensuring that there is a just energy transition, and various factors relating to how these landscapes or conservation areas or protected and conserved areas are actually also contributing to livelihoods of the people that are inhabiting in these landscapes. And there are some guiding principles. When you look at environmental and social justice as a principle, do we have the gold standard that is being applied across the 13 actually TFCAs following the revised program? Initially you had in the video, which was produced a number of years ago, about 18, but there were some reviews that were done. How are we also measuring or ensuring accountability and also transparency, which is acceptable to the modern day standards and expectations, especially in the face of competing needs on limited financial and other resources? So with this backdrop, for Zimbabwe, pursuing the transboundary conservation agenda beyond the protected area estate is not just a nice thing for us to do, it's actually a necessity. There's no way that Zimbabwe can support the second largest population of elephants in the world, looking at the just over 5 million hectares that is gazetted protected areas. But what's important is that we really have to pursue this conservation agenda beyond the protected area network across various different categories of protected areas into conserved areas. Some may call them in modern day lingo other effective area-based conservation measures. But also of particular note is that Zimbabwe has got a diverse flora and fauna. And when you look at the area where wildlife conservation is actually a recognized land use area, it's almost 28% of the country. Therefore, why are we pursuing conservation at scale? And where does scale matter? Spatial scale really is important when it comes to effective conservation of wide-ranging species, some which are listed under the Convention on the Conservation of Migratory Species, such as elephants. Those species that also roam our skies, such as vultures, that do not know any political boundary. And we know that, and it's not a secret that wildlife do not recognize all these political boundaries, and they have to straddle across boundaries, not only international boundaries, but multiple land use boundaries also. And the protected area system on its own cannot sustain the needs of several other species. I can talk about the Zimbabwe's cheetah population, for example. Maybe 90% is actually found outside the protected area estate. Talk about the rhino population of Zimbabwe. Almost maybe 70% is actually on private land. So these are very important land areas that are also contributing to the species conservation from a meta-population management, but also to a landscape level conservation. And this is very important if we are to meet the 23 targets for the Global Biodiversity Framework under the CBD, which we adopted, and also making sure that we are creating enabling conditions at national and also regional level to pursue those agendas, the species-related targets, but also some of the targets that requires us to transform our way of doing business and also our way of thinking, especially when you look at target 15 or maybe target 18. Some of these frameworks and targets, they only make sense when they are being pursued also at not only at park level, but also at national level, but even beyond the national boundaries. And this is very important. So for us, I'll emphasize that wildlife conservation and effective conservation of the Zimbabwean components of this TFCA landscape is actually a necessity. We do not have actually option B to maintain and sustain these species. Just to give an example, for example, in the Great Limpopo Transfrontier Conservation Area, I've been a resident ecologist in Gonorejo National Park, which is the second largest park in Zimbabwe, for almost 6 years of my life, doing research there. And surely there's no biology that can explain the elephant population in that park. And I think basically it shows or indicates that there must be several ecological refugees from the other side of the border that found refuge in this park. Why? Because there's safety, food, and also effective management. And for us to solve this elephant density issue that we are actually really grappling with, we need to make TFCAs work. And this is why we have been having regional frameworks for elephant conservation in the Great Limpopo TFCA, but also even in the Kavango Zambezi TFCA. Zimbabwe is pursuing 6 initiatives for TFCAs, 5-country initiative in the Northwest, involving Hwange National Park, the Kavango Zambezi TFCA, the Great Limpopo TFCA with South Africa and Mozambique. This includes Gonorejo National Park, Greater Mapungubwe TFCA in the southwest part of the country, which involves Botswana and South Africa, and the Tuliseko Safari area. And then we've got a bilateral Chimanimani TFCA, and the new baby on the block is actually the Zimoza TFCA with Mozambique and Zambia. And 2 years ago, we saw our principal signing the Lower Zambezi Manapus TFCA. And this is really a growing network of commitments, and also these agreements, they come with obligations. But we need to be always asking ourselves and reflecting, what is it that we are doing? How is the institutional infrastructure framed in such a way that we are able to effectively meet our national and also regional obligations? We've got the approved SADC law enforcement and anti-poaching strategy, which also has got requirements and reporting obligations. So what should we be thinking? What is missing, really? 25 years down the line, we've got a cocktail of instruments and tools that are already available. Is there anything that we need more? Can we be continuously looking for new tools and solutions? How better can we scale up and do better and achieve much more in this landscape? We know we've got guidelines, SADC guidelines for this and that. We know agreements are there, they were signed and deposited with the SADC Secretariat. We've got standards. We've got laws at national level. We've got standard operating procedures that have been developed. But here, when you look at it, it has mainly been also a piecemeal approach. And where we don't have standards or specific documents approved, we talk about established practice to say, okay, this is how we have been doing it anyway. But is that the best approach? There are several obligations and also resolutions, guidelines, strategies that we are adopting each and every year, maybe every 2 years, every 3 years. When you look at the Convention on the Conservation of Migratory Species, there are manuals. But how, in all this maze, how can we apply the environmental management system framework to assist this program implementation and also harmonization beyond just the compliance monitoring of the essential elements that we need to be tracking? And yes, what is this environmental management system anyway? It's very important that we understand that this is not a new concept at all, but as much as it is not new, it's one thing to have tools and solutions produced, but it's completely another to have those tools and solutions operationalized. It has got a 4-stage iterative strategic approach, which is just mainly aimed at continuous improvement. And of course, involves systematically evaluating potential solutions and assessing observations and findings, which is almost like a learning by doing approach. And is this PDCA model applicable to the context of TFCA when you look at those 5 objectives or goals that I shared with you earlier? And at the center of this model is actually leadership. And I showed you a slide with the institutional infrastructure or institutional framework of the TFCA program. How applicable is this when you look at from a planning, through a planning lens? How can we apply this model even in terms of performance evaluation and compliance? We decided to gather data from the 6 TFCA initiatives that Zimbabwe is involved in, and so far we have covered 4, so it's ongoing research. And we have been exploring the status quo to say, just to take a stock of how we are doing things at the moment and where can we make improvements. We've done field visits, we've done key informant interviews, and also conducted some meetings where over 300 people have participated, and also some interviews with some key informants that are not necessarily based in this landscape or in Zimbabwe. So through the planning lens, there was a very fascinating and interesting process that we got involved in eastern part of the Kaza TFCA on the Zimbabwean component around the Binga area, where the community was very actively involved, and we took a very slightly different approach just to see how EMS can also help us do better or plan better. And there's also another project which was funded by the Global Environment Facility in the Mid-Zambezi Valley in the Lower Zambezi Manapus area, where we also produced some plans in a very widely participatory and consultative process. And we also have been working on a land use plan at transboundary level with Zambia. And that transboundary land use plan was completed, of course, with assistance of the CMS Secretariat. And what's interesting, or what's coming out of this approach, is that we have seen that it's actually possible to do actually integrated land use planning and consider a different approach to zoning, but with a very participatory approach, so that because connectivity and also ensuring corridors are available and secured, and engraving coexistence principles at planning stage is very important. And this is some of the work that we have done around Matusadona National Park in collaboration with funding support from the African Parks Network under our collaborative management framework for this park. And one inspiring outcome of this process is that this plan was developed in a widely consultative way, but it didn't take away the ownership of this plan, because outside the protected area, there are other planning authorities such as the Rural District Council. And actually the minister, who is not the Minister of Wildlife, actually launched this plan very recently. So we've seen that it's actually possible, and there was a difference to how we have been doing this as compared to how we have developed other plans or contributed effectively to planning beyond the protected area, because sometimes people talk about mandate. The same we can do with, we have been doing with environmental awareness and education. There's so many initiatives that are being implemented in these TFCAs. But how do we ensure that there is equitable support and frameworks for environmental education and awareness at landscape level, the whole TFCA, because you can imagine that in Great Limpopo TFCA, maybe we have been prioritizing schools around 15-kilometer radius. Yet the landscape is so huge. What about those other schools? Also, how are we rolling it out beyond? We know resources are limited. Bicycles. Not so long ago, we are giving some bicycles for kids that are attending some school in Victoria Falls at Chinotimba, where the whole school with 67 students, every child received a bicycle, and we've been mobilizing these resources with our partners so that they're encouraged to go to secondary school, which was a little bit far, but these are wildlife-dominated landscapes, so that we are able to invest in the future. How we also have been using the radio communication systems and community-based radios, and also introducing ICT more effectively and equitably at. Honestly, the answer has been there is no standard approach. Each TFCA has been doing its own thing, and some of the things have been very opportunistic. But also even use of drone technology. Its application use. Can you fly your drone across the river? Maybe you're looking at invasive species on the Zambezi or on the Limpopo. What are the joint research and monitoring needs that we need as far as capacitation and also use of technology is concerned? Same with tourism. There's a lot that the EMS framework itself and approach can help us standardize how we look at community tourism or even tourism development in general. And even when it comes to human resource investments, how can we use EMS? We've been reflecting on this in terms of giving more opportunities for communities. Yes, around Matusadona, 80% of the staff is coming from the communal area, similarly for Gonorejo. But what about in other TFCA? Are we adopting the same approach? The more recent, new, upcoming TFCA, are we having a standard when it comes to community beneficiation and also various other livelihood alternatives that we are implementing? We need to ensure that there is also equity in all these considerations, be it human-wildlife conflict mitigation and management initiatives, and also even access in terms of opportunities for aquaculture, etc., within the TSA. We've also been seeing how we have been having these response mechanisms. There was some drought not so long ago, and in 1 or 2 TFCAs, we have been able to respond to have a feeding program for the school kids, food handouts for the other communities. But is it equitable throughout what is the standard? Are we not also going to create resentment and other unforeseen or unplanned challenges? We need to have this in our planning and in our thinking. And it's very important. This is why we have been really driven to find ways and explore how we can engrave EMS standard in terms of policy. And these are some of the preliminary findings from the deliberate management-driven research that we've been doing, establishing rules and procedures, risk assessment, and also even reporting. Why this has been really important is that we've got that institutional infrastructure or framework which can make decisions that are legally binding, and that can also help us have this gold standard in terms of how we can move forward together and have more standardized approach to the implementation of the TFCA program. And so how have we been doing it? Inspired by the SADC TFCA financing facility funded projects and other donor funded projects such as the German Development Bank through KfW, even the UNDP project. But this SADC TFCA financing facility, I think it is really inspiring some approach that we can also consider, not only for the SADC TFCA financing facility, but having generic gold standard for all projects, programs, and also how we approach things in the TFCA program. We can talk about environmental and social monitoring and reporting template, not only for the SADC TFCA funded project, but also even guidance on project level, grievance and redress mechanisms. Sometimes really, we have had to think about this when we run into problems and when we've encountered certain situations. Then we start to think, how do we? But we didn't think about it at project inception level. There are various donor-funded projects in these TFCA landscapes, but there is no gold standard that is really standardizing the approach of how we are doing these things. And we've got these already tailored to a specific programming framework under SADC, but it can be scalable. It can also be it's customizable to the various levels and also applicability needs that we need. And we are going to be sharing, hopefully in the near future, about what extent that we can customize this and also implement how we have implemented or applied such standards at a landscape level. We believe, therefore, that a multi-scale and multi-phased approach to EMS application is very necessary, and we need to think about metrics, social assessment, indices, how TFCA projects are impacting on people. Beyond even IMET, we know there are limitations to all these tools and standards, but governance issues, and there's no single metrics or single approach that can give us any indications on how TFCAs are performing. There's just a cocktail of all these, and we need innovation in this space so that we are able to track progress and make sure that we can be able to reflect on what right things that we are doing, that we might be doing wrong, and what are the wrong things that we can correct, and what are the right things that we need to keep on doing, and make sure that we continue to do research and generate new knowledge that can help inspire transformative landscapes that are necessary for the survival of species. And there are some preliminary or emerging recommendations that we are already considering or tailoring to our context for the TFCAs that are involving Zimbabwe. For example, to make sure that we do this environmental review and make sure that there is some planning that is being done or some scoping, and also make sure that we have a good idea of the environmental policy commitments that we need to be mindful of in all the thematic areas, and make sure that we jointly set these objectives. And when I say jointly, it's not only across borders, but across the multi-stakeholder framework that we operate in, and make sure that we jointly make attempts to harmonize the legal and other policy requirements. But not only required, because most of these policies that we say in law, they're only shaped by governments and never really developed with input of donors. But it's high time that in these landscapes that we make sure that we also include those expectations and standards that are expected by our donor community that are supporting and driving also TFCA processes, and making sure that we've got warm bodies that are responsible for ensuring monitoring and implementation of these processes. So this is ongoing research, as I already informed you, and we believe that it's going to result in some practical guidance that will be very useful in overcoming some of the hurdles that we are seeing at the moment. And there are some emerging opportunities also where we believe that even thinking about these EMS standards, or even thinking about biodiversity credits, how can we already think about unlocking the full potential of the biodiversity economy strategy, but also contributing to the Zimbabwe's biodiversity economy strategy, thinking about or mainstreaming or making sure that EMS standards and accountability and responsibility, we always think about it. And perhaps in future, we can be able to see an EMS-based regional outlook for TFCAs, or the status of TFCAs in Southern Africa, or even at any level, so that we are able to be really accountable and reporting back more effectively on metrics that are standardized across the different landscapes. I want to thank you.
Thank you very much. We have time for one quick question. Any takers? At the back there. Thank you.
Thank you so much for that presentation that actually reflects on how countries should be working together, because the ecosystems do not respect political boundaries. I just have I have a number of questions, but I'll just ask one, maybe I'll follow you on the other questions. In terms of implementation of the agreed activities across the different countries, if you could share your experience in terms of are each countries committing enough resources to achieve the common objective for the transfrontier conservation area? And if so, are there mechanisms for reporting regularly where, for instance, one theme that you could have would be having a science policy interaction? What is science saying about this? And what has been found in this country, maybe Zambia, Zimbabwe, South Africa, and how the countries, partnering countries, can work together to respond to the recommendations by science. Thank you.
Thank you very much for your question. In terms of commitment, I believe that the commitment is there because I believe when our leadership append their signatures to those agreements, they are very fully aware of the obligations that come with those agreements. But when it comes to effective implementation and deploying resources, including human resources for advancing those activities or commitments, there is a range, or there are differences there, which due to mainly resource limitations and capacity. So there are differences, but I think as Zimbabwe, not bragging, but I think we've been trying to really demonstrate our seriousness in terms of implementation of the program. We do not have any TFCA without a home body that is responsible for driving the agenda in that landscape. But that's not the same for other countries. And in terms of reporting, the SADC, the way SADC is structured as far as natural resources management under the Directorate of Food and Agriculture and Natural Resources Management is that there is also a technical committee on wildlife where regular reporting is done, and also updates, particularly with regards to the SADC anti-poaching and law enforcement strategy, but also other relevant thematic areas in line with the 2025 to 2035 SADC strategy for biodiversity conservation. And there are differences also from one country to another in terms of when these the information is pulled together, we always see there are gaps, and sometimes we struggle to add pears and apples, or bananas and oranges. So apart from having a generic monitoring framework for TFCAs, the compliance standards at national level are not always the same, and we need to continue developing SOPs to harmonize those.
Thank you very much. Thank you. Next up, we have Anthony Emenu, who's going to be presenting on triggering rapid scaling of agroforestry.
Thank you for being such a wonderful audience to all the other previous speakers. Now, we've heard about biodiversity, we've heard about scaling, we've also heard about sustainability in different forms, so I think it's about time we throw in agriculture there. And in this sense, the logical point to start would be to remind ourselves of the critical role agriculture plays in a number of our different economies. Now, across most of the sub-Saharan Africa, most economies still depend on agriculture significantly, and this is statistics from 2024, just last year, and up to about 70% of the population of Uganda still depends on agriculture for employment, and close to 35% of GDP is contributed to by agriculture in a country like Ethiopia. So the whole point of this is to underpin the importance of the sector. Now, most of the food we might have consumed here and in most countries to date has been produced by smallholder farmers. Now, most of these farmers depend on rain-fed farming, often degraded soils, and because of this, they're highly vulnerable to climate change shocks. according to one of the reports, that's 2022, even when the available adaptation options could be accessed by the smallholders, they can no longer utilize them, largely because of these vulnerabilities that they experience. Now, the few options that are available that could be utilized, despite all these challenges, is agroforestry. So basically, the integration of trees within their farming systems. A key reason why the agroforestry is so attractive is its contribution to biodiversity. I talk of its improvement in the productivity of the existing systems. But most interesting for myself is its possible contribution to a socioeconomic well-being of smallholder farmers. That only works provided two conditions are met. The first is that the trees being integrated are appropriate for the farming system within which they are being placed. Then the second thing is that there should be market for the products coming out of that system. Otherwise, it wouldn't work. Now, the problem is that despite all this and plenty of evidence out there, most of the programs promoting agroforestry across the continent struggle to attain scale to the level everyone would be excited about. Of course, there isn't a shortage of evidence either on why some of these programs fail. If you Google right now, the chances you'd get so many reasons. But what is really unique is that there are very few cases that demonstrate success against the odds. But of course, there is no shortage of outliers, and among those is the International Small Group and Tree Planting Program, TIST. Now, this program has been around since 1999 and is running across most countries in Africa currently, and in India as well. In Uganda specifically, program has been around from 2003 and has scaled to all the different parts of the country, with the scaling spiking slightly after 2020 and delivering so many socioeconomic benefits, environmental and ecological benefits as well along the scaling pathway. Now, a key benefit I'd like to draw attention to is the carbon finance that the farmers have been able to access through this program. But none of this is really exciting, right? Reason being that the one thing that makes this program unique is that all this is happening with very minimal investment from the outside. All this is grassroots-driven action, which speaks to sustainability at so many levels. Now, of course, the logical place to start questioning why this program is so successful is the design of the program itself. And the program basically, it's built around smallholder farmers forming groups of 6 to 12, and then 30 to 50 groups form a cluster coordinated by a cluster server, and that's basically an extension worker within the program. But what this program does right, and which makes it stand out, it does two things. One, it gives farmers agency over who is in their groups and the group governance, and two, it gives them agency over the choice of what to plant, where to plant, how to plant, when to plant. And the most exciting bit of that is that it rewards action. So basically, when farmers plant the trees, and the program, once a farmer has planted the tree, the program starts giving them a fraction of what the trees basically, the program gives them a fraction of what they would get from the sale of the carbon captured by the tree. So, and after about a year or two, once the tree is about 2 meters high, they start quantification, and then 70% of all the sales from the global carbon market go back to the farmer. So, so that is one thing that we thought the program did very well, and we wrote that up in a paper that you could access through that QR code. Now, the second bit is we looked at scaling at location level. And of course, we started with places where scaling was very successful. And based on that criteria, we sampled 2 places in Uganda. A location in western Uganda called Bushenyi, which basically has a hilly landscape, has 2 rainfall patterns. And agroforestry is basically the primary land use system there, even before the program. Then the second location is in eastern Uganda, which could be easily described as a grassland. So it has 1 rainfall pattern. Most of the cropping systems rotate around annual crops, And then most of the trees utilized in these homesteads are fruit trees. What we should remember is that in both these locations, there are very high rates of scaling, so very high rates of adoption. So that's one thing we should always keep in mind. And through the engagements, we just try to seek out to understand why the farmers picked interest in the program, why do they stay involved, why do they join in the first place. And then for the leaders, we try to understand the diverse drivers for the scaling in their respective areas and try to tease responses to other complaints that came from the farmers as well. At the end of this long exercise, ended up with a total of over 52 interviews across the locations over a 3-month period. And we coded all this into adoption enablers and disenablers. Now, moving on to that, we found that access to land is non-negotiable. So basically, in places where people had access to plenty of land, they went for it, they just took on the program. And where there were difficulties accessing land, the decision was much more complex and slower than we would have preferred. And then where land wasn't a problem, the promise of payments and witnessing other people receive these payments in time became a major attractant to participation. Now, contrary to that, every time people had reports of delays in payment, the majority just chose to step back and wait and see what happened, which basically slowed down the scaling process. Now, most of these delays in payment led into internal conflicts, which manifested in the form of group members blaming their leaders for suspicion of misappropriating the funds, and often this was linked to miscommunication. However, when you interrogate the leaders of the program about what could be causing the delays, they point to policy or operational issues, largely linked to inadequate staffing, a rapid explosion in demand of the services, then occasional equipment failure, and all this eventually leads to a cascading effect that causes some people to just lose interest in the program. Now, overall, and this is a very logical point, basically in places where people are already practicing agroforestry, transition through planting more trees was very easy because for them, this was free money. They were not doing anything different. While in places where agroforestry wasn't a dominant practice, it was more difficult to convince participants. And as I mentioned in the beginning, everyone in this program starts off as a smallholder farmer. So in certain cases, you engage a farmer who turns out to be a local group leader, who turns out to be a pastor in a local church, and some of these people became very influential in providing, giving the program the momentum in recruitment of participants along the way. Now, bringing all this home, we can sum this all up into 4 points. 1, resource access is non-negotiable. So policies at maybe government or institutional level that enable that could drive adoption of agroforestry. And then, of course, institutions that intend to scale have to be prepared to take on the challenge. So basically, once demand explodes and you're not able to meet that, it may not only hurt the scaling process, but it could hurt the reputation of the institution as well and kill all the other interventions coming behind. Then, of course, our consistent and predictable payments of economic incentives are essential to create the initial momentum of scaling, but building markets and creating market linkage could provide for long-term sustainability of this intervention within the spaces. And of course, it always pays to ride the wave of the people who came before you, and preferably either cultivate local passion or identify passionate leaders and work with those. Scaling of these practices is not just about solving one individual problem we might find in literature or promoting a specific innovation. It's about building systems that reinforce so that as a promoter, you could have early retirement and just watch your project grow. So think of it like all the actions you might have in there reinforce each other. An example I've thought of here would be think of just starting with a smallholder farmer who you did not know was a pastor or a local leader at one point. Then that person influences the local policy, and then the policy opens up spaces for everyone to enroll. But then the flip side is that if that person does not get payments on time, they decampaign the whole program, and then the whole process reverses. So a lot of it is about balance and working with actors, having a shared vision, collaboration between actors, adaptability, but most importantly, giving the right people the agency to make the decisions they have to make when they have to make them. In the case of TIST, it's smallholder farmers. In your case, it could be any actor, it could be the rangers, whatever program you're doing. So this brings me back to my concluding point. Whatever intervention you're trying to scale, whatever ideas you have, the whole point of this presentation is to move from the doom and gloom and tell you that it is possible and there's a mechanism to achieve that, and we are available to have a conversation about how we can help. Now, I'd like to thank the University of Exeter and the Oppenheimer partnership for making all this possible, but most importantly, the smallholder farmers for providing insights that I'm sharing today. Thank you very much.
Thank you very much. One quick question at the back there. Thank you.
Thank you very much. Two quick questions, sorry.
Yeah.
One, are you encouraging the farmers to become organic? And second, who is designing the systems? Is it the farmers, or through education you are supporting them to design the agroforestry systems?
All right, thank you. I did not hear the very first question, but I'll answer the second one, then you can repeat the first one. Now, when it comes to the system design, the program basically has a generic framework. So what happens is farmers register and get recruited. Then at the higher program level, they have a model that ensures that groups meet on a monthly basis. The cluster servant trains, and then they have a tradition of sharing information between group members and different clusters at a higher level. So on a monthly basis, the program releases a newsletter on good practices. That's at the program level, and that's shared across all the program areas in the country. Now, at the farmer level, all the decisions at the group level, whether it comes to conflict resolution, who is going to be a member, where to plant, and everything is done at the farmer level. So every single group has its own modalities of how they deal with problems and how they work out the whole process, but with guidance of a cluster servant who is recruited from the farmers, but remunerated by the program itself.
Thank you.
And the first question?
Just if you're helping them to stop using chemicals.
They don't use chemicals.
Thank you.
Thank you very much.
You're welcome.
And the final presentation for the session is by Dara Hare, and he's going to be discussing morally contested conservation. Thank you.
Hi, everyone. Can you hear me okay? I won't ask if you can understand me okay. That's a different question. So thanks very much for the opportunity to talk about a research collaboration that we call morally contested conservation. And in this presentation, I'd like to give you an overview of who we are, what we do, why we do it, and some of the findings that we've got so far. So the background for our collaboration is that high biodiversity areas in sub-Saharan Africa are focal points for sometimes quite intense international disagreements over how to conserve wildlife. And competing answers to questions such as these often suggest that there are these quite stark differences in worldviews between people who live in the high biodiversity areas in sub-Saharan Africa and those who do not. And sometimes these differences feel almost irreconcilable. And this matters because every day local, national, and regional decision makers need to make very difficult choices that will impact wildlife in the region and also impact millions of people who live and work in the region. And many of these decisions are highly contentious, but evidence is often lacking. So our team collects that evidence about how people living in different areas think about these contentious issues, and we communicate the results to people with the ability to effect change. So we are an international group of collaborators centered around 4 extremely talented African students, Betty, Saloom, Yolanda, and David. And we work closely as a group, emphasizing collaboration between students across 3 continents. And the students learn with and from each other, forming a very dynamic cohort supported by Lovemore, me, and Amy. And now I'm the one giving this presentation, but we're fortunate enough to have the entire team except Tricia here with us today. So if you don't already know the gang, please introduce yourself, say hi, get to know them. So far, our collaboration has focused on a set of topics that appear to be especially controversial internationally, where the local and the distant perspectives might differ substantially. So we have looked into the types of human-wildlife interactions that should or should not be criminalized, and punishments for breaking those crimes, hunting, including trophy hunting, conservation law enforcement, including those approaches that some people refer to as militarized, and the most legitimate mechanisms of wildlife decision-making. And to study these issues, we combine on-the-ground fieldwork with large-scale online methods to systematically measure and compare how multiple groups think about these controversial issues. So people living in rural and urban areas of sub-Saharan Africa and people who live in rural and urban areas of the UK and the USA. So we work in 2 trans-frontier conservation areas, one in East Africa and one in Southern Africa. And we have 5 rural project locations across 3 countries. And these places where we work, where we do the in-person field work, are biodiversity rich. They're also focal points for extreme international interest and funding. And they're land use mosaics that are home to millions of people that work in landscapes. So we tend to categorize the different samples that we have into local and distant publics. So the local publics are those who live in the high biodiversity areas, and the distant publics are the people who live away from those high biodiversity areas. And for this purpose, we consider people living in the urban areas of sub-Saharan Africa to be a distant public. And we've collected data from more than 3,800 people, including more than 2,200 people whose perspectives are seldom heard in some of these controversial decisions or contested decisions, but who are directly affected by those decisions. And this allows us to use quantitative comparisons to generate new knowledge on international perceptions of these issues that can be very polarizing. Excuse me. So we also consider the communities and the people who live in our study community, in our study locations, to be partners in this research. So at the beginning of the project, we visited the communities. We asked for permission to do this research and to understand the challenges that the people living in these areas experience with conservation. And an important part of our research, and we were fortunate enough to have funding to do this extra step, was to return to the communities where we collected data before preparing any publications. So after an initial data analysis, we returned to the communities to present and discuss our initial findings. And we asked the communities to help us understand why we might have received these responses from people living in the communities. So this allowed us to get the stories behind the numbers, if you like. And this step allowed us to, well, it made our science better and more accurate. And it also helped to ensure that we could sensitively and accurately reflect the community perspectives in our scientific and non-scientific outputs. Excuse me. So I'm going to summarize some findings from one research topic, and that was conservation law enforcement. And this is very divisive and very emotive, and that was illustrated and encapsulated in the film that we watched in this room last night. And this topic was especially sensitive in the communities where we work. And it was perhaps especially polarizing relating to activities associated with militarized conservation, which is often defined as using military-style techniques, tactics, practices, equipment, personnel to protect biodiversity in conservation spaces. So across 2 studies, we asked people about how acceptable or unacceptable they perceive a variety of law enforcement activities, things rangers do. So we looked at rangers stopping and searching people, arresting people, monitoring people's movements, carrying guns, and in a separate study we looked specifically at when rangers might shoot at people they suspect of breaking conservation laws. So we found that perspectives on these activities were not monolithic. In fact, acceptability of these different ranger activities depends on what rangers do, where they do them, and why they do them. So generally, rangers' activities that occurred inside a protected or conserved area were seen as more acceptable than outside the PCA. And that finding was consistent across all publics, the local publics and the distant publics. And that's maybe not very surprising because people tend to see the PCAs as ranger territory and they're allowed to operate inside there more than outside, but it complicates law enforcement activities because sometimes rangers need to operate outside the PCAs. And the relative acceptability of these 4 activities depended on whether they would occur inside or outside the PCA. So those activities that were seen as more acceptable inside the PCA were not always those that were more acceptable outside the PCA. And you can see that because across all the combinations, the examples we looked at, the most acceptable activity overall was when rangers monitor people's movements inside the PCA, and the least acceptable activity was when rangers arrest people outside the PCA. And we as a team were surprised that maybe carrying guns wasn't the least acceptable one. But this makes a bit more sense when we understand that ranger activities were more acceptable when they would protect people from wild animals and when they would help reduce poaching. And this finding, I think, suggests that people see protecting people and reducing poaching as core responsibilities, things that rangers are expected to do. So of all the aspects of conservation law enforcement that we looked at, by far the most sensitive one was when rangers might shoot at suspected criminals. And maybe unsurprisingly, shooting at people was not very acceptable. Acceptability was low across all publics, the local publics and the distant publics. However, it did depend strongly on which crime rangers would suspect those people of committing inside the PCA. So this kind of makes sense because it reflects this general recognition, and this is what the community has told us, that rangers have a right to defend themselves. And most often, poachers will be armed, so rangers have a right to be armed too. So overall, we found that ranger activities, all these activities, were more acceptable to the distant publics than the local publics. And the exception was in Magadi in southern Kenya, where perspectives there looked more like the distant perspectives than the other local perspectives. And maybe this is because the PCA there is a community-led PCA, where the rangers are community scouts, they're from the area, they speak the language, they are trusted, and they are not typically armed. So, across these 2 studies, we found no outright endorsement or rejection of militarized aspects of conservation. It's much more complicated than that. And we were surprised at acceptability for some aspects, was so high, especially when people live near the strict PCAs. And we found some evidence of a global north, global south divide, but a more complex local distant divide in perspectives seems to be emerging from our data. And that more complex local distant divide maps onto another study that we published earlier this year. So we wanted to know how people in all these 10 publics think about two enduring ideological divisions in international conservation. Should conservation prioritize the interest of people or the interest of wild animals? And should it prioritize the interest of individual animals or groups of animals? And what we found was, again, that the major dividing lines seem to be the people who live in the high biodiversity areas versus the people who live further away. And we think that these differences in priorities or values or worldviews might explain why conservation programs and policies that seem more acceptable to donors, funding agencies, researchers, etc., from outside of the high biodiversity areas might be less acceptable locally, including conservation law enforcement, but also things like hunting, culling, and translocations. So I hope that gives you a glimpse of who we are, what we do, why we do it. And we're looking forward to continuing this research in this period between now and 2030, where many more contested issues are surely going to have to be looked into to make sure that the decisions that are made on where the international community goes reflect the diverse voices. So I'll leave you with this diagram, and Betty Rono in our team likes to think of our collaboration as a tree. And that's a tree with roots in collaboration, communities, and evidence, yielding fruits in the form of scientific and non-scientific outputs, and continuing to grow and produce fruits into the future. So with grateful thanks to our funders, this research would not be possible without you. And also special thanks to all the people who helped along the way. Thanks.
Thank you very much. I'm just going to allow for one quick question, if that's okay. Anyone? Right at the back. Thank you.
Thank you for the very interesting talk.
Thank you.
Unsurprisingly, it came out that a lot of people want to prioritize wild animals over people. What do you think needs to happen to shift that mindset? Because it doesn't work. We tried that already.
So I think you ask a question that's at the heart of all this. We can document these moral divisions as researchers. I think that's our job. We can provide the evidence about the contours of these divisions. Changing stuff, I'm not sure that's researchers' job, right? That's the people who've got the mandates to make decisions, or maybe it's the job of the advocacy organizations. But I think that in order to manage these moral divisions, you first of all need to understand them, and that's where we've got. This is maybe just a long-winded way of dodging your question, because it's a very good question and a very difficult one.
Thank you very much.
Thanks.
Thank you to all the presenters. You've let us take a lot of food for thought with us as we digest our lunch, which apparently is served under the trees. Thank you.
Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves. There's no one I can turn to. And I know all the feelings that we shared out in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. We're moving on. We're moving on. I know times are
All right, I'm Wendy Pinena, and I'll be chairing the session this afternoon. Those of you that heard my chairing session last year, there's going to be no funny business this year. Let's all keep it together, please. All right, first up, we've got Rafiwe, and she's going to be telling us, well, she's going to be looking at assessing nitrogen dioxide in the Highveld troposphere. Over to you.
Thank you. Good day, everyone. My name is Refilwe Kais Kakane, and today I'll be telling you a little about one of the objectives that we investigated during my PhD research, which was assessing nitrogen dioxide in the Highveld troposphere. Nitrogen dioxide forms part of the pervasive air pollution and the cause of some of the associated air pollution consequences. Nitrogen dioxide is not in itself a greenhouse gas, but it indirectly contributes to the warming by forming tropospheric ozone, which is a greenhouse gas. Globally, nitrogen dioxide emissions from various sources have been increasing, especially in developing countries such as South Africa. With the increasing atmospheric nitrogen dioxide concentrations comes increasing environmental and population health issues such as acid rain, soil and water acidification, smog, increased algal blooms in natural water systems, biodiversity loss in sensitive habitats, and exacerbated human respiratory conditions such as asthma and chronic obstructive pulmonary disease. The World Health Organization has emphasized that nitrogen dioxide is a major pollutant of concern. So the Highveld area, as you can see from the map, the Highveld area has been identified as a pollution hotspot in Southern Africa with the Mpumalanga Highveld, those green triangles there. The Mpumalanga Highveld having most of the coal-fired power stations, which are more than the other Highveld provinces. So in addition to the coal-fired power stations, there are other sources of NO2 in the Mpumalanga Highveld, such as emissions from vehicles, biomass burning, and burning from surrounding settlements. The NO2 concentrations in the Highveld are reported to exceed the national air quality standards. Hence, it is important that we understand the concentrations in that region. These concentrations are comparable to emissions in developed and highly polluted regions such as North America and Southeast Asia. This here is an image of tropospheric NO2 concentrations over Southern Africa, just to show the elevated concentrations over the Highveld. And this is an image from the 31st of August 2025. So, however, with all this that's been mentioned, South Africa has scant air quality information due to the lack of resources to measure the trace gas concentrations. So this is a map showing ground-based instruments called Pandora. And as you can see, the global north has a lot of these instruments, but the global south does not. In Africa, we actually have 2 operating instruments, and they are both in South Africa, and I worked on one of them for my PhD. So it is important to understand the distribution and transport of the emissions in the troposphere, since the troposphere is the layer of the atmosphere where most of the emissions are released and also where the air that we breathe is. For that reason, we worked on filling the gap of scant air quality data in South Africa by leveraging tropospheric nitrogen dioxide data from a Pandora 2S ground-based column integrating instrument located in Wakkerstroom in the Mpumalanga province of South Africa. And we also use space-based remote sensing data obtained from Tropomi on board the ESA Sentinel-5 satellite. This study was done at Wakkerstroom, which is a small town in the Mpumalanga Highveld, located downwind majority of the coal-fired power stations, and also located close to the Gauteng-Tshwane metro, which is highlighted in blue in image A. So we used the ground instrument, the Pandora, in max DOS mode, and a satellite instrument, the tropospheric monitoring instrument, Tropomi. The Pandora instrument is a sun photometer with a dual spectrometer system. It measures trace gases in the ultraviolet and visible spectral range of 270 nanometers to 530 nanometers, and in 400, and also from 400 to 900 nanometers. The instrument scans the sky at various elevation and azimuth angles. This sped up video that you just saw shows how the instrument moves as it measures the tropospheric NO2 concentrations. The different elevation angles make the instrument sensitive to different levels in the atmosphere, so at different altitudes, thus giving us integrated tropospheric NO2 concentrations at about 6 kilometers above ground. The tropomi scans the Earth from space, so it looks from the top to the bottom, and it scans the entire Earth daily, and it has a local overpass at 1330 at each location, and it gives us concentrations of the full tropospheric column. Right. I'm not going to go any further into the specs of these instruments. If you want to know more about the nitty-gritties of how these instruments work, we can have a chat during the break or after the conference. Otherwise, catch me outside. So now I'm going to give you some of the findings. There are a lot of them. So these findings are as follows. The comprehensive results can be read from our published manuscript. I will put it on the Slack. So we found peak Pandora measured NO2 concentrations in spring and in summer. So what's the big deal about that? Hey, we found peak concentrations, and so what? So our findings from the ground instrument measurements are actually contrary to the literature and the satellite-derived concentrations. And the literature and the satellite-derived concentrations showed elevated NO2 concentrations in winter. But we found them in spring and summer. And this can be attributed to a few things, such as the transport of air masses to the site where we actually measured the concentrations, and also to the stable atmospheric layers in the high veld, which caused the mixing of the NO2 in the tropospheric column to not be as good at that point. So in this figure, which was derived from high split, which is an air mass backward trajectory model, we can see that, so from the top, yes, the top arrow, it's 54%, so 54% of the air mass trajectories that arrive at the site are actually from the east of the site. And so these air masses are loaded with NO2 concentrations from southern Mozambique, Eswatini, and also recirculated concentrations from the high veld, including emissions from coal-fired power stations. So this study also provided insight into the combination of the various sources that contribute to the NO2 concentrations measured at the Wakkerstroom site. The image that we have here shows the active fires during 2020 in parts of southern Africa, and this shows that in addition to power stations, there are also biomass burning emissions, wildfire emissions, and other emissions that are not mentioned today. Okay, so we have more data, we have a better understanding, and then what? So studies like this one, they contribute to the understanding of pollution, one trace gas at a time, one site at a time, and also to the associated consequences of air pollution. In the past few hours, from yesterday till today, it has been reiterated that air pollution is one of the main drivers of biodiversity loss in certain habitats, and that increased temperatures increase bird mortality in tropical forests. And also it has been reiterated, or also it has been mentioned that the adaptation of biospheres to pollution is one of the research questions that are still going to be investigated in the future. Therefore, it is important that we understand the sources, heterogeneity, and the dispersion of criteria pollutants such as NO2. Thank you to all the sponsors, the software engineers, instrument calibrators and operators, and my supervisors for making this study possible. I appreciate you. Thank you.
Right, thanks, Refiwe. Any questions? Concerns, complaints, suggestions? Yes.
Thank you for the presentation, Refiwe. I just have a question around where our emissions are going. Since you said most of the nitrogen emissions in your study site come from Mozambique and Swaziland, where do our emissions go then?
Oh no, so they are just a contributing factor to the ones that we are also emitting. So I mentioned the recirculated emissions in the Highveld, which would come from the Gauteng-Tshwane Metro, and they would also come from the power stations, the coal-fired power stations in the Mpumalanga Highveld. So in addition to that, with the emissions from southern Mozambique and Eswatini, then we see a higher concentration of the NO2 at that particular site. So it doesn't mean that our emissions are not part of what we saw. They definitely are.
Any other questions?
Sure, this is really next level, almost one could say sci-fi, but I want to, in contrast, maybe ask a stupid question, is that the nitrogen fixation by lightning, especially in Highveld, that cannot lead or in the equation of NO2, as well as even getting more nitrogen out of the atmosphere, or is that not really significant? Is that too small an amount to take into account in the whole nitrogen balance, the fixation of nitrogen by lightning?
So it is something that has to be taken into account because of the whole nitrogen cycle. However, for this study, we do not look at that. But yes, it also contributes, yes.
Okay, we have time for one more question. Aha.
Hi, Refiwe. My name's Glenys. I noticed your study was in 2020. Do you think that was obviously over COVID period? Do you think that the quality and the levels that you measured would have been affected because there was less activity, less travel during the COVID period?
So it could have. We did not look at so we didn't have data for 2019, therefore we could not have compared the nitrogen concentrations in 2019 to those that we found in 2020. However, we did look at the 2021, and the 2021 concentrations show that as much as the elevated concentrations were not necessarily seen in spring, but they were seen during the transitioning from winter to spring, and also from spring to summer. So yes, COVID could have played a factor, but we did not have 2019 data in order to compare.
Great, thank you so much. If you've got any further burning questions, she'll catch you outside. Okay, next up, we've got Stephen Johnson. Has anybody read the title? Big Data's Big Daddy, Aerial-Borne Multi-Sensor Data Collection Beyond the Curve.
Hi, many of my old friends, young friends, new friends, and to-be friends. Lovely to see you all. Good one. Today, I'm going to talk about big data's big daddy and aerial multi-center data collection. About 40 years ago, a young man set out seeking adventure, flying an air balloon across many parts of southern Africa. And he fell in love with its landscape and its wildlife and its whole sense of vastness. Skip Darlington, an American. And in the intervening time, he put together a team of people that looked at trying to use aerial-borne platforms for conservation. But around that time, 40 years ago, there was a young man that was just starting his career in national parks in Zimbabwe, and that was me. And over the years, we communicated somewhat, and it's in the last 5 years that we got together and saw the potential of actually taking this further. So what we bring you today is an innovation that can revolutionize conservation research that we feel. It's an airborne platform that can stay aloft for 10 days and operate 24 hours a day. And on board is high-tech, high-resolution sensing and a supercomputer that goes with it. We call it the sensible option. Now, innovation is when you take two things that already exist and put them together in a new way, and that's what we feel we've done. But who are we? We are an NGO that looks at enhancing environmental intelligence and research. We're a team of aviation, sensor, and environmental management professionals in our team. We support research to collect specialized, aerially sourced data, and we focus on biodiversity, environmental management, and sustainable development. Our area of expertise is that we've developed and patented an autonomous, remotely piloted airship that is equipped with cutting-edge sensors that survey the ground below in flight. Now, these sensors can collect and image thousands of square kilometers on each mission, gathering data from below, that is, across a wide range of wavelengths and radio frequencies with superior resolution and at a fraction of the cost of satellites and other similar platforms. So from a research point of view, our problem was that we saw that aerial collection of data is constrained by its high costs, especially with airplanes and helicopters and things, the short aerial duration, the limitation on the scope of the data collection equipment itself, the limited resolution of the data collected. And we saw that this constrains a lot of research. And so we looked at the various options of satellites and aircraft and ground truthing, and there's still high costs there or problems in the times that you can actually collect data. And we looked at resurrecting and enhancing old airship technology so that it's extended with its duration of being aloft, putting on board high-tech sensors, 8 of them, maybe 6 sometimes, with an immediate onboard and analytical capacity. So the data sensors can collect the data and it's analyzed on board and then it's relayed to a ground station. And it can be collecting specific data that you program it to collect. And we feel that this will enhance a lot of research that is going to be available. So we have an airship that flies at an altitude of between 1,200 meters up to 10,000. It can cruise at 35 knots, maximum 60 knots, and stay up in the air for about 200 hours, which no airplane or drone or anything like that can do. And we can cover vast areas at a time. But our special competitive advantage is Discovery One, our sensor suite, which uses near-infrared high-resolution spectroscopy, thermal imaging, and daylight RGB with our onboard AI processor. Now, it sounds amazing, but it can operate at 25 trillion operations per second for real-time analytics. Okay, I'll talk about that later if you're interested. It provides 3D reconstruction and geolocation with stereoscopic imaging and additional things. It can have bioacoustic microphone arrays and liminal lighting for operating in certain night situations. We looked at a number of different imaging and data gathering sensors that are available, and we have compared everything with what we've been able to produce, which we feel is our cutting-edge offer. So as it flies and has a radar frequency operating below it, it can cover a swathe of 60 kilometers, seeing 30 kilometers on either side, and can detect objects, especially moving objects, in high definition. So, for example, if we were looking down on a suburb and looking at a mall with this parking lot, we'd be able to see certain vehicles and even identify these number plates and things like that, even at night using thermal imaging infrared equipment. Our secret sauce is our shortwave infrared sensors. Now, if you look at this as an ordinary photograph, and if you really look hard, you might see some vague images of a building behind. But with our equipment, we are able to transform that so that it penetrates any smog, smoke, mist, or even snow. We've tested it even in snow. So that's the kind of sensing you can see under very adverse conditions. Its resolution is amazing. At 4 kilometers away, what would be a real-life example on the left is the image we would be able to see at 4 kilometers. That's 30 blocks of a city. And even at 17 kilometers distance, we could program it to identify that if something looked like that, it would be an elephant and very likely its calf. So if we were looking at what can we do with this, we can use it for general population counts, tracking herd movements, identifying sick or injured animals, assessing health and fitness, assessing conditions of grazing and vegetation, and even doing real-time and phase-time vegetation assessments. And we are now exploring machine learning to be able to even track individual animals in a herd. It can monitor endangered species as well, which is an important aspect that we're offering. And the stereoscopic sensors I mentioned before are used for tracking birds and marine animals from the airship on 20-meter-long carbon fiber rods with sensors on the edge. And they can geolocate resting birds and birds in flight and bring to life a whole different area of research. So what's our possible contribution with the findings that we've had? We can enhance early threat detection and crisis response, such as in human-wildlife conflict. It can support governance and enforcement activities, such as anti-poaching, illegal fishing, illegal logging, mining, and for either real-time response or for strategic planning to go back to at a later stage. We can improve ongoing management research through monitoring, predictive models for climate, biodiversity, and resource management. And also, it can enable continuous low-cost change measurements in carbon offsets, hydrology, habitat, and protected areas. From a social side of things, we work with communities to ground truth of some of the research and findings, provide data to them for some of their challenges, and even share data with them for the agreement for local enhancement, and empower communities with this data and help them build their leadership for effective long-term management. So the pain points that we want to avoid or help you avoid is eliminating high aircraft costs, minimizing the data gaps from cloud cover and the revisit delays that you have in satellites, reducing the processing lag that we can actually operate in real time, and it also provides contextual big picture missions using our field sensors. So we bring you an innovation that we feel can revolutionize conservation with our airborne platform and the high resolution sensing. So if you need to and you're interested, please contact me and we can discuss how this might help you with your research and help with our sensible option. Thank you very much.
Thank you, Steve. Any questions?
Hello, thank you for presenting a fantastic subject, but one thing that concerns me is the fuel that this airship uses. What would that be?
So it's a combination of renewable energy with sensors on top of the airship itself from sunlight, etc. And there is some onboard diesel or aviation gas that can propel it. So it does carry a stock of that so that if it needs to, in adverse conditions, be able to move around and not get kind of trapped in certain circumstances.
Thank you very much.
Lots of questions.
I'd like to just thank you for a very interesting presentation. I'm curious about the resolution, the ground resolution that the sensors can provide for imaging. And you showed us a picture of an elephant, which definitely looked like an elephant. You also mentioned that it could read car registration plates. And to me, those seem like very different kind of orders of magnitude of resolution. Do you actually have a figure, in terms of pixels per centimetre kind of thing that would help us understand what could actually be seen on the ground?
We have that, okay, and I can give it to you virtually immediately after this, but I don't have it in my head right at this moment.
Okay, that's fine, thank you.
Yeah.
Hi. What's the reason for doing the processing on board? I'm just worried because now getting your raw data goes there, processing takes place, but heck, your airship just crashed. You've lost your raw data. So what was the thinking there?
Okay, the good question. The processing can take place at such a high rate, and that's huge data that's being collected. Okay. And you can program it to only send down or up to through satellites or to a base station certain information that you need. Okay. So instead of trying to dump all of that huge data at a time, it stores it up there, sends you what you need at that particular stage, or just leave it up there, storage, and when you land, you can get access to it. So that's the reason for onboard.
Same problem if your machine crashes, though. But I'd like to chat to you afterwards then.
Sorry?
I'd say it's the same problem if your airship crashes. It's still lost the raw data. So we'll chat.
Yeah, but that happens in a light aircraft as well, so same situation. Sorry? The airship. It varies according to what you need and what payload you want to carry with it, okay? It can be from about 10 meters up to about 40 meters. They can be very, very large. Yeah.
Hello, I'm Simone. This is a very fascinating product, but I am curious about the risk of hacking. It has a lot of benefits for conservation, but when monitoring endangered animals, what's the risk of this being hacked by poachers also looking for those animals?
Okay, thanks. So almost similar to the previous question, if you then programmed anything like that it's an endangered species being found, that data would be kept on board and not transmitted via satellite down to the ground station or directly to the ground station. That you could program to be kind of kept aside and on board.
All right, I think that's all the time we have. I get the sense that there's far more questions, but you can catch Steve
Please
during
do.
the tea break.
Thank you very much.
All right, next up we've got Stu Behop, and he'll be talking about from fields to flyways, population regulation and conservation in migrating birds.
Okay, I'd like to begin by thanking all the Oppenheimer team for the opportunity to talk here today, even if it was last minute. And I also have to come clean because I'm a pretty temperate biologist, and I'm not really going to be talking about any African ecology here, but the lessons I hope you might learn from this will be very applicable to the systems you're working in. And we've heard a lot about animals moving across boundaries and the problems of trying to manage animals that are highly mobile. And this is really kind of hopefully some of the lessons I'm going to talk about today. So it's going to be geese and swans, and they're obviously quite scary in the London Underground. So migration is a global phenomenon, and it involves the movement of billions of individuals on an annual basis. These are huge volumes of biomass moving across the globe, and they play important, and migrant birds in particular play really important roles in the ecosystems they visit across the annual cycle. So they can be predators or prey, they can be pollinators, they can be seed dispersers, they can be pests, and I'll talk a little bit about an animal that is perceived as a pest. They can be controllers of pests, and of course, they are hugely culturally significant in the regions that they move to. So they're the harbingers of the change of seasons, they feature in poetry, literature, art, etc. So an important group of animals, and migratory birds in particular, are an important group in that respect. But it seems that migratory bird populations are in crisis, so we've seen lots of stuff like this. We know we're losing birds at an enormous rate, probably billions of individuals since the 1960s. Top panel is one for Northern Europe, for Afro-Palearctic migrants. The bottom panel is North America. They're estimating 800,000 birds per square kilometre going missing over 10 years. These are astronomical losses. But you can see from that bottom panel it's not uniform. And this, we have some species increasing in number, some migratory species. Some species like this willow warbler, this is a BTO plot of willow warbler population trends in Britain and Ireland. In the southeastern part of its range, the grey, it's declining. In the northwestern part of its range, Scotland and Ireland, it's increasing. Diagnosing the causes of these things is quite tricky, particularly when we only got population level estimates. Beyond the kind of obvious, there's climate change and habitat change going on. And it's even more complicated because the responses to changing environment vary among species, vary among populations, vary within populations in time, and vary within populations in space. So it's a highly complicated issue. And this is some work one of my postdocs did a few years ago, just to illustrate that migration is a costly behavior. So we did an analysis of life history traits in migratory animals, both mammals and birds. This is just the bird data. All you need to know is that bottom axis is a measure of the pace of life. So lifespan, age of first reproduction, number of offspring they produce. And you can see full migrants, which is FM in the top, have a faster pace of life than partial migrants, which in turn have a faster pace of life than residents. So migration is probably costly because it's shaping the life histories of these animals. And of course, we can interpret this in two ways. This may mean that these migratory animals are kind of on the edge because they're living this highly energetic lifestyle, and so additional insults may cause problems for these populations. But of course, those higher reproductive rates may also mean that they can buffer better the effects of change as it happens. So it may be a response to living in these stochastic environments, because migrants have no real way, that we know of anyway, of predicting the places they're going to, or the conditions of the places they're going to end up in. And the conservation of migrants is tricky. For a number of reasons, I'm only going to talk about two of them here, otherwise I would be here till the end of the day. One of them is, for some time, ecologists tended to teach the annual cycle of animals as a series of black boxes. But we've known for a while that actually what you can achieve in one season is inextricably linked to what you did in a previous season. And in terms of migration, we call these processes carryover effects. So something like this European, oops, sorry, I didn't mean to do that. Something like this European roller, wintering in East Africa, may settle in a really good territory, get loads and loads of insects during the winter months, and that allows it maybe to migrate early back to Northern Europe or have more resources to devote to reproduction when it gets to Northern Europe, and as a consequence, it increases its fitness. And so we could be looking at variation in roller productivity in Europe, going, well, what's going on with the breeding grounds, when actually it's a phenomenon that's been driven by resource access during winter. So these carryover effects could act as mechanisms of regulation, and it means, again, diagnosing decline of populations is really difficult. The other obvious problem is that migratory animals, and migratory birds in particular, do not recognize national boundaries. So many countries are important to single species, and they're quite often, the protection given to these animals quite variable across the range. So this is a pink-footed goose. It breeds in Greenland, where it's shot in relatively low numbers. It stages in Iceland, where it's shot in relatively high numbers. And then it comes to the UK for the winter, where it's shot again. So it's been harvested on multiple occasions across that annual cycle. And we do have conventions. We have the Convention on the Conservation of Migratory Species. But individual countries will enforce derogations to those laws because these animals are pests. Protection is poor or non-existent in other countries. And so we have this system where we have animals visiting lots of places, lots of different designations, lots of different protection or exploitation. And so really to try and get a picture of this, we need to understand who goes where and when they are there and what time of year they're there. And this is why individual level data are really important. So individual level data are obviously fine-scale data compared to counts of animals, which are a typical way of sensing populations. And I'm not suggesting population censuses aren't good. They are very useful for a number of things. But if we have fine-scale data, individual level data, we can start to pinpoint carrier effects because we can look at the conditions an individual has experienced at one point in the annual cycle and then look at the vital rates in another. We can explore the consequences of different strategies individuals are taking. We can look at how habitat use influences fitness. We can look at routes. We can look at annual variation. And of course, all of those allow us to then start pinpointing mechanisms of change and mechanisms of decline. And of course, that will allow us to identify where population regulation occurs, and that then allows us to enforce targeted conservation efforts. So the problem's solved. We just need individual data. But of course, these animals are traveling huge distances, very difficult to track. One of the main ways we've really revealed the richness of migration, certainly of birds from the northern hemisphere wintering in the southern hemisphere, is via ring recoveries. But ring recoveries are very difficult. It's very difficult to set up individual long-term data sets with ring recoveries. These are the metal bands we put on rings. The recoveries of these animals tend to be serendipitous. They're often dead, which means it's very hard to know what to make of, and they're often very rare. And I've just got a wee quiz for you. This is a pied flycatcher. 650,000 pied flycatchers ringed in the UK since about 1900. Anyone want to guess at how many sub-Saharan African recoveries there are? What was it? What did you say? You're right, it's 5. 5 sub-Saharan African. So if you think about it, there's nothing you can make of that. 650,000 and 5 recoveries. So ring data do not, or this kind of conventional ring data is not the best approach to generate these individual studies. Of course, we've had this technological revolution, and we've seen plenty of examples. We just saw an example of further technological revolution. And it's a huge impact on our understanding of the migrations that animals undertake. But the size of the tags are really too big for a lot of the animals we might be interested in. This is a study we did, a meta-analysis we did a few years back, showing that really no matter what size of tag you're putting on a bird, it does have detectable effects. And typically the sample sizes are small, because if we're tagging 20 individuals of a population of 10, 15,000, it's very hard to know what to make of the responses we observe. So there's still huge knowledge gaps here. And I'm going to persuade you, I'm going to try and persuade you, that migratory wildfowl overcome a lot of these things, and as such can provide really good insights into the processes that are regulating migratory species and how we might tackle some of the problems that they face. So I'm going to talk most about geese and swans. This is a light-bellied Brent goose. We can catch them relatively easy. This is a cannon net we shot over birds. We catch them in the nets. We fit highly visible colour rings to them, and then we can recite them at later dates, so we don't have to recapture them. So this is AKON with its partner NVON. We know these two individuals very well. We ring these birds in Dublin. We saw them again in Iceland. So they're easy to recite, partly because they tend to be very faithful to sites, so we can go back to the same sites year in, year out. And because they live together, we can assign long-term pair bonds, so we know who's paired with who. So we can start to build lifetime histories of individuals. Another really neat feature is they have extended family parental care. So getting these things breed really far north, it's very hard to get to their breeding grounds, but they come back with their offspring. And if you look carefully, you'll see some of these birds have little white bands on their greater covers at the end of their wings. Those are the juveniles. The ones without the white bands are the adults. And we know the juveniles hang around with the adults for about 11 months. So as long as we see the adults, we can know whether those individuals had a successful breeding season or not, and obviously how many offspring they produced. And another neat feature of them is we can measure their instantaneous condition remotely. We don't have to capture them. Because these birds, all of these birds, store fat between their legs and their tail. And this we call the Abdominal Profile Index, or API. And these measures are highly repeatable among individuals. So I am talking about individuals measuring them. So we calibrate off one another. And of course, we've then taken these measures and they correlate with body mass, they correlate with the diet they're having. So we know they're measuring something about the condition of the animals. So, well, Phil, to the rescue for migratory birds. These features allow us to link up the annual cycle. They allow us to build accurate demographic models. We can then relate changes in vital rates to events and decisions in these animals' lives. And of course, that allows us to identify where regulations are occurring. So I'm going to give you 3 case studies, 3 beautiful birds. The light-bellied Brent goose that I've been working on for about 25 years. Greenland barnacle goose, another long-term data set, only been working on that about 10 or 15, and whooper swans. So light-bellied Brent geese undertake this migration. They are wintering around the coast of Ireland. And about late April, the birds leave Ireland and migrate up into Iceland, where they will spend about a month gathering all of the resources they need for reproduction. So this one you'll see start foraging. They're foraging mostly on the marine angiosperm zostra eelgrass. And they cross the Greenland ice cap into the high Arctic. 470N breeds successfully. You'll see from the track it just stops. That's it nesting. And we know 470N bred successfully because we saw it with its offspring. And then they come back in the autumn. So for these birds, fat stores is the key driver of their annual cycle. They're social foragers, so they're foraging in very large groups, fighting with one another, and there's very predictable dominance hierarchies. So family adults are dominant over pairs, and they're in turn dominant over singletons. They also prefer, as I alluded to, these marine plant resources. So this panel in the bottom is work that Rich Inger did back in his PhD. We've done this dozens and dozens of times. No matter what measure of body condition you choose, it correlates with the amount of marine protein in the diet positively. So this marine protein is estimated using the stable isotope analysis of blood. And this is just body mass in this instance. But as these resources get exhausted during the winter months, they do switch to terrestrial foraging, which is not as profitable. They're time limited. We found birds in nests 500 miles from the North Pole. They are really getting up about as far as it's possible to breed for a vertebrate, and they've got virtually no time to lay a clutch and get offspring to independence before the snows of winter come. So they're time limited, which means they can't buffer the effects of a bad decision at one point in the annual cycle very well. And of course, they're capital breeders, as I alluded to. They're carrying everything into the Arctic with them, because when they get to the Arctic, there is nothing. I assure you, you've been up there and you kind of look around, you're thinking, I don't know how these things are surviving up here. So this plot here, when it first appeared during Rich Inger's PhD some time ago, was a bit of a surprise to us. This is the amount of marine protein in the diet of adults who are families versus pairs of birds. And surprisingly, the family adults have less marine protein in their diet late winter than the pairs. And what this means is those family adults are in much poorer body condition than pairs, despite the fact that the family adults should be able to monopolize the resources. They're dominant over pairs. And what is happening here is a multi-seasonal carryover effect, starting with successful breeding. The bottom panel on the left here is Zostra at low density. The top panel is Zostra at high density. When the geese return, the zostera at high density, they graze it down. It turns out the juveniles just cannot forage on zostera at this low density. And what they do is they drag the adults onto terrestrial habitats because the juveniles can maintain body mass on those habitats because then there's not much, it's not very hard to forage on swaths of grass. This depletes the adult body condition, delays their migration, and as a consequence, they end up late on the staging grounds, late on the breeding grounds, and that results in very few of the adults in our population being able to breed in consecutive years. But reproduction is highly variable across years. So the top panel is the percentage juveniles in the flocks. And you can see there's total crashes in some years. And this is quite a typical pattern for Arctic breeder. And of course, the smart ones of you would think, well, it's clearly lemming cycles that's driving this. There are no lemmings where these birds breed. So we suspected that these mass breeding failures were associated with weather. And one of the smoking guns is the North Atlantic Oscillation, which is I think it's about 10, 11-year cycle, very similar to El Nino or the Ensign Oscillation. And we can see it has peaks and troughs. And so NEO in late June really reflects that window when the birds are coming into the Arctic and starting to breed. So we suspected that would be the best place to look. And this is what we found. So this is what Zav Harrison did during his PhD, where our prediction really here was that the weather's probably delaying or preventing breeding. These positive NEOs mean adverse winds and snow. And if there's snow on the ground, the birds can't lay eggs. Negative NEOs are good. So this is the model that Zav built. The x-axis is a measure of body condition. The y-axis is number of offspring. And the model actually predicts the number of offspring quite well. And you can see the red line is those bad years. And birds are not managing to produce very many offspring in those bad years. In contrast, the blue line is the good years. And so what we see is the variation fitness within years is being explained by this density-dependent carryover effect, whereas the variation in fitness among years is a density-independent abiotic effect. So what does this mean for the population and where regulation is occurring? So we've got a huge database of those birds, about 300,000 resightings of these individuals over a long time period. So Ian Cleasby, as part of one of his postdocs, built an integrated population model, which essentially includes all of those aspects, include behavior, weather, demography, and the annual counts. The top panel, the red dots are the counts, the black line is the model. You can see the model's fairly predicting our count data, our empirical count data, pretty well. So it turns out, as the bottom panel shows, that the female survival is actually lower in those good breeding years. So this might be some sort of reproductive trade-off. Might be allied to the kind of thing Andrew McKechnie was talking about yesterday. It might be thermoregulation, we're not really sure. So the population is currently regulated by a winter-driven carryover effect, that fat score as birds are leaving. But population change is really most sensitive to adult survival. And I think what we're concerned about here is, as the climate ameliorates, these stormy springs or these clear springs might become more common. And if we get system flips, i.e. we start getting lots and lots of reproductive years, then the system may flip from a winter-regulated system to a breeding season-regulated system. And of course, that's huge implications for how you conserve this population, because at the moment it's pretty easy. If you want to conserve them, we just protect winter habitat. But if it flips to a summer-regulated system, it's actually going to be very difficult to do anything for them. I'm now going to talk a little bit about how local management actions might drive flyaway scale effects. So these are Greenland barnacle geese, a rather similar migration, wintering in Western UK and Ireland, staging in Iceland, and then breeding in East Greenland, sorry. This is work that Amy McIntosh and Luke Osnov-Harris did as part of their PhDs. So barnacle geese are a conservation success story. They basically went from threatened to agricultural pests in about 40 years. And that's because of the change in agricultural practices. In Northern Europe, people effectively are farming for geese. Geese love the way farmers manage the land up there. So intensification has been brilliant. It's been bad for a lot of things, but it's been brilliant for geese. And on the island of Islay in Scotland, the population increased from 2,000 to 50,000 individuals, right? It's just an absolutely dramatic increase. And of course, this has led to conflict with farmers. because these birds are grazing pasture that are either being grown for silage or livestock production, and the geese reduce yields, but they also actually destroy the pasture through trampling, so they're a real problem. This bird is protected under the African Eurasian Migratory Waterbird Agreement, but there's the UK have given a derogation to that to shoot birds that are on these high-value reseeded fields to manage the population. However, the derogation was given on a rather back-of-the-envelope calculation. They just said, well, we think it should be about this, you should. Nobody really actually modelled this. And of course, the birds are actually being shot in other parts of the range because they're a pest in Iceland as well, so they're being shot there. So there's a need for coordination across range states, and there's a need for us to coordinate conservation and management. So we got commissioned by the Scottish Government to build another integrated population model that would incorporate data throughout the whole flyway to allow them to inform their future management of this population. So the model is very similar to the Brent Goose model. It has a breeding census, we have a demographic model that's got the mortality in it, we have productivity estimates, and then the difference here is we've got the harvest because we know the bags that are returned in Iceland and Scotland. And you can see again, in this one, again, the counts are the dots, the lines are the predictions, the model's fitting the data sets very, very well. So the top line is the entire population, which is a 5-year count. The blue line is the Isla population, which is an annual count, and the orange line is all the other sites, which is also a 5-year count. And you can see that 2011 is when the derogation happens, and the population starts to decline as soon as shooting is introduced. And indeed, when we look at the harvest rate of birds, so you can see the Iceland harvest rate is relatively constant, but that Scottish Isla harvest rate suddenly shoots up about 2011. I'm not going to talk about these, but these are the kind of predictive models that the Scottish Government are now using to think about management. We can run different scenarios and look what happens to that population. We can run different management scenarios. So it's informing future management scenarios. The key message here, though, is that changing a vital rate at a single site is driving the population trajectory of this whole flyway. And of course, that has profound implications for conservation efforts. So we need to be sure that site-level management prescriptions are not affecting population-wide conservation goals. And I'm going to finish with arguably the most beautiful of the three, which is the whooper swan, Icelandic whooper swan. This is work led by Andrea Soriano Redondo. So these don't have quite a big migration. They winter off the British Isles, and then they migrate up to Iceland to breed. And the red, this is in collaboration with the Wildfowl and Wetlands Trust in the UK. So the red dots are Wildfowl and Wetlands Trust reserves. So the reserves, again, were sited where the swans were. They just thought, well, there's lots of swans there, build a nice reserve. We've got some coffee rooms, people can come in and watch them. And the assumption there is that the regulation of these populations is happening at the wintering sites, okay? And they've had massive marking and individual ID programs on these swans over about 30 or 40 years, so there's a fantastic data source there. The birds are fed at the site, so we think that's probably a good thing. And there are predator fences at the site, so there's essentially a couple of things that should be good for these animals. But there's lots of evidence that protected areas aren't working the way they think they are. And there's a recent big analysis in Nature where they showed that protected areas have a very mixed impact on waterbird populations. So the goal here is really to try and help the WWT work out whether these protected sites are actually functioning in the way they hope they are. So there has been a population increase. The question they are asking is it increased because of the reserves? So it's increased by about 5,000 over 10 years. We've got this huge reciting database. We've got productivity assigned to those pairs, so we can build a demographic model there. We build a survival model. This is just one of these multi-state survival models. We don't need to go into the detail of it. All you need to know is we model survival inside the reserves and outside the reserves together, and we model the survival of juveniles, immatures, and adults separately, okay? And then we can take this data and build population projection models and forecast what we think the reserves are going to do down the line. So the first result was exactly the result the Wildlife Analytics Trust did not want to see. Turns out that the birds inside reserves have lower productivity, so they're much less likely to come back with offspring than birds outside reserves. And it's not about who uses reserves, because if you look at birds that move into reserves, end up with the same productivity as birds that are staying constantly in reserves. So this suggests it's nothing to do with the individuals that are actually occupying the reserves. But productivity is not everything. Turns out survival is much, much higher inside these reserves. So you can see for all age classes, survival is higher inside reserves compared to outside reserves. And what that means is birds that spend their entire lives inside reserves have much higher lifetime reproductive success. So the reserves are working. The WWT are pleased. And we can take these values and project them into the future. What we find is that the growth rate inside reserves is faster than the growth rate outside reserves. And actually, reserves may contain up to 50% of the population by 2030. So that contrasts with about 5% of the population in 1985. And we think the enhanced survival is likely linked to reduced predation, and actually they tend to have, one of the main ways these swans die is with collision with power lines, and these reserves tend not to have power lines going through them. So you only get this level of detail with these high-resolution, long-term individual studies. And so the conclusions at the top are just the main ones about what I've talked to you about, but I do want to try and persuade you that these principles are not exclusive to ducks and geese, right? Any animals that are engaging in long-distance movements are likely to be affected by the same kinds of processes. So I'm thinking particularly elephants, but vultures, antelopes, fish stocks are the same problem. You know, we're having fish stocks on one side of an ocean basin differently to the other, and it's effectively the same stock. And I think, just in general, if we're managing highly mobile species, it requires these integrated multi-scale approaches, these high-quality data sets, obviously ecological insight, and then some sort of coordinating governance. So I thank you very much for your attention. I obviously said we, but it was actually they. So thank you very much for your attention. I'll happily take any questions at this time. Thank you.
Thank you, Stu. Any questions? Surely. Concerns, complaints, suggestions? Nobody? Oh.
There's one way up the back.
Yeah.
Hi, thank you. This is Sally Archibald from Wits University.
Thank you,
That was
Sally.
really fascinating.
Thank you.
Good to know the reserves are working for the swans. But could you tell me why they're not working for the other birds in the paper that you mentioned?
Well, I think actually part of that, the reason in that analysis is that it's census data. So it's just count data that they're using, and it relax some of the nuance that that these kind of high-resolution data sets can allow us to get to. And I think also a lot of these sites, a lot of these wetland sites are in marginal lands that are next to industrial plants, and they might, if you're, I guess it's the same in this part of the world, a lot of the reserves are in places that people don't want to use, and I think, again, they're probably just not very high quality, a lot of them. That would be my guess, Sally, but I'm not sure.
Great, thank you.
Thank
If
you.
you've got any other questions for Stu, you guys can migrate to the deck. Alternatively, if you're feeling extra goosey, you can spread your wings and flock to the bar later. At the end of the day, what's good for the goose is good for the gander. All right, all right. Okay, enough of this, enough of this. All right, up next we have Tinao Petso, and she's going to be talking about improving AI for wildlife tracking, the value of expert tracker knowledge and training data. I'm done, I promise, I promise.
Good afternoon, everyone. My name is Major Pizzo. I'm a PhD student, and I'm also serving in the military in Botswana. I am supervised by Professor Rodrigo Jamisola and Dr. Namusha Mlaleza from Botswana International University of Science and Technology, and I'm also co-supervised by Dr. Zoe Joel and Dr. Sky Alibahai, and they are the founders of WildTrack. WildTrack's mission is the development of non-invasive wildlife monitoring techniques for conservation. And we also have Captain Waja Mereki from Botswana Defence Force. Our research is titled Improving AI for Wildlife Tracking, the Value of Expert Tracker Knowledge and Training Data. And we are funded by United States Army and Botswana Defence Force. We quickly like to share one of our latest publications titled An Investigation of Lightweight AI Models to Classify African Ungulate Species from Tracks. So one of the main contributions of our research work was the development of introducing the use of bounding box to classify African ungulates in terms of width bounding box to classify the track, and also using landmark points. Additionally, this work, we trained the models in the lab, and then we went back into the field to test how the model performs using a laptop to understand efficiency and its challenges. In our field testing data, we managed to achieve an accuracy of 98% in classifying African ungulate species. And these species that we looked into were black rhino species, blue wildebeest, common eland, giraffe, white rhino, and zebra. Why African ungulates? African ungulates help in maintaining the ecosystem integrity and balance, and they do also help in ecotourism as well as in the cultural value as African people. Artificial intelligence is something that is mostly used nowadays in our everyday activities, and it can assist or aid us in terms of anti-poaching efforts. Like Anne said, I work in Botswana Defence Force, so our main or priority reasons that we contribute to in support of my country is in the anti-poaching aspect. And it additionally can help in issues such as human-wildlife conflict mitigations and also in wildlife monitoring efforts. For this research work, we looked into 3 research areas in Botswana. We considered Khama Rhino Sanctuary, which is situated in the central district of Botswana. And this place has both soft and hard substrate, and it has 4 species. It has several species, but for our analysis, we only looked into 4 species, which is black rhino, blue wildebeest, giraffe, and white rhino species. Additionally, we visited the second place where the substrate is hard, which is Mokoloji Nature Reserve, which is situated in the southeast portion of Botswana, and it had blue wildebeest, giraffe, and white rhino. Lastly, we visited the western part of Botswana in order to see where we are having a soft substrate, but this place, it only had white rhino species. Unfortunately, we cannot disclose the exact location of these species, of this research area. So our data protocol is quite simple. With the assistance and guidance of expert trackers, they help us to find fresh tracks with working characteristics. From there, we then put a square ruler, which is, you can see 2 in the image over there, and then a distance of 1 to 2 centimeters from the track. From there, we put a label slip. In this label slip, what we are having, we are recording the date, we are recording the name of the person collecting the data, the species, and we are recording whether it's a left hind or a right hind, and the location where we are collecting the data. From there, then we take an image, making sure we make inclusion of the ruler and the label slip. We collect as many footprints as possible with the guidance of expert trackers. Additionally, we record the environmental conditions where we collected that data, and aspects such as lighting effects, the type of substrate, and the specific location of the trail where we collected the data. These are just a quick visualization sample to show the effects of different weather seasons in terms of dry season and wet season. So in wet season in my country, you are looking at a time where we are getting rains, which is around December. So the rain does have different effect to the footprint. And then we look into the dry season, which is like you are having it in winter, which is something like June. So the quality of the footprints do change a bit. What we did, we considered to see what is the impact, because with artificial intelligence, it's garbage in and garbage out. In terms of that, I mean the data that you train your model with impacts the outputs. So the model can underperform because you didn't train it with different or diverse data sets. So in this case, we wanted to see the effect where you are having two expect trackers and non-expect tracker in this case, which was me. So we went through 3,039 images individually and independently. So the first thing that we measured the track quality. We looked into the aspect, as you can look into that image, where you have region 2 and 3, which is the outer toe and the middle toe of the white rhino species. The soil is collapsing. Hence, as it's collapsing, that means certain features are not visible. So in this case, the soil collapse, we are ranking the effect of soil collapse into the track quality image. Additionally, we looked to the impact, the clarity of the outline of the footprint. So in this case, we looked into 4 regions to quantify the quality of it. Are the outlines clear? Are the outlines perfect across the 3 assessors? And we also looked into indentation depth effect of each track. Additionally, we looked into the presence of vegetation that can be, an animal will just go in any region. Sometimes it will go in a region where there is a presence of vegetation, and hence that presence of vegetation affects the quality of the track. And lastly, we looked, naturally there will also be external disturbances. In terms of external disturbances, it's regions where another animal will step on top of the footprint, or another animal walk into that footprint, because there are several animals in the area. So in this case, the image on the right is me and the other 2 trackers evaluating the images. And then this is just a quick example to show of one track that is a high quality images where the disturbances are less in terms of soil collapse, and you have clear outline and clear indentation, and there is no presence of vegetation and external disturbances. This is one image where you are having totally, this will be a low quality ranked images. There is high presence of vegetation. So one might ask, what are exactly these algorithms? So what we do to evaluate the models to see how the model perform is we looked into an image. With these algorithms, you put an image. When you put an image to the system, it will detect or localize the presence of the footprint, and it will make a bounding box. So what we are evaluating is the true ground truth of the track, which is in red box, and then we are having the model making a prediction. In this case, when it's making a prediction, it's making the blue box. So if it's an easy detection, it's something you are having with an intersection of union at 50, that means you are not having a perfect fit towards the actual track in respect to the footprint. So if you want to be tight on the exact location of the footprint, we are evaluating the mean average precision where it's between 50 to 95, which is shown on the image on the bottom right. This is just some of the quick results. We looked into certain or different hyperparameter settings to understand the effect of our results. So the results in here, we are analyzing where you are having mean average precision, which is a kind of a loose detection, not a tight towards the footprint. So in this case, we looked, the blue parts are the results or analysis based on the images that were analyzed by me or assessed by me, which I'm a non-tracker. And then we increased the images gradually. So we had 100 images for the left hind, 100 images for the right hind. And in that case, you are having 200. And since we are having 4 species, that makes a total of 800 images. We further increased the images to 150 images per class, which makes a total of 1,200. And then further increase with 50 images to see the impact into the model. In this case, we are having a total of 1,600. So the green and the red results are for the tracker's results. So here quickly what you can see or analyze, you can see that the results are based on the trackers on the red and the green. Has a higher performance compared to the results of a non-tracker. For me as a non-tracker, I would have to train the model with higher number of training images. We further looked to see if this impact still relates where you are making sure that the track is properly on the footprints. And similarly, we got the same idea that we got the same results that the non-tracker, you will need more images, whereas for the expert trackers, you will need lesser images in order to achieve high model accuracy in species classification. These are just quick images under different environmental settings that we tested with the highest or the best performing model from the analysis. We have the middle images after rain condition. Out of this, what we can realize is expert trackers, which is traditional ecological knowledge, is quite vital in data collection in our study. So they are quite valuable to have. And for the data pre-processing, additionally, it does highlight that with spectral trackers' help, fewer images are needed to achieve high accuracy. And for a non-tracker analysis, you will need a higher number of accuracies in AI model development. Tracking is something that is quite important, and it should be utilized in research and incorporated. As I'm from the military, we use tracking skills for our anti-poaching operations, and it's a useful skill to keep improving. We would like to thank some of the trackers that contributed in our research work, and mostly of these trackers, 90% of them are serving in the military, and 10% are working in national reserves as trackers. Thank you.
Thank you, Tanao. Any questions?
Thank you very much for that presentation. So I'm just curious to know which specific AI tools are you using for your work? Are there any specific? Because you just said improving on AI in the prediction. Are there any specific? For example, the convolution network, are you using such kind of tools that, or models?
I'm not sure if I understood your question. Tools, you mean the devices that you are collecting the data with? Or you mean the computer?
The algorithms. I mean the algorithms, for example, when you talk about AI, it's a bit general.
Yeah.
So are there any specific AI tools that you're able to tell us that you're using in your work? Is it neural networks, tools related to neural networks, for example?
Oh, we are using deep learning. Thank you.
Thank you very much. Two short questions. The first one is, how does time of day affect the model's confidence in determining what the track is? And the second one is, does the model get any false positives? Thanks.
Okay, thank you. I think you can repeat this. I'll answer the second one and then you repeat the first one. Okay. We do get false positives, and that happens a lot between black and white rhino species. To account for that, when we did our first study in the publication that we had, we ended up going to use strategic landmarks. And when we use strategic landmarks, that's when we improved the model performance. So we use strategic landmarks because it's something that WildTrack have developed over years, but using statistical morphometrics. So we enhance that in terms of putting it in AI to see the effect. Hence, when we put the strategic landmarks, the results improved. The first one, I didn't guess what.
The first question was, how does time of day, in other words, the amount of shadow on your track, affect the model?
Okay, thank you for that question. We collect our data during early morning and early afternoons, but we did make an observation that when there is lighting and shadow in the same image, there seems to be a challenge. Sometimes you get lower model performance. So it's something that we are still working on. But we do acknowledge that environmental factors in terms of the lighting and shadow effects, especially where there's light and shadow, do impact the model performance.
Thank you very much for your very interesting presentation, and it's really exciting to see people from the military doing this kind of research. I wanted to find out what risk management and mitigation measures are you thinking about in terms of the potential of these same tools and approaches also being employed by the enemy that you're trying to also fight, like the same technology, especially if it's open source, being used by the poachers so that they are also more efficient on their poaching? Thank you.
Thank you for the question. It's quite a good one. Actually, I am a junior officer. In between junior and senior officer, I'm a major. So there were certain precautions that were taken. There was a meeting between Botswana Defence Force, which is my employee, and Ministry of Environment and Tourism. They had to confer that I hold the data, and everything that we do before we can share it further or do anything further with it, a decision has to be made. So at the moment, we are trying to protect the data being held by the people who work with the data in terms of that. But in terms of when we visit these areas, we also have to write in advance requesting so they know who are the exact people collecting data in that area at the time it's registered. So they're keeping records of us who are collecting data. Additionally, in order to develop this model, you would need a lot of raw data in terms of that. So the poachers can develop the model in terms of making it open access, but you need a lot of data under different areas of analysis. But for this case, the decision lies between Ministry of Environment and Tourism and the Botswana Defence Force.
Okay, thank you, Tanao. We're not going to take any further questions. If you do have further questions, you can track her down later. Okay, up next we've got Thando Twala talking about ecophysiological responses and projected climate suitability of the podocarps.
Okay. Afternoon, everyone. Sanbonani. As already mentioned by Wendy, today I'll be talking to you about podocarps and their response to climate change. But I just wanted to highlight first that this is my PhD work, and I spent most of my academic life as a savanna ecologist, so all of my training is there. And I eventually got very tired of exploring that side of the world, so I decided to challenge myself by going to a different ecosystem. So yeah, I'm learning. I came out with a lot of questions. I'm sure many people who've done research start off with a question and come out of that with more questions. So this is some of my work. It actually came from or was inspired by a paper by William Bond, where he spoke about this ecological competition, right, that happens in forests where you have your tortoise in the form of angiosperms, in the form of gymnosperms, and the hare in the form of the angiosperms, where the hare is fast-growing, competitively dominant in these high-nutrient ecosystems, and because of these traits, they tend to outcompete gymnosperms in these systems, where our gymnosperms are the tortoises that are slow-growing, shade-tolerant, and very persistent, and they thrive in these suboptimal conditions. So essentially, these characteristics and how they respond to light and nutrient stress is what shapes our South African forests. So South Africa's native tortoises, as I've mentioned, are the gymnosperms, where in South Africa, the most prominent family are the Podocarpaceae, or the podocarps, which are the yellowwoods, and they are a national tree. So they are very central to Afro-temperate forests and sort of influence and shape the structure and the function of our forests. These forest systems tend to occur in very fragmented relic spaces, and they stretch from the eastern escarpment going all the way down to the southern Cape, with this distribution being shaped by millennia of fires, topography, as well as climate. However, as many of the talks that we've seen between yesterday and today have spoken about, the imminent challenge of climate change, because now it's happening more rapidly than before, with heat and drought stress being the biggest drivers or biggest factors. And it's very nice because Prof. Andrew actually spoke about hotbirds, and he highlighted that this is also an issue in forests as well. So now the race is not solely based on competition for light and nutrients, but now the next thing that we need to also look at is how can these species in these forest systems cope with drought and heat stress. So persistence of these species depends on their ability to physiologically respond or through physiological thresholds, as well as their reproductive timing and demographic resilience. And this brings me to my question, which was if or can these species that actually persist through a strategy of to persevere at slow and steady, using a slow and steady strategy, will they be able to cope under the stresses when the competition rules are rewritten by unprecedented climate change? So how I did that was that I firstly tried to predict, or I tried to map or predict the potential distribution of podocarps in South Africa, or habitat suitability, under current and future climate scenarios, as well as exposing seedlings to climate change-related stresses, because William Bond has stated that this competition is very prominent at the seedling stage. So together, all of this gave us a more mechanistic way of looking at the system. I hope you guys will be patient with me, because I'm also still trying to figure out the threads of putting all of this together. But we can journey together and try and figure it out. So starting out, what I did was I selected 2 of the 4 South African podocarp species, the first being Podocarpus henkeli, which, if you can see there, we have the GBIF data that I downloaded, and Podocarpus henkeli is represented by the orange dots, and then Afrocarpus falcatus, which is represented by the blue dots. After that, now that we had our occurrence data sets, I downloaded climatic variables from CHALSA, and I ran a correlation to be able to remove variables that were correlated with each other. Upon completing the correlation, we were left with 7 climatic variables, which were maximum temperature of the warmest month, temperature annual range, mean temperature of the wettest and coldest quarter, which made up our temperature variables. Then we also had precipitation of the wettest, driest, and warmest quarters, making up our precipitation or rainfall variables. Now that we have our occurrence data sets and our environmental data sets, we fed this into an R package, which is Biomod2. I chose to use an ensemble model instead of using one algorithm, because ensemble models were considered, or are still considered, in fact, to be more robust than using a single model. So these models that you'll see here were actually informed by 10 algorithms. From there, the output was to look at the current distribution or habitat suitability for both species in South Africa and identify environmental variables that drive this distribution. Secondly was to map or predict the potential future habitat suitability of these species for 2070, so I didn't want to push it too far to 2100. And what I did was I checked, I looked at change in climate change at 2 climate change scenarios, which were RCP 4.5, sort of like average climate change, or moderate climate change, sorry. And then lastly, RCP 8.5, which is sort of like worst case scenario. So just to take you through the results for the current predicted habitat suitability for Afrocarpus falcatus on your right, you'll see that habitat suitability spans from the northern parts of the country going all the way down. If you know forests, and as I've already mentioned in my introduction, is that this is tending to overestimate. But it makes sense because this is a correlative model and not a mechanistic model. So we're just looking at habitats based on climate, showing habitat suitability. Moving on to Podocarpus henkelii, we can see that the distribution is in a very summer rainfall area, sort of isolated in the eastern parts of the country. So the distribution of Afrocarpus falcatus was influenced or driven by precipitation of the driest month. And when looking at this, just to try to link these variables with its ecology, I assume that this variable is important because it ensures, during this period, it ensures that the seedlings are able to survive during the dry periods, and secondly, that there's successful cone development as well as pollination during this time period. For Podocarpus henkelii, with precipitation of the warmest quarter being important, it might be due to increasing successful seed formation because podocarps actually produce seeds that are underdeveloped, and to help with seed maturation. And these results actually correlate with a lot of studies that have been done by other scientists, such as Tim Broadrip, who's looked at podocarps in Australia. And most of these results or most of the patterns that we saw was that it was due to sort of the plants having small single-veined leaves, as well as due to their hydraulic structures, because unlike angiosperms, they don't have separate structures for water transport and for support, as well as due to their seed biology, because podocarps tend to produce recalcitrant seeds, which are seeds that lose viability when they dry down. So I took the future predicted distribution of these species and I overlaid that with the current distribution to sort of look at the change or potential change in habitat suitability with climate change. So you'll see that for Afrocarpus falcatus, that the distribution remains relatively stable. But what's interesting is that you can see that we're gaining suitable habitat at high elevation. And this is driven by temperature annual range. Moving on to Podocarpus henkelii, you see quite a different distribution, where unexpectedly so, in moderate climate change, you can see that with the predicted habitat suitability is expected to be lost at higher elevations, and this is driven by mean temperature of the warmest month. So indicating that those higher or upland areas are predicted to become hotter. However, in RCP 8.5, you can see that the areas that were initially predicted to be lost or contracting are actually stable habitats. And you're actually seeing that there is potential shift upslope and shift downslope. And this pattern or this distribution is driven by precipitation of the warmest quarter. So this precipitation in this case is clearly offsetting the higher temperatures that you're seeing up in the RCP 4.5. So to switch gears now, moving from predicting habitat suitability or distribution, what I wanted to do was to sort of push them to the limits to understand their physiology. Is the physiology driving their distribution or also restricting their ability to compete potentially under climate stress? And what I did was, with the same species, I purchased seedlings that are from the same seedling batch of the same size, and then I brought them into the greenhouse at Wits University, allowed them to acclimate, and then I tested their limits. So what I did was, I looked at temperature or ambient temperature in the distribution of Podocarpus henkelii, which, as you've already seen, tends to overlap with the distribution of Afrocarpus falcatus. So I chose 3 temperature treatments to test its response or their responses to temperature, and the first being ambient temperature, the second being 2 weeks of ambient temperature, 1 week of high temperatures, and 1 week to recover or at ambient temperature, and then lastly, pushing them at high temperatures. And of course, you cannot have a climate change experiment without introducing a bit of drought. So I further in the individual temperature treatments, I subdivided the seedling batches into 5 seedlings that will be well watered for each species and 5 seedlings under progressive drought. So I'm just presenting just a subset of some of the variables that I actually measured. Firstly, we looked at photosynthetic traits. So we looked at chlorophyll content using a SPAD meter, just to use a non-invasive methodology to measure chlorophyll content, maximum quantum efficiency of photosystem 2, which is sort of a gauge of plant health. And then I measured whole plant transpiration by using gravimetric method of measuring water use efficiency. And then lastly, I used a visual way of looking at leaf production as well as leaf aging throughout the experiment. I just wanted to highlight that this was sort of a snapshot. It's not a long-term study. It was a short-term study over 4 weeks. So looking at some of the results, you'll see that, interestingly, Afrocarpus falcatus increased its water use efficiency under drought stress, and this shows that the species is plastic, but it's also very sensitive to drought, especially at high temperatures. But what's interesting is that this plasticity actually coincides with its distribution. As you've seen, it occurs in both high rainfall areas as well as in dry coastal areas. So that's an adaptation to episodic drought. However, looking at our restricted species, Podocarpus henkeli, you'll see that the well-watered, the water-stressed seedlings actually increase water use efficiency under drought stress across all the temperature treatments. And this could possibly be due to stomata regulation as well as photoprotective mechanisms in order to protect the functioning of photosystem 2. So I actually have students that are measuring other traits in relation for us to be able to understand whether this is actually the case in terms of stomata regulation. So then looking at chlorophyll content, I know these graphs make a lot of sense. So we can see that chlorophyll content under drought stress actually decreased across all the treatments for both the species, which then is a proxy to indicate that there is a reduction in photosynthetic capacity for both species. Moving on to maximum quantum efficiency of photosystem 2, we can see that for both Podocarpus henkeli and Afrocarpus falcatus, there was a decrease in the efficiency or in the function of quantum efficiency of photosystem 2 under drought and heat stress. However, what's interesting is that for Podocarpus henkeli, under combined stress, you can see that there is tolerance to photo inhibition. So it is offsetting under combined stress. And then just to put it together with physiology, the physiology with the phenology, as I've already stated, chlorophyll content decreases under these environmental stresses, resulting in a decrease in photosynthetic capacity, therefore reducing the efficiency of photosystem 2, resulting in leaf senescence or leaf aging, and then at the end of that cycle, you get leaf death. So this is an avoidance strategy in order to conserve resources and to reduce the effects of the stresses. So, as I said, you guys are going to be on the same boat as me. So firstly, what you'll see is that Podocarpus henkeli, despite its restricted distribution, shows robust photosynthetic responses, and it suggests that it could also tolerate moderate climate shifts regardless of its restricted distribution. However, some of the questions I left with was, is their reproductive strategy, dispersal, and competition in these systems the true limitation to podocarp distributions? And we shouldn't be that worried about climate stress, and that while the hair actually dominates in the early successional stages through rapid growth and resource capture, do the tortoises or our podocarps persist through stress and tolerance, stress tolerance and longevity? And at what age does this happen for the seedling? So what is the bottleneck at this stage? So we're seeing that there is a shift from resource acquisition in the form of light and nutrient capture to a more stress endurance reframing, to a more stress and endurance strategy, sort of reframing the race from light and nutrient acquisition to heat and drought stress tolerance. So the question here that I would pose to you is, if people have researched, but maybe they could also help me think about it, is what are the angiosperms doing in these systems as well? Okay, so I'd like to acknowledge my supervisors, Dr. Kelsey, Dr. Jolene Fisher, and Prof. Kelsey, as well as Prof. Ed, and my funders.
Thank you, Tando. Unfortunately, we don't have time for questions. And I know what you guys are waiting for. I'm turning over a new leaf. Okay, just a quick announcement before tea, please. Yesterday, somebody in the third row from the back accidentally took the wrong conference bag, which means they left their bag behind and somebody probably took it. It had an Apple Mac charger in it, so if you got home and you found a new Apple Mac charger in your bag, it's not yours. It wasn't part of the gift. Please take it back to Ricky. It's not a name and shame, don't worry. Accidents happen. But yeah, please, if you did find something in your bag that doesn't belong there, please take it to Ricky. All right, let's go and have tea, and please be back by 4 o'clock sharp.
And to kick us off, I'm going to pass over, or my name is Laura Pereira, sorry, and I'm going to be facilitating the discussion. So we have sort of 3 sections, variety of sort of really quick interventions, and then we're going to pass over for a more open discussion and hopeful engagement with the audience. So to kick us off, I'm going to hand over to my co-PI, Sally Archibald.
Thank you so much, Laura. And thank you for the opportunity to spend a whole hour here today telling you about our Future Ecosystems for Africa program. I think it's good to talk a little bit about where this started. So about 4 years ago, Oppenheimer Generations Research and Conservation, and led by Jonathan and Carrie, kind of approached us with the idea that we really need to drive some larger integrated research programs. And the one key point that we all agreed on was that there's something not in balance right now in terms of the actions that we're doing to try to create sustainable development in Africa. If we just carry on what we're doing, if you carry on what you're doing, we're going to end up in a future that we don't want. And this was highlighted to us by Jonathan. So the idea is we really need to shift the curve, shift the dial, change our actions in order to produce a future that we all desire. We want to go from the projected future, which, as the talks have told us today, some of it looks pretty dire, into a more preferable future where we as human beings living with nature, it's actually it's a future that we all would like to aspire to. But the challenge is that, like, we could imagine any preferable futures. We also need to think what could be possible. How could we achieve that future? So this beautiful cone that Laura introduced me to at some point in our collaboration together epitomizes what the whole brief that we were given by OGRC, which is to shift the dial, to move Africa into a more preferable path that we all would desire. So that was the Future Ecosystems for Africa program. We are a global collaboration for local action. And we really want to develop strong African voices, informing just and sustainable pathways for Africa and for the world. We want to be an inspiration for the world in how we do things. So there's a lot of amazing work going on in Africa right now, trying to achieve the same thing we're trying to achieve. So we want to work with those efforts to improve biodiversity conservation and social well-being, but we want to make sure that they're informed by the best possible data and in a way that really does capture the priorities and values of African people. But we also, and this is kind of key, and I think everyone involved in this project recognizes that that's not enough. We really want to be driving transformative change across a range of spheres, because otherwise we're not going to shift the dial, we're not going to move towards a more preferable future. And then we definitely want to provide tools for decision-making and for action. How do we do this? This is a beautiful figure that sort of summarizes some of the ways that we work together on the continent. We build actionable capacity through futures thinking. We forge a lot of partnerships where we provide a detailed evidence base using all of our networks across the continent. And we support cutting-edge multidisciplinary science. And then that goes in 2 different directions. It goes on the ground towards implementation projects, working with people on the ground, and it goes up into the policy and funding sphere to try drive and change the way these policies work in Africa. And ultimately, we're aiming to empower African citizens. We've forged a lot of partnerships in the last 4 years. As you can see, we don't totally have active people on the ground in every single country on the continent yet, but it's growing. And we do have some Africa-wide projects. So we really do represent a network of people. And it's just sad that there can only be this many on the stage with us today. There are many more here with us at the conference, and please make sure to reach out to them. I mentioned the implementation projects. We have a couple of really exciting activities on the ground, cutting across more futures thinking, community engagement, to the land management side of things. The most important stuff about this is that there's interaction between the projects. So we have colleagues in Angola looking at how fire in peatlands with agriculture, whether it can be sustainable and help feed people. We've got people in Zambia looking at fire regimes and biodiversity. We have people in Mozambique looking at how fire is used to get honey production. And these people talk to each other and share knowledge and share insights. But that's not really enough, as I mentioned. There's hundreds and millions of implementation projects on the ground in Africa. And talking to my past students yesterday, who many of them work for NGOs, many of them work for consulting companies, they were saying, we know what we need to do. We know what needs to be done on the ground. But what constrains us is that the funding coming in from outside is telling us to do something different. So we're really constrained. We know what needs to be done, and the funding and the policies are pushing us in a direction that we don't think is preferable. So as well as the implementation projects, we're also really working to change that policy and funding landscape. And this is just an example of one of the outputs involved in that. It's a paper we recently published, which has been really useful for engaging with some of our policy and government actors, just providing some principles about if you do want to fund something good on the ground in Africa, these are the 6 principles that you should think about if you want this project to achieve your goals, be aligned with the needs of people and nature, and to actually have long-term benefit. And we will hear some more about these actions in the next few minutes. Now, at this point, it's going to be hard in an hour to summarize this massive project. But fortunately, our wonderful colleague, Carlos Amato, who's doing some graphic harvesting in the corner there, helped us to produce this graphic. And the point of this graphic is to show that we're a group of people with very different skills, very different priorities, coming from very different disciplines. We have a bunch of people who are real hardcore scientists doing ecosystem functioning and biodiversity work on the ground, getting kind of on their hands and knees, getting pricked by things in the bushes. We have people who can think about economy and think about nature financing and link those ideas about people for nature and nature for people. And then we have people who are really good at working with communities, helping them to imagine the preferable futures that they want and helping to make sure their voices are brought into these stages. And all of these people and all of these disciplines come together in a couple of activities, of which there are many people, and we're hoping that if you can zoom in and see the many people that are involved in this project. But what is really important is that the outputs, the thing we've managed to produce in the last 4 years, are informed by many different spheres. So the different activities come together to achieve something greater than the sum of its parts, and that's what this image is supposed to show. But at this point, I think Laura's going to help lead us through some of the stories of the things we've achieved in the last little while.
And so this comes to the interactive part of the panel. If you can see here, there's a QR code that you can scan, and we have a set of questions for you. Based on the discussions, what do you think we should stop doing? What do you think we should do more of? And what do you think we should just continue doing? As well as general questions. And we'll come back to that at the end of the panel in a more open, what we're going to call the interrogation session towards the end, which should really fire us up before moving on into the evening's activities. So this will come up periodically. I know if you're like me, you never actually land up getting the QR code the first time round. So don't worry, it will come up again. So this is just to introduce us. We didn't do it at the beginning. Sally is the co-PI on the project, on the program, together with myself, Laura Pereira, and our other colleague, Odi, who's on this side, sitting next to me, Odiriwe Selemane. And we'll sort of be coming up sporadically to sort of weave the story of this journey that you saw so beautifully captured by Carlos, and we'll come back to that at the end. And hopefully we've been able to tell the story. But for now, we wanted to sort of give a real impression of what we've actually been doing. What are the stories of on-the-ground data collection that the different collaborators that we've had on the project have been doing? So we've got 3 collaborators, Batlalifi Tatenda and Mohammed Amani, who are going to be coming up to just give a really brief insight into some of the work that they've been doing. And so it's my pleasure as our first speaker to introduce Batlalifi Khotwe, who is going to talk about futures thinking. Thanks, Batlalifi.
My name is Batlalifi Khotwe, and I'm a PhD candidate at Global Change Institute through the Future Ecosystems for Africa program. And I'm just going to share some snippets of my work that I've been doing in southern Kenya. So I want you to first think about what life would be like, what the reality would be like in this room if we were to have a Maasai pastoralist to come and give us advice or insights on how to coexist with wildlife and livestock systems within the various landscapes that they reside in. So for my project, I'm collaborating with the South Rift Organization of Landowners, which is a conglomeration of Maasai pastoralists who are based in southern Kenya, and they operate within numerous conservancies. But for the purposes of my study, I focused on two landscapes, the conservancies of Olkir Matian and Shompole. So smacked right bang there, excuse the resolution, between Amboseli and the Masai Mara in southern Kenya, just north of Lake Natron on the Tanzanian border, is where my work is based. So with the organization in the landscape, we're working in to say, what are these pastoral visions of future aspirations that live within the landscape? And how can we ethically, keyword, ethically, leverage some of these value matrix that exist within the landscape and into the broader livestock systems, more broadly for food systems transformations. So in 2022, IPBES released the values assessment, and with the values assessment being sourced by 13,000 sources and with member states of around 139 countries, all agreed that there needs to be some very important shifts that take place, part of which, within my 4 minutes, includes transitions or changes within the food system. So in order for us to achieve one of 4 pathways for for transformations, to build more sustainable and socio-ecological conservation spaces, we need to focus on 4 key areas. And because of time, I'm only going to focus on the part that's most relevant for my project, which is number 4, for earth stewardship and bicultural conservation. You cannot speak about Africa, as Prof. Belinda Reyes stated yesterday, and a colleague of ours, Anthony, stated that you cannot build Africa's futures without its people and landscapes involved. So then with onset of my project, I asked, what are some of these values or these cosmologies or knowledge systems that exist within the 2 landscapes, and how can we, in collaboration with the communities in the landscape, leverage them, as I've already said, ethically for broader food systems transformation? So what you're looking at is a camera trap that captured a lion a day before, and around 24 hours later captured livestock. It's these very important, interesting systems of coexistence that brought my work to the landscape. With that, I thank you.
Thank you so much, Batilifi. It's now my pleasure to call up Tatenda Gatore, who's going to talk us through his project.
Thank you. As introduced, my name is Tatenda. Before joining the FIFA, I was working for the Zimbabwe Forestry Commission as a researcher in forest and woodland management. And among all the duties that I did, some of the things that I did was to set up long-term forest inventory plots where we would measure tree growth, where we would assess tree growth with a special focus and interest on timber harvesting. And this made it possible for me to join FIFA from that perspective, where my role basically is to look at tree growth rates across Southern Africa from our woodlands and savannas. I make use of long-term tree data that have been collected by different researchers across Southern Africa under the CISO partnership and some bit of complicated models to be able to understand the tree growth rates across the region. My role basically is about bridging scales, where we need to try and move from individual localized case studies and try and come up regional insights that can be able to inform tree growth across the region. This kind of data that we have been generating under FIFA is very important in enabling us to have a balanced discussion within FIFA, considering the woodlands, how they are growing vis-a-vis other systems that are surrounding us. We understand that Africa is a very big landscape, and there are many systems with different people, with different interests for different people, and we need to integrate both. So I find so much value working in FIFA, where we are a multidisciplinary setup, where I have gained from combined ideas that help us to think appropriately about how we value our forests, but also valuing other systems like grasslands, and also incorporating expertise from different individuals. I have also benefited from this because it have enabled me to think appropriately about my assumptions when I'm looking at tree growth rates, when I'm looking at the different interests, when I'm looking at people, people who think in different ways, like futures for the people, people who look at socio-ecological systems or other interests from other different disciplines, which is very important for us to consider different views and multiple interests when we are looking at these systems. So this have helped me so much, and you've given me a platform even to share my products, to share my ideas. Through FIFA, I was able to come to the ORC for this year. Through FIFA, has given me platforms even to share my ideas through impact pathways that are coming through more collaboration with the different people. Also, the data that we are building is also enabled from the FIFA products that are coming up and others that have already come up to be able to make context-specific solutions and be able to profile ideas that enable various people and various interests to be met. Whilst I look at my role within this system or within this project as a role that have enabled me to be able to ensure that the study of our woodlands and savannas, they are not done in isolation, but they are integrated along with other aspects of the environment or of the broader landscape, of the broader ecosystem. I've also been able to see and experience what others feel and how other views that come from other disciplines and specialities. Finally, while we can not fully understand what Africa's future ecosystems will be, it is my belief and my understanding that it is at the intersection of different systems and different specialities where new solutions can be birthed, which will enable us to manage our future ecosystems with respect. And I'm happy and delighted to be part of this collective, speaking from the woodlands and savannas perspectives and their growth, contributing to the broader picture of our systems in Africa. Thank you.
Thank you so much, Tatena. That was great. And last but not least, we have Mohammed Amani to come up. Amani, I know you. I am going to come and give you a hug at exactly 4 minutes if you haven't stopped talking. Thank you.
That's good. Thank you. Hello, everyone. As Laura said, my name is Mohammed Amani. I'm from Ghana, and I teach at a university in Kumasi called Kwame Nkrumah University of Science and Technology. And if you see the picture down there, that's what I'm really interested in, the forest savanna dynamics. I'm going to go really fast because I've been given only 4 minutes. But actually, unlike Tatenda, I have a very unbelievably weird background. So I started my career in forest certification and sustainability, spent most of my early years working in the forest reserves in Ghana, auditing timber companies and engaging with local communities, and trying to convince them about the usefulness of sustainability and certification. When you grow up in Ghana, you are told that there are a lot of dwarfs in the forest. I walked through all the forests in Ghana. I didn't find any. So I decided that, maybe it's time to go and do something else. So I went to Netherlands to study advanced forestry. And once I'm there, everything changes. I had a couple of classes where I read about fire ecology, tree-grass coexistence, and then I realized, I really love this stuff. you know, I told you I'm from Ghana, right? But actually, my dad is from Niger, so maybe it was already in my DNA from the beginning. I didn't know. So I got excited, and needless to say, I did my master's thesis looking at the vegetation dynamics of the forest-savanna transition zone in Ghana. Finished, the next thing I know, I'm back in Ghana and back into forest certification again. You know, they're saying about old firewood catching fire very easily. This time not for long. Next you know, I'm already going back to China to do a PhD during the Ebola outbreak. So you can imagine what I had to experience. And then my PhD takes me into trade-based plant ecology. So if I say my background is weird now, you understand. So I moved from forestry to savanna ecology to trade-based plant ecology, looking at how spiny plants grow and defend themselves. So I come back to Ghana in 2020, during the outbreak of COVID. So imagine coming from China back to Ghana in the COVID period. And I was wondering, what am I going to do with all this disparate background? And that is when FIFA happened for me. My first assignment with FIFA was to draft a technical report on how to enhance climate actions on land in Ghana. It was a good opportunity, but also very challenging, because quite quickly we just realized that there's not enough evidence base to even to draw on. So I did what any researcher would do, build up a team, 2 Ghanaians, 1 Beninois, and 1 Ethiopian. And then we were all early career guys, so we struggled a little bit. But to cut long story short, we were able to put together the first Agnes evidence base and also completed a report. And during that time, I became acutely aware of the issues on climate actions in savanna landscape. I had, like I said, returned to Ghana, and I was already also reading the landscape in Ghana and seeing what was happening. So as if I had not had enough trouble already, I decided to start something new in Ghana through the support also of what I got from FIFA. So I established my research lab called the Plant Ecology and Nature Conservation Research Lab. Here I work mostly with really unbelievably smart undergrads and early career guys. We collect data, we synthesize information, and we are attempting to build collaboration with policymakers and managers towards bridging the science policy in Ghana's savanna. Recently, we have attempted to update the Agnes evidence base, and very soon we'll be done with that, and it will feed into the FIFA African Data Drive initiatives. I'm hoping that as FIFA 2 comes along, there will be more support for us to really get involved into trying to changing the narratives from the ground up. And last, this is my first ORC, but I just realized, oh, I'm an endangered and rare species because I'm the only West African that is here. If you're from West Africa, please sit down. Don't steal my shine.
Thank you so much. The threat of the hug always works. It's one that I keep in my back pocket. So now you've heard individual stories from researchers and how the work that they've been doing, as you can see, has not just been about the output that they have, but also the people they've been working with, the labs they've been able to establish, that sort of real policy interface that they've been able to pull together on the ground. We're now going to go to the next level and have 3 presentations, again, very, very short, just talking about some of the synthesis that has started to come together through the FIFA program, how we've been able to draw on these different data threads and to have 3 very, very different kinds of outputs. So again, it's my pleasure to ask Sally to come up on stage to talk about the landscape decision dashboard. Thanks, Sal.
Thank you. Thank you, Laura. Just to zoom in on Carlos's amazing slide again, there's been a bunch of outputs. We can't talk about all of them. We're going to zoom in on a few. But the landscape decision dashboard, I think, is something that's been quite important in that it's really one of these things that's integrating the data people like Tatenda, like Robert and Francis here, who are producing data on carbon and biodiversity and herbivore impacts, with the people who help us think around what is a preferable future and how do we help people design preferable futures. And it's also a collaboration with Rewild Capital, and I'll explain to you that in more detail just now. I think we've heard a lot in the last day or two about the challenges of people having different visions about what they want their land to look like. On the right here, we have the Mutinondo Wilderness Area in Zambia, where I was a tourist with my kids a few years ago. not an animal to be seen, but very beautiful. And then the same ecosystem, some people would like to have pastoral systems in there with cows. And my colleague Alicia from Tanzania is helping us to engage with the tricky issues between the foresters and the pastoralists in these ecosystems. And then there are other people who like, well, cows aren't like a natural herbivore. We need to replace them with wildebeest. And there's very contradictory views about the same ecosystem. So that's what's preferable. We disagree on what's preferable. We're also not always clear about what's possible. This photograph was taken by Stefan Woodbourne for me when he was at Gorongosa. Everyone there agreed they didn't want to have fire in the ecosystem, but were they able to keep fire out? No, because excluding fire from that system is not possible. So even you have to challenge our visions for the future with our process-based understanding of what actually can work in these ecosystems. Finally, there are people who like tall trees. When elephants knock down the tall trees, we accept it. When humans cut down the tall trees, that's called degradation, but you end up with very similar landscapes. We need to embrace all of this complexity. So how are we going to do that? We've got this landscape decision dashboard, and the audience is really anyone. It's designed to be working with landowners who want to know about the current state and the desirable state of their land. But we imagine that you could engage with tourists, with school kids, with anyone about what storytelling about where Africa is now, about how Africa looked in the past, and about how we could look in the future depending on what we value, and to create a tool for us to have these discussions. The scope is fully scalable. We are producing data and models at the scale of the whole continent, but you could also do it in your backyard if you wanted. And the idea is that Laura and her colleagues could, if they wanted to, put it in their backpack and go to the middle of nowhere to a small village in the Lua Plains in Zambia and use this tool to help have conversations with the people they work with. But we also own discussions with people at the Digital Dome about putting it up on the huge big screen that WITS has been developing and enabling school kids to have arguments about whether they want elephants in their village or not. I'm not going to go into details of our approach, just to say those 5 things are fairly novel in terms of these sorts of tools, and I can talk to you about them afterwards. But basically what we do is we quantify the current ecosystem state with great detail. We identify a preferred ecosystem state, and we identify one as ecologists, but we also allow the land users to put any state that they would prefer into that. So there's the option for different people to put in their different preferences at that stage. And then we evaluate the consequences of that intervention, and we cycle and we discuss it. At some point in that process, our fantastic Rewild Capital colleagues take all of those models and really use them to help the landowners find ways to fund and make their preferable state possible using the finance that is available. So it really is a very important collaboration for us. I'm not going to spend long just to say there's a lot of data. It's been amazingly rewarding to realize how much data we have. And we have an entire kind of product which is just highlighting for the world. There's a lot of great data in Africa if you know where it is, and here it is, and we're bringing it all in to be used in this decision tool. We've got a couple of really important case studies proving that this works. Together with Rewild Capital, we're running these tools in Golden Gate National Park, in Marakele, in Tswalu, really helping to work out, this is your reference state for grazer biomass. Your grazer biomass is 3 times what we think your reference state is. What are your options to change that? And what will the consequences be for the system? So at the moment, it's all in the data analysis stage. We have all the models. We haven't made the fancy dashboard yet. This is just a vision of how we want our dashboard to look. But the idea is that it's going to be really user-friendly. Someone could pull those little toggles and watch in real time what happens to their soil carbon for the site that they're interested in somewhere in Africa. And I'm going to hand back to Laura.
Thank you, Sal. So when the clicker becomes the talking stick, right, that you're only allowed to say something if you have it in your hand. It's now my pleasure to invite Kim Zola, who's going to talk to us about the Africa roadmap that has been keeping us up late for many nights. But please, Kim, over to you.
Thank you. Hi, everyone. As Laura mentioned, I'll be talking about the African roadmap. And fundamentally, what the roadmap is a framework for implementing natural climate solutions with a really fundamental question, which is how do we implement natural climate solutions in Africa that both serve development goals and also contribute to global climate policy? And this is represented as a document. So as Sally mentioned, this is one of the major outputs. This is represented as a technical document that enables decision makers to strategize ways to implement natural climate solutions that both mitigate climate change by increasing carbon sequestration, but also, and critically, promote non-carbon benefits. And when we talk about non-carbon benefits, we refer to things like biodiversity, livelihoods and well-being, food security, and water security. And this journey toward developing this really important roadmap has been quite a long one, as Lara mentioned. It's sort of started when we helped prep Africa's regional COP27 position, and with the help of Armani and Ibukun, who's our collaborator with IUCN. And we strategized in a way that enabled us to open doors to really make a difference in the climate policy space. And then about 2 years ago at this very conference, OGRC introduced us to Conservation International, which enabled us to collaborate on this roadmap along with regional partners like the African Group of Negotiators. And this has been a really interesting journey getting us to the point of producing this document. Just a few lessons learned. Conservation International is a global NGO based in the US. We were really keen on bringing forward the idea that African solutions need to be context-specific. And instead of approaching natural climate solutions with this kind of global north perspective that planting trees is this panacea to mitigate against carbon as, you know, as the major effort, we really pushed this narrative that people need to be front and center of this conversation. And this is especially important on this continent, where about 60% of people are reliant on ecosystem services for their well-being. And so this means that any climate solutions that we implement need to serve direct benefits to the communities who rely on these ecosystems. And we produced a document which we're really proud of. We worked really hard to push our narrative by mobilizing partnerships across the continent, getting African-specific data and contexts integrated into the roadmap. And we just had our soft launch at the African Climate Summit last month in Addis, which was amazing and really well received. And then just in terms of use and implementation, it's quite a busy graphic, but just to say that the most important sort of way to catalyze this roadmap is to identify that the regional, global, and local stakeholders need to be very well integrated, and these need to lead to actions that are informed by the values of local land users. And importantly, these need to be able to facilitate policy transformation, nature finance, and enable local users to use the environment in a way that doesn't hurt nature. And this enables us to protect, manage, and restore the landscape in a way that's sustainable in the long term. And we're really looking forward to the proper release of it. And yeah, thank you so much for your time.
Thanks so much, Kim. I'm now taking the unilateral decision to cut 1 minute off all of the subsequent presentations, so we do have time for talks. We're going to spice things up a little bit now. We're going to have a 30-second intervention by Mulako Kabisa, who's going to just explain a little bit of the background behind the video that we're going to be sharing. Mulako.
Good afternoon. Good afternoon, everyone. So, African Anthology is part of FIFA, is the storytelling side. What are these stories that we developed from the futures visioning exercises that we had and conversations with local communities and indigenous peoples? So for this presentation, we're going to talk a little bit about the story that was developed by Ekari and Muti with the Mzimba people of Malawi. So I invite you to listen to our conversation and get to know a little bit about what we're doing.
Thank you, Ekari Muti, for joining us today. And so it's been 1 year since you wrote Mombera Rising. Considering the focus of FIFA on African futures, what still stands out to you about the process of writing these stories and just reflections on your experience? Let's start with Muti.
Thank you. Hello, everyone. My name is Muti Shema. I'm a speculative fiction writer from Malawi and one half of the team that created Mombera Rising, the writing team that created Mombera Rising. And I can't believe it's been more than a year since we actually wrote the story. It's still fresh in my mind. And there are a lot of reflections I still have and that still sit with me more than a year on. And I think the one that really stands out was a conversation that we had with the indigenous tribe, the Ngoni tribe, when we were doing the research for Mbombela Rising. And what I remember was we posed a question to the community. And the question that we asked them was, what does the future look like in 100 years? And there I was all excited that we're going to hear stuff like robots and AI and, all this, or, maybe flying through, rocket ships to Mars and things like that. And to my surprise, everything they said was incremental. So it's rather like, for example, the replacement of physical money would be mobile money, which is something we already have. So there were lots of things that were purely incremental, which was a bit frustrating. And I was, to be honest, a little frustrated because I expected a little more. And then during our conversations with the team from WITS, we decided to come up with a different question. And the question we then posed the next day, which was a little different, which we refined, was if you are given the agency to decide to run your society, how would you run it? And that's when we got a lot of content. They spoke about how they would do governance, how they would deal with all sorts of social inequalities. They had solutions to various things. And the thing that we noticed as they were speaking was that a lot of what they were saying, and they didn't say it in these terms, but what they were saying was more related to really going back to where they left off in terms of their own cultural evolution before Christianity, before colonialism, before enslavement. They wanted to start from there and sort of evolve according to their terms. And that was not what we expected. And it was very clear that the future that they saw was more cultural, not technological, which was my bias as I went into that particular space. And I think that's the thing that remains with me to this day, that for the indigenous tribe of the Ngonis, the future for them is more cultural, not technological, as we would assume because of our kind of Western conditioning.
Thank you for that, Muti. Carrie, anything stands out to you still?
Sure. Hi, it's Harry Mbundula Chirombo here. The second half of the Mbombela Rising authorial team. And I would concur with Muti as well. Like it was something that challenged our expectations, and delving into the cultural side. Like my stories were really focused in on that cultural side. And one of the biggest challenges, I think, was the perception of gender dynamics in the future, where within that culture, they had polygamy as something that they wanted to take, forward as into the future as part of their culture. And so that, regardless of my personal views about it, I wanted to make sure that I represented the vision that they had in mind. And so, my story wove that in a way that I hope was really representing what they had envisioned. And just to build on what Muti said as well, it was their future, Western future was more about like how much further we can go, how much higher, and all of that. Whereas for the Ngoni people, their future was about reclaiming their past, with culture, which shows the difference sort of between, the colonial perspective versus the Western world perspective. So it was very interesting overall, and it was an exciting and challenging project.
Just a little bit of insights from sort of varying different components of the FIFA project. Everything from discussing futures and being able to just sort of wrap those into these data sort of decision-making tools. And we've really had this weaving together of a variety of different components. And so having finished, I think we were going to have our journey behind me, but that's absolutely fine. It allows me time to move on to Odi, who's going to talk about, having heard about this sort of FIFA 1, the journey that we've been on, what would we like to do if we got a FIFA 2? So, Odi, over to you.
Yeah, thanks, Laura. So we learned quite a bit in the last 4 years of the project.
And so we're already starting to think about what would we do next based on what we've learned so far. So Sally already presented that we've built quite an integrated network of different kinds of stakeholders on the continent. And we think, based on the trials of engaging with the African group of negotiators, trying to get some of this work into the policy space globally and also on the continent, that in doing the second round of this, we would want to build on that model, get more involved in the policy space, as well as organize around other things. So there's a lot of, in the international assessment processes like IPES, IPCC, often African scholarship is very underrepresented. Not only scholarship, but African voices in general are quite underrepresented. So organizing comment teams to really try and bring the context into those conversations. There's a few other things. So Sally's already presented a lot of data sets that we've really looked and found that there's quite a bit of data on the continent. Often we hear stories that there's not enough data, but our experience is that there's quite a bit of data that's unused. So in the next version of this, we would want to fast track and really try to apply this. So now that we know it is there, how do we use it? In terms of the futures thinking, it's really about, I think, what Belinda was presenting yesterday, that the version of the future that thinks about people with nature rather than trying to pit this to you. I think it's often the case that when we think about the future of not only this continent but everywhere, that we think there's a future that has nature there and people there, sort of this land-sparing, land-sharing conversations. But I think if we start to think about alternative scenarios that position this nature with people, we think there's a lot that can be said there based on the experience from this project. And another thing that we did quite a bit in this project was also focusing on the nature finances. So often when you look at the why biodiversity indicators are not achieved, there's of course a lot of reasons for that. But one big reason is also that financing is always a problem. So what we did in this project, we focused on understanding the financial flows. In terms of, in particular, we focused on the public finance flows. And what we would like to do is to expand the data sets, because after the publication of this work, we got approached by a lot of people working on or holding a lot of interesting data that we couldn't access before, that we think would be able to expand the analysis to look at more countries on the continent, as well as do some work that focuses on private sector, which is something we weren't able to do in this case. So out of this, we think the two main clusters of interest for FIFA 2 would really be to think about decision tools. So Sally presented about AD, which is this landscape tool that was developed. So the AD Plus would really be making it more user-friendly and more basically getting it to the laptop, as Sally was saying. But this is also harnessing all this other information that we have now gathered here and try to integrate more of that in there. And so that will be also focusing on things like process modeling and amplify more African biodiversity in this. Another cluster that we are really interested in, and it's got a big scary name of rethinking economics, and I think for a lot of people, you look at that, you think, how on earth? And of course that's true. How do you rethink that? But we have three specific things that we want to look at in there. One is just exploring this idea of the care economy. That I don't know if Siobhan is here, but there's someone who can speak very well about this concept. I've already explained a bit about the nature financing component, which is that until the recent geopolitical issues, there was a lot of information and a lot of promise of big funds flowing into the continent, both for climate and biodiversity. Eventually, those conversations will come back. Maybe they're now in hiatus because of what's going on, but they will come back. And so if they do, how do we make sure that the funding that flows in does the right things, basically? And finally, we're going to be doing some integration and synthesis and really trying to integrate a lot of this information into these discussions and negotiations that we build with the stakeholders in the that I've showed in the previous slide. But I'm under pressure for time, so I'll give this back to Laura.
Thanks so much, Odi. So I had promised the Slido link to go up at every point at that, but I don't think it came up. So here is your final chance, please. If you want to ask us questions, give us comments, please put up the QR code and start to give us some questions, because we now have 10 minutes, and we do, for what we want to call the interrogation session. So this is a chance for everyone really to lay into us, to ask us, why were you doing this? What would you like to do? Why weren't you doing that? Why are you only focusing on this going forward? And of course, I think, whilst everyone is thinking through this, and we're going to have some of these sliding through in front of us, I believe that Jonathan, yes, wants to kick us off with some really hard questions, which is why I'm really grateful that I'm only facilitating and not answering any of them. But whilst the mic starts to make its way to the front over here, I would also just like to ask all of those who are involved in FIFA but who aren't up on stage, please to stand up. I think there's a cluster of you over on this side. Yes, stand, please stand, up, up, up. Everyone, Siobhan, just to say, this has been a collective effort for everyone. I know Siobhan is around somewhere. So thank you so much. This is also all about you and those who aren't physically present too. But right, and now Jonathan has a microphone. So over to you, Jonathan.
Hopefully this actually perhaps is difficult, perhaps is less difficult. But firstly, I think sitting in the audience, listening to what you're doing in terms of the integrated approach that you are bringing to this, that needs to be celebrated. It's absolutely critical in any integrated solution. So congratulations. Now to the more difficult part, and I'm going to start by paraphrasing Einstein. And instead of saying same data, and I'm going to say doing the same thing and expecting different outcomes is tantamount to insanity. And we as human beings are incredibly good at doing the same thing over and over again. And that leads me to really thinking about how we do science. And we love longitudinal studies. They give us really, really important and effective data, but what they don't do is address urgency. And what we know with the climate challenge we have today is urgency is key. We can't afford to do things in these very long, longitudinal ways. We need to find shortcuts to do this more quickly. So there is challenge number one. What is your way to do the shortcuts more quickly? And so I thought about what is the answer that we're looking for. And the answer we're looking for, I believe, is this unique integration between conservation and ecology, our community, and sadly, capital. And we referenced the inability or the need to access money. And I just want us to think about that briefly. And the reality is we spend a huge amount of time in these forums talking about philanthropic support. Philanthropy represents less than 2% of global capital flows. So we want to fix the planet on less than 2% of global capital flows, and we're going to leave the other 98% doing bad. That sounds like a good plan. So the question is, how do you intend to make the 98% work for the good of the planet? And what kind of research and programs do you need to put forward so that that 98% can continue to make money? So that's the goal. How do we find that integrated approach? And two, how do you critically enable capital to support both conservation and ecology and the community? And so looking to the, now I begin to speculate, and these are the tough questions. The best filter process in business, now business isn't the be-all and end-all of anything, is the venture capital world. And it looks to filter programs on a logarithmic basis. And so one of the challenges for your science is how do you get to a logarithmic approach to science where you can exclude losers more quickly. And so therein lies another challenge to you as a panel. I said this wouldn't be easy, so I hope you're enjoying that. And so then finally, if you're able to do that, how do you move the dial? How does it manifest in more capital flowing to sustainable conservation and ecology preservation that does support the community? Can you point to living examples of that goal being manifest? And then ultimately, where can we begin to see that not only conceptualized, your roadmap, your what do we call it? Target, the picture that you had up, your plan, but actually manifested in delivery. And so the final thing is, how do we get all of this brilliant thought into real change on the ground? So I hope that Lara, sort of, as you say, maybe you don't need to answer it, everybody else on the panel does, but thank you, really appreciate the opportunity.
Sure. Thank you so much for that, Jonathan. And I think that really has set off for a real interrogation. I also see quite a few really good questions coming up in the chat, so I'm going to take the liberty of actually pointing out for some of us some questions that I think we can answer. And I think I'm going to start off for the last person to answer, actually, Sal, moving the dial. I think that last point of Jonathan's, how are we actually taking what we're learning and actually seeing impact with communities on the ground? So I think something that you can think through from that perspective. Kim, for you, that one of the questions that came up is, what if people don't actually have preferable visions? What if these nature's contributions to people component isn't actually part of what's possible? Sort of how are we navigating that from a data perspective? Odie, you're always going to get the finance. I think Jonathan is also sort of mobilized on this 98%, right? Not just the finance that's been flowing towards. How do we actually talk about this access to capital? If you could please talk to that. There's been a sort of a point on more indigenous local knowledge that we need and better integrated, and I might say better woven knowledge. I think I might ask Batlelifi and Mulako for both of you to sort of think through how we can actually operationalize that more in the next phase. Armani, there was a sort of a question here on Agnes not just being an evidence base, or what do we mean by that? Potentially you could expand a little bit more from that side. And then to Tender, there was a question how we've actually been leaving out some components, particularly around water, and I just want to say we weren't able to sort of present everything that had happened across FIFA. We actually have a really big marine and ocean component to the work we're doing. But sort of maybe you can talk about some of the access, coming from what you were saying, your story, that's not just focusing on trees, actually this expanded understanding. We were not just thinking about carbon, but we're also thinking about water, etc. dynamics, and sort of maybe what you would like to see going forward. And I am not going to answer anything. I'm going to hand over to Sal, and I think we'll just move this way along the panel, and I'll see if anything else comes up, and I've got a final wrap-up question for you all. Sal.
Great. Thanks. Yeah, I'm going to start with the question about shifting the dial, because that's really the urgency. I'm going to start by saying I do think there is a lot of stuff happening on the ground. Like, one of the concerning things is that everyone is now really urgently seeing they need to do things. So there's a bunch of stuff happening all over Africa. Some of it good, some of it going to achieve some good things, some of it funded by venture capitalists. But so I really feel in the last few years the scientists have got with the program in terms of action now. But we still do need some advice and guidance, because a bunch of the stuff that's happening is really a bad idea and going to end up with undesirable, perverse outcomes. So we are engaged in some actions on the ground, and we're engaged in building the knowledge base and learning by doing. Because like we say, we want to work with what's going on. We don't want to stop everything that's going on. We want to try guide it into directions where there's more consensus about the fact that it's going to be a good outcome, where there's a fewer trade-offs as possible. But that's not enough. We really need to shift the dial, and for that, we need to challenge, and that's going to take some time. So that's why we're doing stuff on the ground with everyone now, but we are also taking these back routes to really rethinking how we fund conservation, but not only conservation, how we live with our ecosystems in a way that is sustainable.
And I think
so,
on that...
Sorry, just to say, like, we're working with some economic colleagues around these ideas of a care economy, like how to value the way that people care for nature and give it some kind of economic meaning. As Odie says, we've sort of engaged with how national governments fund conservation. Now we're moving on to thinking about the private sector, which is a whole different kettle of fish. And so I think it's about working at both scales. Action on the ground, learning by doing, and pushing back on the way the funding is coming in the first place.
Great. Thanks, Al, because we are out of time, but I am just going to let everyone sort of quickly answer the questions. I think this also talks to that logarithmic approach to science that you were mentioning, Jonathan, right? To put on a complex systems nerd hat, it's about this integrated sort of emergent outcome that you see from all of these different components. And I think this next phase is challenging these paradigms, rethinking economics. So I think that's a good segue, Odi, to talking about the finance really quickly, please.
Yeah, so yeah, thanks. I think this is a very important question because indeed, if you look at the framing of capital as, nature positive capital versus nature negative capital, you see that quite a lot of it is sitting in the private sector, and so for me, I think the mobilizing comes in two ways. So if we think about capital as wheeling capital, which is people who are saying, "Tell me what to do." At the moment, unfortunately, they're being told by climate cowboys, people who are trying to implement quick solutions, single-issue solutions. And I think the wheeling capital is one that is currently a low-hanging fruit. And then on the other side, you have the sort of the capital that's waiting to be convinced. And I think that kind of capital, the language that he speaks is the language of green bonds, the language of offset mechanisms, and that's going to first use the usual economic instruments first before we get to get it to the point where it's wheeling. But this is I think there's a lot of hope, I think, and promise. And when you think about the coalitions of private sector, there's a few organizations and coalitions that are forming now that we can certainly tap into. But I know that you want me to stop.
No, thanks, Odi. That's perfect. Bathalifi, African voices, actually, indigenous local knowledge. How do you see this program being able to lift those up?
I think a lot of it actually begins with the kind of research tools and methods that we use. It's important for us to not just parachute ourselves as researchers into the respective landscapes within which we work. It's important for us to build within those networks and rapport that exists within the ground. And it's through these, the process of building these relationships that the ground as it exists, the stories that exist at grassroots then come up and affect systems transformations. It's not an easy process, but it's very important for us to really build those genuine connections and effect change.
Thank you. Malako, how do we get more indigenous local knowledge in?
First of all, we already have quite a bit of evidence from very different places that have never been spoken to before. We have the opportunity to look at the pathways that they propose. That may be very different from what we know as conventional knowledge on how conservation, but climate action should happen. And I think that's an opportunity we can leverage into the next step on the how.
Tatenda, moving into sort of different spaces, not just carbon, thinking about other aspects. What do you see for the next round of FIFA?
Yeah, so this week have explored many different aspects, like what Kim alluded earlier on, that our products, they are not only directed to carbon, but they are also looking at non-carbon benefits. That means we are looking at the use of the landscape holistically, looking at different interests from all that perspective, and trying to strike a balance. Actually, that's the perspective of the decision tools that we are looking at. That when a landowner looks at it, he should be able to make decisions based on their interests, but also striking a balance on the systems that occur within their landscape and be able to make a decision on what is of best interest going forward.
Yeah. Perfect, thank you. Armani, working with Agnes.
Yeah, so the first phase of Agnes, what we were trying to do was actually to identify the trade-offs in relation to climate mitigation, biodiversity, and livelihood. And that is very important because you see how livelihoods are quite significant in Africa. So we had to do that. But actually, once you build the data, what you realize is people interact more with narratives and stories. And a lot of these climate actions are implemented in Africa by NGOs, mostly working with the communities. So we have to, and I think FIFA has done a bit of that, and that's why we partnered with Agnes in the first place, because they negotiate more of these. But we have to tell the stories and the narrative from the data to a much wider audience to really get our stories and message across.
And just to clarify for those, Agnes refers to the Africa Group of Negotiators, Expert Support. So those who are actually sort of supporting our negotiators when they go to these intergovernmental meetings. Kim, what if people's visions aren't preferable? Destroying things.
I didn't quite understand the question.
What if sort of the biophysical possibilities aren't actually preferable, but people still want to do something? How do we navigate our own inherent biases?
So I think part of the way the question was framed was what if natural climate solutions aren't needed in a system? And ultimately, our continent is not a global emitter. We really need to focus on adaptation, and part of adaptation is addressing the fact that communities need to benefit from whatever intervention we implement. And so potentially there are interventions that aren't preferable for people, but we need to identify the benefits that directly contribute to people's livelihoods and well-being and make sure that those are the ones that are accounted for in the trade-offs that Amani alluded to.
Cool. Thanks, Kim. A lot of really good questions touching on sort of Eurocentrism, colonialism, how we can actually capitalize sort of the voices that we've heard. I am going to answer the final question, and there was a really good one on what gives us hope for the future, and I'm going to answer on behalf of the entire team, and it's projects like FIFA. It's recognizing that Africa does have the data that we can put into these intergovernmental processes. We are leading one of the most important synthetic, interdisciplinary and transdisciplinary projects that I've seen globally, right? And we're operating it from the local level all the way into the regional sort of continental perspective. We're being taken seriously in the global sphere. I think we're publishing in Nature, for example, sort of they're taking our commentaries on board. And for me, that's what gives us hope. As researchers, that we can actually provide the evidence base, the pushback that we need for the new narratives that are going to take us onto a more preferable, more prosperous future for people and the planet, starting from our African continent. So on that note, thank you so much, and I think I'm going to hand over to the next proceedings that will emerge from this. Thank you so much, everyone.
Danny, must I make my housekeeping announcement? I was supposed to make a housekeeping announcement about the posters. Were you going to do that? Apparently, everyone who produced the beautiful posters that I have had the privilege of judging over the last few days, there is an A0 version for you to take home. Anytime you want it, you must go to the reception, is that right? And you can take your beautiful poster and use it and put it up and spread it to spread the word. Thank you.
Thanks, everyone. So if everyone could just move down at your leisure just in the next half an hour to the bottom with the dining area for the JWO award. Thank you so much.